Aviation system, which will be a 5,000 tonne per year plant, and that will be a very faithful reproduction of the larger scale plant that we're going to scale up to. Then we're going to scale up to our 30,000 tonne per year commercial plant, where we're making fuel, selling the fuel and making money for the business. Jet fuel is a tightly regulated product. In our case, we have to meet those requirements, but we also have to meet the requirements that it's sustainably produced.
Reducing global temperatures and protecting our planet is a key generational challenge. Our mission at Aviox is to deliver the world's most technologically advanced refinery making sustainable aviation fuel. We believe that the plant will be highly profitable due to the very low cost of the waste materials as input material. We need the resolve and the capital to make a radical shift within our economy to make it modern, circular and sustainable. This is a once-in-a-lifetime opportunity to join a new wave of clean tech companies developing clean, green and sustainable aviation fuel, and it's a privilege to be part of it.
Airlines and aircraft makers are desperately searching to reduce their climate impacts. CO2 emissions amount to about 2% of the global total and 7% in the UK, and are increasing. But there are other impacts, such as the damaging contrails. Back in 2011, I was granted a patent for a novel way to generate power and hydrogen from hydrocarbons. Highly efficient fuel cells and electrolyzers make this possible. Using this patented process as a front end to a more conventional gas to liquids process, we can turn all sorts of worthless waste into high-value fuel, help clean up the environment and solve the problems of disposal in one fell swoop.
Making sustainable aviation fuel in sufficient quantities is a massive chemical engineering challenge. We've already started building our bench scale system, which will just prove the concept. So we'll take some waste, which is our feedstock, and we'll create some fuel to demonstrate that the process actually works. The key step is then our demonstration system, which will be a 5,000 tonne per year plant, and that will be a very faithful reproduction of the larger scale plant that we're going to scale up to. Then we're going to scale up to our 30,000 tonne per year commercial plant, where we're making fuel, selling the fuel and making money for the business. Jet fuel is a tightly regulated product. In our case, we have to meet those requirements, but we also have to meet the requirements that it's sustainably produced.
Reducing global temperatures and protecting our planet is a key generational challenge. Our mission at Aviox is to deliver the world's most technologically advanced refinery making sustainable aviation fuel. We believe that the plant will be highly profitable due to the very low cost of the waste materials as input material. We need the resolve and the capital to make a radical shift within our economy to make it modern, circular and sustainable. This is a once-in-a-lifetime opportunity to join a new wave of clean tech companies developing clean, green and sustainable aviation fuel, and it's a privilege to be part of it.
Okay, morning everybody. We'll just, a few people still coming in, but so welcome everybody, and particularly to those of you that are just joining us for today, and I hope you found yesterday enjoyable and useful for those of you that were around yesterday. So today we've got a whole selection of topics today and in parallel sessions as well, so lots of technology focused presentations. So in this room we've got our plenary sort of keynote presentation, to start with from British Airways, and then we'll get into the showcase of the DFT projects. And then at 10:15 next door, it will be the integration of SAF in the SAF supply chain at scale panel discussion, which is sponsored by Johnson Matthey. So that'll be at 10:15 if you're interested in that. First of all, I'm going to hand over to Tom Byrne, and he is Head of Net Zero at British Airways, who will give our first keynote presentation for the day. So thank you, Tom.
Thank you, Michelle, and thanks everyone for having me today. Really happy to be here to talk to you about British Airways, our strategy, Be a Better World, SAF and how it fits into our long-term net zero programme, and then also what we're doing around SAF to accelerate our usage of it in regards to reducing our emissions in the short term, medium and long term. So myself, I'm Tom Byrne, Head of Net Zero and Environment for British Airways. My objective is literally my job title, to get to net zero. It's something that it keeps me very excited every single day going into the office. My team not only look at net zero and accelerating our work towards that, we also look at wider environmental issues, compliance, resource management, waste, and we might talk about a couple of these things today. But the focus of today is obviously net zero emissions, and particularly how SAF fits into our programme. I just want to give you the kind of wide lens view first before we focus in on how SAF fits in. And this is Be a Better World. So we've got three pillars of our strategy. We launched this in September 21. And sustainability at British Airways, it's not just climate change. It is a huge array of different topics. So within people, it's about creating this informed, diverse, inclusive workplace where people have the ability to show up every day and perform well. We've got over 30,000 staff members all across the world, some of which are flying right now at ops bases, many of which then come to an office. So engaging these folks just generally is really important, but from my perspective is engaging these folks on sustainability is also extremely important as well. So that's the people strategy. Responsible business, it's all about doing things the right way, reflecting our values, our purpose, and investing in the communities that support us. This could be shown through our work with Comic Relief, for example, raised over £28 million with them in the last 10 years. Our work with the Disasters Emergency Committee, over £2 million raised with them over the last couple of years as well. So really engaging communities that engage us. But this is where I spend most of my time. So I work within the planet function, as you can imagine from my job title, and it's all about urgent action towards net zero. But it's not just climate change, it's the respectful use for resources and the higher standards of environmental protection as well. In terms of some of our highlights in this pillar from last year, well, we released our last annual report in March. It's available on our website if you wish to learn more. But I'm just going to run through some of these highlights, as I saw as highlights from last year. And SAF kind of runs through a few of these. So we reduced our carbon intensity again by 3% versus the year before, which is a total of 10% down versus our 2019 year baseline. I'm going to talk to you a bit about why this is important and how SAF has played its role in driving that result. We received the IENVA certification as well for our environmental management system For us, this is really important because it's about doing the basics. It's making sure that our supply chains are being assessed effectively. We are doing things at head office, in-flight operations, in our engineering bases with the higher standards of compliance. And that mindset really then continues through to how we work with supply chain partners, including SAF partners and others, in regards to making sure we're doing our due diligence to best practice. On SAF, well, we increased our usage by 5-fold in 2023 versus the previous year. This is a great statement to say, 5 times the wonderful thing, but we still only have about 1.1% of our fuel usage as SAF as of last year. So 5-fold increase is wonderful. We're doing a lot more, obviously, but we're still quite far away from our target of 10% by 2030 and from where we need to get to in 2050. But we're making good progress, and we'll go into some details as to how we've done that. Carbon removals, I think, is really important for us as well. I'm going to talk to you a bit about our general program to net zero and how removals fit in. And last year, we launched a new collaboration with a few folks that we'll talk about. And I think it's really important to understand that, while SAF is really important for us, it won't get us to the full net zero picture we need. So we need to be engaging in these technologies as well. And this quickly, again, it's not all about climate change. For us, we're investing a lot of money in reducing single-use items on board, tackling food waste, and making sure that environmental management runs through our business. And finally, we are modernising our fleet. 11 new aircraft delivered in 2023, and these aircraft are obviously more fuel efficient and therefore helping to deliver our goals as well. Okay, I want to take a step back just to give you a real picture of our emissions and how SAF is helping us to deliver against our reduction goals. This is our pie chart of emissions broken down by scope 1, 2 and 3. Now, I've worked in many businesses where this has been the complete inverse, where scope 1 and 2 has been relatively minor and 3 has been pretty big. British Airways is not unique, but it's one of those cases where our scope 1 is by far and away our largest contributor to our greenhouse gas emissions. 82% is primarily burning jet fuel. There's a bit of ground vehicle usage in here, a bit of gas boilers in there as well, but primarily it's jet fuel burning. Scope 2, as you can see, is very, very small. In comparison, 0.2% electricity usage in our buildings and some of our vehicles. And our scope 3 makes up the remainder. And what's interesting from our scope 3 is that actually the majority of this is the production and transportation of jet fuel. So actually, if you look across our footprint, both on scope 1, 2 and 3, it's dominated by our usage of kerosene. So if you're going to start somewhere, that's where you start, of course. And in 2023, our emissions were nearly 18.5 million tonnes, with obviously most of this coming from our scope 1. And this is what our scope 1 footprint looks like over time. And I want to call out kind of 3 kind of stages to this 10-year period. I guess we have the pre-COVID stage, the COVID stage, and the post-COVID stage. So pre-COVID, what you saw was general small increases in our scope 1 footprint over time as the business grew, offset slightly by our emissions intensity coming down. So emissions intensity for us is emissions over passenger kilometres or combined passenger and cargo kilometres. So essentially it's how much we're flying, right? So our intensity was coming down steadily, kind of offsetting some of our growth in emissions, but we were on a kind of a path. I would say this is kind of pre-SAF. So this is really before we had much SAF or any SAF really coming through to our business. You then saw the COVID period where, unsurprisingly, our overall emissions dropped off a lot. Our intensity went up because our planes weren't full. And so, that was obviously the wrong direction we were going for intensity, but good news on gross emissions. And now you're seeing this kind of post-COVID recovery. So what we're now seeing in this post-COVID recovery, something that I really want to accelerate, is this decoupling of business growth from emissions. And that has been driven by emission intensity coming down. So you see here a little kink in emission intensity. That can be, not all of it, attributed to more SAF usage, which is good, more efficient aircraft, more efficient practices, etc. And what we're starting to see now in our COVID recovery is that actually our missions aren't growing in line as our business growth is. And what we need to do is keep that trend going. So for us to hit net zero, we really need to decouple that completely. So our business can continue to operate and grow, but we also need to make sure that our overall emissions are forcing downwards. And you can only do that by getting your intensity lower. So when we talk about carbon emissions a lot in terms of BA, we really focus on intensity being the main metric, because if we get that right, then everything else will follow. And I don't want to be overly basic with you folks here, but this is how I explain things internally. So this might give you a bit of insight in terms of conversations we have with British Airways. And so, like, you know, for us, our Scope 1 emissions, and I know this is overly basic, how I try to get people to think about what we're doing here is most of it is going to be our jet fuel consumption, and most of it, and so we use that as a multiplier, times our CO2 emission factor, which is 3.16. So there's a couple we could use, but we're using 3.16. Which basically means if you burn 1 tonne of jet fuel, you're generally emitting 3.16 tonnes of carbon emissions, right? So when I challenge the senior leaders of the business to say, how do we get CO2 emissions down? And they don't really understand what it means. I basically say, look, it's this really simple equation. What we need to do is either reduce our fuel consumption or reduce the 3.16 number. How do we do that? Well, jet fuel usage reduction is maybe more straightforward. You use less fuel by flying more efficient aircraft, improving operational efficiency, reducing weight on board, fixing defects to make sure your planes are flying at the most efficient, optimum condition, and getting from A to B as quickly and as efficiently as possible. They're all things we're trying to do every single day to bring that fuel usage number down. The 3.16, they asked me, how do we go about that? That's a fixed thing. Well, I say, well, this is where SAF can come in. So we can slowly change the mix of our fuel. We can be using more sustainable aviation fuel in our operation. That blended 3.16 figure comes down. I know that's overly simplistic, but this is how we try to explain things. And essentially, for us to reduce our CO2 emissions, we need to be working on both sides of the equation. We have to be reducing our fuel usage, and we have to be changing that number to get as low as possible. And obviously, SAF with its life cycle reductions can really help us do that. So when we talk about carbon intensity, all we do is do all of these things on that side, and we make sure that our planes are as utilised and optimised as possible. If we get all these things right, we'll see that number come down. And people started to pay attention with this when we actually set this as a target linked to our remuneration. So we have over 3,000 colleagues at British Airways who have part of their bonus scheme tied to this number. And every single year for our carbon intensity, we set a new target. And if we hit it, we unlock some bonus. If we don't, we don't. So that kind of sharpens people's minds as well and gets people thinking, what can I do to reduce fuel usage? Or what can I do to try to grow our use of SAF? So that's one way of explaining how SAF really fits in and how we explain things. And then this is something else that we use. This is our flight path to net zero. So this essentially is where we were in 2019 versus where we need to get to. And I mentioned the idea of decoupling business growth from emissions. I think this kind of depicts that quite nicely. If you look at the top line, it's a very faint grey line above the red chunk. That's essentially what would happen to our emissions if we did nothing and we just grew as an airline at 2019 efficiency. Obviously, this is a fairly simplistic chart. This is not a growth projection necessarily for any investors. This is a depiction of what might happen if we grew at a fixed baseline efficiency, right? So our net zero challenge isn't actually getting from 2019's number to zero. It's actually decoupling that future emission number, what it would be, to zero. And as you can see, over time, that challenge gets bigger and bigger and bigger. So this is where this decoupling comes in. And we have 3 main methods of doing this. And again, I want to talk to you about a couple of them before really delving into SAF. We spoke about this one before, more fuel-efficient aircraft, new aircraft technology, operational efficiency. We know if we're using less fuel to start with, that's a good thing. And we believe this could do probably about a third of our total reductions we need to get to net zero by 2050. The second big thing, that big grey wedge, is SAF. So you can see SAF here is kind of ramping up slowly. We've got a goal set through IAG, our parent company, to hit 10% SAF usage by 2030. Remember, we're at 1.1% now as British Airways. We need SAF to be between 50 and 70% of our fuel mix by 2050 to achieve this roadmap. Hugely important, and so therefore our reliance on this technology is clear to see, which is why we're doing the work we are at the moment. And we welcome all the fantastic work you are all doing to help build this sector and to help build this future supply for us to be utilising to achieve our goals. And then finally, we understand that no matter how much we work with you and work with more efficient aircraft and get SAF on board, it's unlikely to get us to a true zero position. We're very transparent with that. We have to rely on some form of removal to get us to a zero base. Our challenge here is to make that blue wedge as small as possible. We want to be reducing our gross emissions as much as we can. That makes business sense. That's preferential environmentally, but we understand there's some removals as well. But we're also really excited about the prospect that the SAF industry brings to us in regards to removals. David Pangier, for example, talking about biochar. I think you'll hear more about that later. But there's a role we can all play in this as well, and I think it's important for us to acknowledge the role it will play. So before we get into SAF in more detail, I just want to talk about some of the things we're doing to complement that strategy and some of the red and blue wedges. So this is one of my favourite aircraft, not that I'm biased because it's BA Better World livered, but it's the A320neo. It's one of our most efficient aircraft in the fleet. Its numbers look really great compared to what it's replaced. We love them. So our big opportunity here is to utilise more of these aircraft, work with the likes of Boeing, Airbus and others to help them, innovate and deliver aircraft of the future and to make sure we're utilising them as best we can. And that's where our pilots come in. So last year, we trained over 3,500 pilots in fuel efficiency and sustainability at British Airways. They all took it as part of their annual mandatory training, and now we're seeing more engagement from pilots in regards to how they're flying their aircraft and the steps we can take to reduce our fuel consumption. Now, this might be marginal gains, but if we add all these little micro gains up, it can lead to some big savings. And the way I see this in regards to the SAF context is if we can reduce our overall fuel demand, it gives us a better chance of getting our SAF penetration higher. It means we can get to 50, 60, 70% of SAF because we're reducing our demand on jet kerosene. So this is really important for our overall program and hopefully supportive of achieving some of our SAF goals as well. I do want to talk about other technology as well. I know this obviously is a SAF conference, but we are talking about other technologies too. But I kind of want to give the balance view here in regards to we understand that this won't be the solution in the near term and likely for long-haul flights in particular by 2050. And so we understand that without investing and working with the likes of Zero Avia, who are doing amazing work in regards to scaling up hydrogen zero-emission engines, without working with these folks, this won't scale. We want this to be part of the solution in the future, but we also understand that actually for long haul in particular, SAF is the way to go. So it's a blended approach we're taking to this, and hopefully what you see throughout this presentation is that we are trying to leverage a diverse amount of levers, and we're actually partnering with as many people as possible to get to the best outcome. So through Hangar 51, who are IAG's investment and innovation arm, we are investing in Zero Avia. They're doing some fantastic work here. And we're looking for other partners as well across this space to partner with. Again, there's not one solution to the journey to net zero. Hydrogen and other zero-emission flight will play its part, but obviously SAF plays a huge part as well. And I just want to touch upon this as well. It's not all in the air. Obviously, most of our missions are in the air. I've been through that before. But we are also trying to decarbonise our ground vehicles too. And we are utilising alternative fuels in the ground as well. So at the top left-hand side for you is one of our new HVO Bowsers at Heathrow. So we are now supplying HVO fuel to over 700 pieces of GSE, saving, I believe, 6,000 tonnes of carbon per year. And that fuel is actually being delivered by Phillips 66, one of our SAF partners. So we're working with our partners, not only in regards to getting more SAF into our air operations, but also getting alternative fuels into our ground operations as well. We see this as a really brilliant solution, particularly as we transition towards more electric fleet on the ground. As you can see, we have some electric fleet there, but a lot of our kit is pretty big using diesel heavy, so HVO makes sense. So we're not only utilising this technology in the air, but on the ground as well. And then finally, I spoke about removals. I do want to touch upon their importance and how, again, partnership here is really key. I think one thing I'll hopefully take away from this is that British Airways can't do anything alone. It's impossible for us to scale these solutions, invent these solutions by ourselves. That's not what we're here for. We need to work with experts, innovators, engineers, entrepreneurs to achieve our goal. And this partnership is a good example of that. So working with Undo, who are a UK-based carbon removal startup, Curate, who are a carbon removals UK market maker, and Standard Chartered Bank, we've developed a first-of-a-kind financing project where we'll be buying in 4,000 tonnes of removals from Undo, primarily from British removal projects, working with Standard Chartered, who are going to be funding this project as well for success. 4,000 tonnes isn't a huge amount, let's be honest with you, compared to our footprint of 18 million, but we have to start somewhere. And again, we acknowledge the fact that if we need a lot more of this stuff in the future, we can't wait for it to happen. We have to be working with these partners here and now, investing to help scale. And the same goes with SAF. With SAF, we know that we can't just wait for it to happen. We know we have to get involved, and we have to make sure that we are helping to scale solutions, not only in regards to signing long-term offtakes like we have with Undo here, but also by putting our money down as well. And that's part of our SAF strategy, which I'll come on to now. I want to flip back to this because we've kind of gone through the red bar and the green wedge. You can see there's a massive big grey wedge in the middle, and that's why what we're all here to talk about today. I really wanted to give you a sense of how important it is, but also how it fits into our wider flight path to net zero. So SAF, this is a fairly basic slide. I'm sure all of you know all this stuff already. I'm going to put a little spin on things in regards to why do British Airways, why do we like SAF as an organisation? Well, number one, because it can be produced from multiple feedstocks, it's really exciting. You know, there's not just one primary solution feedstock that we need to leverage and everyone's going to be fighting over. It's got a huge capability to be diverse geographically, as well as in terms of technology, in terms of actual material, and we love it because of that. And as you can see from our partnerships, we're working already with a diverse supply chain of production types, feedstock types, because we believe that diverse supply chain is vital to be resilient in the future, but also to scale, you know, the SAF we need up to the levels that we need. So we like it because of that, and I'm sure you all know a lot more about the types of feedstocks we could be using now and in the future, which is really exciting. The only reason why we love SAF is that because it can be dropped in. It's a drop-in fuel, similar chemistry to jet fuel, obviously. Why is that such a benefit for us? Well, number one is that we can utilise our existing aircraft. That makes sense. It means that we can continue to invest in the aircraft of today, knowing that it's got a long lifespan, and we can work with the existing aircraft types and technologies whilst decarbonising the business. It also means that we don't need to invest a huge amount in new infrastructure. One of the step backs of hydrogen, if you think about hydrogen, is you need to produce the hydrogen, you need to then produce the aircraft that can fly it, you need the local infrastructure, the local airports. So that's going to take time. Hopefully we see more of that in the future, but it's going to take, you know, frankly, a lot of investment and a lot of time to deliver that. SAF, we can use it today, and we are using it today. So that's one of the really exciting things we see, is that we can get more use out of existing aircraft technology, and we can start using it today and scaling it today, which we're really, really excited about. Obviously, as life cycle emission reductions are there, we say more than 80% compared to traditional jet fuel. Some of our suppliers are surpassing that quite comfortably, and if you put removals into the mix as well, you might get to the world of actually negative emission SAF, which again, from a carbon perspective, is extremely attractive. And you know, if our carbon equation is using that 3.16 number, how do you get off that? Well, the only way you can really get off that is by utilising SAF that has really good LCAs. But our major challenge with SAF is availability. I mentioned 1% of fuel usage is SAF today, which we're really happy with, but we have a long way to go. A long way to go to achieve our goal of 10% by 2030, a long way to go to achieve the level we need by 2050, of 50 to 70%. So really good progress, however, a huge road ahead. We've already announced partnerships as well. So I think one thing that, again, that runs through our strategy is partnerships are really, really key. We can't do anything alone. Throughout our strategy, and SAF is very clear on that as well, we have to work with people, and we have to put money down sometimes, and we have to put long-term agreements in place. We have to work with suppliers, a couple of which are in the room today. So Phillips 66, actually, we're match made by Innovate UK, so thank you very much for that. We were the first airline in the world to use UK-produced SAF, which we're really, really proud of. This is the lion's share of our current SAF that we're using. It's being pipelined down to Heathrow, so if you've taken the flight from Heathrow, you would have been on the flight that probably has a very small amount of it on it. People are quite shocked when I tell them that in the pub, and they get quite interested. It's obviously UK produced, using used cooking oil, etc. But really proud of this partnership, really proud to be utilising UK derived SAF. And again, we're working with Phillips elsewhere by delivering HVO to our ground fleet as well. So again, how we leverage partnerships to not only answer one question, but answer multiple questions too. A couple of others I wanted to focus on, and there's two case studies coming up, and LanzaJet and Project Speedbird are really exciting for us and really important in the UK context as well. So LanzaJet, primarily a US-based organisation, have just opened their first, well, the world's first dedicated ethanol to jet plant in Georgia called Freedom Pines. And we're working with Neva Pangea Technologies and LanzaJet on Project Speedbird, which is trying to take this similar technology here into the UK. And then finally, Amitis, again, another US-based firm, supplying SAF to our flights and our partner airline Aer Lingus' flights from 2025. Again, with a different feedstock, with a different technology. As you can see here, the diversity of our supply chain coming through in regards to the geographies, but also types and feedstocks as well. I want to talk about LanzaJet quickly because it's something that is relevant. It was launched earlier this year. As you can see here, this is the launch event. Very proud photo. You think Americans have much bigger flags than we have. But it was really brilliant to see the first ever alcohol-to-jet dedicated plant opening up. And we're not only utilising this fuel for a long time, we are an investor as well. So we work with LanzaJet as an investment partner and as an off-taker because we want to see them succeed. We want to see the technology succeed, we want to be utilising their products, and we also want to be learning with them and sharing their learnings as well. And that's where Project Speedbird comes in. So Project Speedbird is trying to bring LanzaJet technology into the UK. Again, working with Neva Pangea Technologies, who will be producing the bioethanol and then using LanzaJet technology to convert that ethanol into SAF. We are looking at producing enough to reduce emissions by 230,000 tonnes per year. And that's before we talk about removals and any additional removal reductions as well that might come on top of that. Very proud to have won UK government funding from the Advanced Fuel Fund last year, and really hoping that this is one of the 5 SAF projects that get off the ground in the UK, and we see this under construction and SAF flowing through to our fleet in the late 2020s. So again, a good example of how partnering is really important, but also sharing practice and bringing it into the UK and what we're trying to do here. The other exciting one for us, and this is hot off the press in the last few weeks, we've announced this one, driven by IAG, our parent company, the first airline group in the world to commit to 10% SAF by 2030. IAG have actually invested over $865 million into SAF already, and that number is growing. And they've done the partnership with 12. 12 are an E-jet, so it's power to liquid technology, converting CO2, water, and renewable electricity into into an eSAF. Fantastic LCA reductions. And then that's a 14-year agreement. So really putting down a marker in regards to what they want to achieve, how much and how committed they are to that, delivering over 700,000 tonnes of SAF per year over the lifetime of that project, coming through the British Airways aircraft, but also Aer Lingus, Iberia, Vueling and others. And again, a good example of partnership, the IAG Hangar 51 team, who I mentioned before, who help startups kind of innovate and accelerate, they went through our accelerator program a few years ago. So we've gone kind of full circle on this, where we've seen them as a very young company, we helped them kind of accelerate, and then a few years down the line, we're now signing a 14-year agreement with them. So again, this idea of partnership and collaboration is really important. And 12 have just recently broken their first facility in Washington State in the US. Again, really great photo, hard hats, very important in all these photos. That's what I've learned so far in my time at British Airways. And really exciting to see this hopefully get off the ground in the next couple of years. And I guess I'm happy to kind of wrap up there, but I want to just summarise a few closing points. And I guess it's, number one, if you remember anything from today, remember some of these things. Be a Better World it's more than just climate change. We're trying to build a responsible, inclusive, more sustainable business across the entirety. Obviously, climate change and net zero is incredibly important to that. I would say that it's my job, but it's more to it than that. Net zero emissions by 2050 is a tough challenge, but we've got a roadmap to get there, and we are already progressing on that roadmap as well. So whether that's new efficient aircraft, investing in the aircraft of tomorrow, such as Zero Avia, driving more fuel efficiency in our operations by working with pilots and working with other teams around the business to save fuel on a daily basis. Obviously, scaling up SAF is incredibly important, but then making sure that we also have a good supply of removals in the future as well to zero out anything we've got left over. These are all ingredients that we need to be really maximising each one of them to get to this net zero position. And we can't just rely on one. They all have to work together, and we have to be doing everything we can in isolation to make sure that they're all being delivered as best they can. Our SAF usage is increasing. This 5-fold number is really great, and I always just say it's still 1%, so let's not get ahead of ourselves. 1.1% is progress, but we need a lot more. And we need scale supply. So I think that's the big challenge for, obviously, we all know in this room, is that demand's there. It's not like of ourselves, IAG, our sister airlines, other airlines globally. It's the supply that will meet that demand is the big issue. Not only to meet our voluntary targets, of course, we set voluntary targets before many others, but to increasingly meet government mandates. So the UK government mandate, which we welcome, we need supply to make sure we are achieving those and surpassing those to achieve our voluntary goals. I think for us, it's collaborating and partnering with a diverse supply chain is the key. Again, we can't rely on one technology, we can't rely on one feedstock, we can't rely on one geography. We have to be looking at a diverse supply chain here, and we also have to be engaging with them and partnering with them. And that means sometimes actually putting money down and investing in from day one, signing long-term agreements like we've done with 12, and trying to support this industry as much as we can, because we understand that as the end user, we need to be doing our bit to make sure supply is coming through as well. So thank you very much. I really hope you learn more about Be a Better World and how SAF fits into our program. And again, thank you very much for the wonderful work you're all doing in regards to scaling up this amazing and exciting business. Thank you.
Great. Thank you very much, Tom. That was a really interesting keynote presentation. In the interest of time, perhaps it might be helpful if you've got any questions for Tom that we pick them up in the networking break. And so we're going to move on to our DFT showcasing, project showcasing session in this one. And then next door in the Whittle room will be the scaling and integration of SAF if you're interested in that panel discussion, which is in the Whittle room. So we'll just give people a couple of minutes to do that. So I'm just going to invite the first speaker up onto the stage in the meantime. is Martin Atkins from the Abundia Global Impact Group. So fingers in many pies you do, Martin, don't you? But you're talking about this project specifically. And then we've got other presentations from Carbon Neutral Fuels, OXCCU and Alfanar in this session. So I'll hand over to you, Martin, and we'll go from there. Thank you.
Lovely. Thank you, Michelle. Can you hear me okay? Thumbs up? Yes, thank you. Great. It's a great pleasure to be here today. First and foremost, on behalf of Abundia, I'd really like to thank DFT and the AFF Fund for the support on the project. We'll come on and talk about that in a few minutes. And I think we should also thank Michelle and the KTM group for putting on such a good display and such a good diverse partners of technology on the SAF. It's been really illuminating for me and I'm sure a lot of others. So a little bit about introduction to Abundia. We're going to talk about our plans for the AFF funds from the DFT and the type of technology we've got. I know we've only got 10 minutes, so I'm sure there's a trapdoor under here after 10 minutes that will open up and consume me. We'd also like to share with you some of the innovations we see in the technology and our forward plans for implementing the technology. So the technology we're talking about today, and we've got a stand, so please come and talk to us. We're ably assisted by Sophie, our Head of Sustainability, and Sarah, Director of Operations, on the table down here. I just wave to everyone to make sure you know where they are. Please come and talk to us. We're delighted to share the activities we've got. It's a unique pyrolysis technology. It fits into the bucket of biomass pyrolysis, so we're a biomass pyrolysis player here. You think of the technology as two boxes. The first box is a biomass pyrolysis to a mixture of liquids, gases, and importantly, biochar. We heard a lot about biochar yesterday. Our process does actually co-produce biochar in a very unique form. It comes off bagged in ton quantity poly bags from our process, could be used directly. So we heard a lot about locking in carbon. It's a very important part of our process as well. So the process itself, the pyrolysis process itself, started off life in about 2017 as a biomass to power display, which is fully commercial. It's fully commercial today. And since then, we've been optimizing the technology around the opportunity to produce liquids and gases. We future-proofed the technology to a certain extent by having everything on our technology is electrically. All the furnaces are electrically heated. So those of you that come from the oil and gas industry, you know, when we're doing pyrolysis at very high temperatures like this, we often use fossil fuel. So there are no fossil fuels burnt in our process or used in our process to generate the heat. It's all electric. So it does take advantage of being fitting into all the electrification technologies as we go forward. So the trick with the first black box, the trick with that is to optimize the conditions where you generate liquids and you generate gases and you generate this biochar. So the beauty about the technology being able to be flexible around those activities is that we can sustain the energy for the process as well through burning the syngas rich and non-condensable hydrocarbons in the gas phase through generators. So we can really recover over 85% and support over 85% of the power for the whole process. So it's an integrated process. It's one eye to the future. So it produces this liquids product which we make is a crude diesel. Those of you that have been involved with biomass pyrolysis will know that a lot of the pyrolysis technologies, particularly fast pyrolysis, has a lot of oxygenates. The unique nature of this technology is that it makes far fewer oxygenates and makes an already hydrocarbon-rich diesel phase. So the second stage is really a conventional hydrotreating and upgrading. For those of us that are in the oil industry, my background's in the oil industry, that's a pretty standard hydrotreating technology. It uses conventional refinery technology and catalysts and so forth, which we'll come on to a little bit later. But it's a standard off-the-shelf upgrading process, so it makes it suitable for people, refiners that want to do co-processing of the crude diesel, but we also have a first intent process to make 100% SAF and 100% diesel in our facilities. So the project that we're looking at here, and we've got funding for from the AFF, is to take the project through to complete FEED study, which is the front-end engineering design study for the project. We're working with EPC from day one. We're moving forward on the projects here, looking at integrating every aspect of it for a full FEED by March 2025. So that's our timeline for the AFF grant. So the process development, as I mentioned earlier, really started being optimized heavily for liquids around about 2019. And we focused in those 4 years really trying to maximize the yield of the liquids and upgrade those into sustainable technology. Clearly, we need to look at many aspects in that technology, such as the mass balance, the accuracy of the recycle, and really make it suitable for various locations. We had to focus on ISCC certified biomass to start with, because when we're looking at making SAF, that's one of the requirements, as you know, for biomass processes, that it has to be ISCC certified wastes. So we focused heavily in that period on ISCC waste. We have a full supply chain, integrated supply chain, both on the feedstocks with the commercial supplier, and we have also offtake agreements for the products. Now, we were introduced yesterday to University of Sheffield as the clearinghouse. I fully endorse us using these. We've had a great help from Chris Lewis. I know he's disappeared into the next session. We've had a great help from Chris Lewis in helping us map through the fast-track process. So we are entered into the fast-track process. It's been a tremendous bit of help from Chris and the team. So the process that we operate at the moment is a demonstrator plant. We're building that up to FEED study now. Each of these, see some in the pictures in the background there. Each of these modules, it's a total modular process, so we can clip these modules together. But one of these reactor furnaces that we talk about, they typically process about 5 tons a day of biomass, to give you some idea of the scale. When you make the crude product, those of you that are familiar with biomass pyrolysis will know you do get a muddy brown liquid, if you're lucky, like us. Other times you can get a product which is more akin to some comments made yesterday, which I won't really rely on too heavily. But you get these dark brown liquids, and you can see that on the left-hand side. When you distill those and hydrotreat those, you get perfectly clear water white jet fuel. And that's another part of the benefit of working with Sheffield. I don't know if Mohammed's in this room today, but many of you know Mohammed. He's been a great help with us on the characterization of the liquids. We've also gone through the fast-track first phase in the US with CRC, and we've also gone through jet screen in Europe, which some of you will be familiar with jet screen. The role of Sheffield is really important to us for the accreditation and the next stage. This is Mohammed's, the picture there you can see is Mohammed's APU unit at Sheffield, fully instrumented to give you all sorts of data that you need on efficiency of the engine, on particulates and non-CO2 impact aspects of the technology. We typically process about 0.3 to 0.5 of a ton per batch through the hydroprocessing to get enough product to go into the jet engine testing. There's some graphs on there. I'm not sure if it comes out too well on there, but we've been working very closely with Mohammed and the team there. We do get a 50% reduction in particulates. So again, in line with the talks we heard yesterday about particulate reduction in jet engines, this seems to be a real positive feature of sustainable aviation fuel made by some of these routes. The thermal properties of the SAF that we make, minus 47 cold flow properties, excellent purity. It has to be an ultra pure product. And we're pushing very, very hard through the fast track at the moment. So, I've got 1 minute. I'm timing it as well with, I'm just don't want this trap door to open. So in our future timeline, we're going to complete the feed by March 2025. We're moving very quickly now on the fast track process to look at other types of biomass. We've tested over 100 in the small scale. We're focusing on waste wood. We're focusing on empty fruit bunch wastes from different parts of the world, and we're looking to push the accreditation for fast track, which will be the 10% blend by Q1, probably Q2 next year. And with that, I'd like to thank you very much for your time, and I think I'm on time myself.
Thank you very much,
Thank you.
Martin. That's great.
Thank you.
Thank you. So for this session, we'll pick up the questions in the break. So all of these projects are exhibiting. So if you've got any questions for them, you know where to find them. They'll be in the Britain room. So Alasdair Lumsden from Carbon Neutral Fuels, over to you. You've got 10 minutes. Thank you.
I don't think I've been mic'd up, so
No.
shall I steal your microphone, or is it?
Are you happy with the
Yes,
lectern?
I can stick to the lectern, that's fine. Just waiting on the slides.
Click the green button.
Fantastic, thank you. So I'm Alasdair from Carbon Neutral Fuels, and I wanted to start off with just doing a few shout-outs. Carbon Neutral Fuels is a startup. The business has been going for less than 2 years, and without the support of the organisations on this slide, I don't think would have gotten nearly as far as we have. Especially Innovate UK have done an amazing job in terms of industry introductions, and that includes things like introducing us to investors, and it was an Innovate introduction that resulted in our first investment last year. DFT obviously has been doing amazing things with the SAF mandate and the consultations, and we've really felt included in the legislation process, and that's been a real surprise to us, and it's really, really welcome. So as I mentioned, we're a startup. We've been going for less than 2 years, and the journey kind of began when Sophie and I met at COP26 in Glasgow in 2021. And Sophie and I were there campaigning on behalf of the Net Zero Needs Nuclear campaign. This is Sophie live on Sky News being grilled about nuclear, and she remained calm and composed. And there was about 50 of us campaigning at COP26, and I thought Sophie was absolutely brilliant. And so around a year later, I invited her to do a power to liquid startup. And when I approached Sophie about this, she said, well, what's power to liquids? And the rest is history. So in terms of what we're looking to do, we're looking to tackle what we call the 3 S's, and that's sustainability, scalability, and the supply of energy. It goes without saying, if we're volunteering at an environmental thing like COP26, that sustainability is key for Sophie and I, and that's the whole reason that we started Carbon Neutral Fuels. And for us, that means trying to get the greatest emissions reduction with the lowest environmental impact. And that's kind of what led us to power to liquids. It has a very low environmental impact. It can be done with a very low amounts of land use. And if you use technologies like direct air capture, you can get one of the biggest emissions reductions. When we started off, we kind of looked at the goal and the end in mind and worked backwards. And one of the biggest risks that we saw to sustainable aviation fuel projects was getting past that final investment decision. A lot of these infrastructure projects can cost tens or hundreds of millions of pounds, which, if you're a debt financer, it's hard to get them to invest in these projects unless you meet certain criteria. And so we spoke with them and we mapped this out. And One of the key things that came up was no new technology development. One of the nice things about PTL is a lot of the technologies are there to go. This doesn't mean that you can't use new technologies, and certainly our approach does integrate some new technologies, but you can't be developing them as you go if you're looking to go to a commercial scale. We also identified that investors want to see a track record of delivery. You can assemble an amazing team, but that team hasn't necessarily worked together, hasn't necessarily delivered any projects. And so right from the outset, we wanted to work with people that have done this before to reduce that risk. And then the other thing we wanted to do was use modularity where possible. And has anyone in the room read How Big Things Get Done as a book? Not so many. I'd highly recommend it if you're doing a SAF project or any big infrastructure project like High Speed 2. Give it a read. And it turns out that the things mentioned in the book directly align to what we kind of independently arrived at, which was a really good validation. And the third thing we want to tackle was energy supply, because if you're doing power to liquids, you're effectively converting electrical potential energy into stored chemical potential energy. And that's quite different from biofuels, where nature supplies the energy in the forms of sugars and starches. And so with the energy transition, we see a huge scramble to get hold of these low-carbon electrons. Home heating is going to be becoming electric, road transport is going to be moving over to electric, industry is going to be becoming electric. And so whoever controls those green electrons or can get hold of them are going to be successful, especially with PTL. And so we think there's a big opportunity for nuclear tomorrow. I don't really have time to go into the nuclear side, but come find our stand and let's have a chat. So in terms of our process, what we're looking to do is, if we work from left to right, we're starting off with carbon capture on the left to get hold of the CO2 feedstock that we need. That's two sources. One is industrial point sources, and the second is direct air capture. We then take water and electricity, and we feed that into the first process block. And this is where we start to look at the new technologies that we're looking to integrate, and it's solid oxide electrolysis. That's a high temperature electrolysis. It's one of the most efficient in the industry, and one of the unique things that makes our project a little bit different is we're also looking to electrolyze CO2. The way solid oxide works is it strips off oxygen atoms, and you don't just need, it's not only steam you can pass through it, you can also pass through CO2. At the end of that, you get syngas, and with that, you can pass it into a Feedstocks reactor and make sustainable aviation fuel. So last year, we formed a consortium with Mission Zero Technologies. They're a direct air capture company. They're working with Breakthrough Energy, and we're also an X Prize winner. And we're also teamed up with IO Consulting, and they're an engineering company that are a joint venture between McDermott and Baker Hughes. And we've been working with them on the development of our plant. And we jointly applied to the Advanced Fuels Fund last year, and we were successful in raising 1.4 million to design our first e-fuels facility. That's going to be sited in the UK. We're currently going through the shortlisting process for sites. In terms of the inputs and outputs, it's going to be 100,000 tons of CO2, around 120 megawatts, and then the output of that is around 25,000 tons of sustainable aviation fuel. This is actually up from our initial Advanced Fuels Fund application. We recently completed our feasibility study, and it indicated that with what we wanted to do, going larger was going to be better, and so we've kind of adjusted the project parameters to match that. In terms of our timeline, as I mentioned, we've just completed a feasibility study. We're now going into pre-feed, and towards the end of the year, we'll be starting the feed process. And then next year, we'll be looking to do an invitation to tender for EPCs, and then hopefully looking to get construction underway in 2026. And yeah, we're looking at commissioning maybe 28, 29, trying to get something online, but before the end of this decade. And I would be remiss if I didn't mention the things that we're looking for. So the first thing that we're looking for is a site. So if you have a source of CO2 and you have a site, please speak to us. And the other thing is private investment. We're doing a seed round this year. So if you're an investor in the room, come speak to us. And yeah, that was it. Thank you very much.
That's great. Thank you very much, Alasdair. Okay, so next up is Andrew Symes, and he's from OXCCU.
Hello, can you all hear me? Good. Hello, welcome. My name is Andrew Symes. I'm CEO of OXCCU, and as it says, we are focused on CO2 catalyst and reactor designs. Let's start with kind of a very, very high-level point, which I think everyone in this room is fully agreed with, but it is a really significant thing for everyone to get their heads around. But we need a lot of hydrocarbons in a net zero world. Yes, it's aviation fuel, which we're here to discuss today, but it's also petrochemicals and plastics. You can't get away completely from carbon-based molecules. They have these inherent chemical properties that give them uses that can't be replaced with electricity or hydrogen. So we need them, but we can't carry on getting them from fossil fuels. The issue we now know is serious. As the more that we dig up, the more that CO2 accumulates in the atmosphere, making it incredibly difficult or increasingly difficult for humans to live comfortably. Biofuels can play a role, of course they can. Plants do the work for us, but there's severe limitations on biofuels, particularly first-generation biofuels in terms of land use. This was really pushed in the early 2000s, but now we know that it's not enough. We're not saying no, but it's just not enough. We need more. Waste can play a role, but waste is difficult to aggregate, difficult to convert. And again, it's going to play a role, but not enough. So we've really got to think what can supply huge amounts of hydrocarbons in the future that isn't fossil fuels. And of course, this is what people are now moving to, which is the circular economy, CO2-based fuels. Now, the CO2, to be purely circular, has to come from the atmosphere, or it can come as a byproduct of another biomass process, so-called biogenic CO2. That way, the CO2 comes from the atmosphere and then is returned to the atmosphere on use. In the meantime, though, we can use industrial sources of CO2, get this industry started. That's a lower carbon fuel. It's not a carbon neutral fuel. It's not completely circular, but we've displaced fossil fuel, we've reduced fossil fuel demand, and we've made significant progress towards it. Given that we emit 38 billion tons of CO2 per year, this is definitely the way to go in the short term. So CO2 and hydrogen come together and form hydrocarbons. This is actually a very fundamental reaction, and actually, interestingly, if you look back at some of the recent literature, it could even be the reaction on which all of life first emerged, or at least the metabolism of life in which we are based on emerged, the reaction of CO2 and hydrogen in a hydrothermal vent. What is the challenge with CO2 and hydrogen? Well, it's actually, and this is a misconception, it's kinetic, it's not thermodynamic. What do I mean by that? Well, CO2 and hydrogen, if you have enough hydrogen, will react and release heat to form hydrocarbons and water. It is delta G negative for the chemical engineers in the room. And it's a misconception that it's not. The challenge is kinetic, in that CO2 has got a high energy barrier to react. The answer, which all chemists know, is catalysts. And do not forget catalysts. That's probably my main point on my presentation today, is that catalysts throughout chemical engineering history are the key to novel processes. And for CO2, it will be absolutely no different. And interestingly, we haven't spent a huge amount of time on CO2 catalysts because we've always had this access to hydrocarbons. Now, we do need to spend time on it. And thankfully, we have been spending a lot of time on it. We are based on over 10 years of research from the University of Oxford Chemistry Department on CO2 catalysis. And we've developed novel sets of catalysts that can massively simplify this process of turning CO2 and hydrogen into fuel. In May last year, we raised our £23 million Series A with world-leading investors. You can see a number of names there, but Aramco, Eni, Trafigura, United Airlines, showing the interest from the whole value chain in our technology. Why were they excited? Well, it was all based on this Nature paper, which was published in 2020. This got worldwide media attention, and it showed that you can make CO2, you can make jet fuel range hydrocarbons in a single step from CO2 and hydrogen. There is no intermediate step here. This is one reaction. It is known, and a lot of people know, that you can do CO2 and hydrogen to make methane. Everyone knows you can do CO2 and hydrogen to make methanol. And actually, it had already been shown that you could do CO2 and hydrogen to make light olefins. But what this paper showed was that you can do CO2 and hydrogen straight through to C8, C9, C10, C11, all the way up to C16 in a single pass over a catalyst. This had never, ever been done before, got worldwide media attention, and that's the result on which we are based. So why is this significant? Well, most people are looking at multi-step routes to convert CO2 and hydrogen into fuel. The most common one is first turning CO2 and hydrogen into CO in a reaction called reverse water gas shift, and then CO and hydrogen in the well-known Fischer-Tropsch reaction. And this is a sensible route to go because the Fischer-Tropsch reaction is well known, and we needed to essentially make the CO, and that's reverse water gas shift. But it's not the optimum route. And what we are showing at the bottom is that actually you can invent a catalyst that can do both these reactions in a single step so that it is one reaction. And why is that significant? Well, the reverse water gas shift has a huge energy input. We're talking 800, 900, maybe even 1,000 degrees. And the Fischer-Tropsch releases almost too much heat. So what we have shown is that with a new catalyst, you can turn that into a single exothermic reaction. So we now have one reaction that is essentially releasing heat with CO2 and hydrogen. Yes, we need a lot of hydrogen. That's where the energy is. But once you've got the hydrogen, CO2 and hydrogen will react to form hydrocarbons and water and release heat. The plan is to be the catalyst provider and license our technology globally. So we're looking at a business model more similar to those companies that you'll know at the bottom, as opposed to necessarily being the project developer ourselves. That said, we know we have to prove our catalyst works, is stable, is strong, and we need to demonstrate that with demonstration plants and pilot plants. As I said, the research started a long time ago, but we've really got started around 2021, 2022, and last year with our Series A. This year, we are delivering our demo plant, which will be in Oxford Airport, which will produce 1.2 litres and 1 kilo of fuel per day. We're then quickly moving to what we're calling our first-of-a-kind plant, which will be 160 kilos a day or 200 litres of fuel per day. And that will be produced in a single step with CO2 and hydrogen. We'll then move on to our Series B and then the commercial plant probably around 2028. Thank you very much.
Thank you, Andrew. Great, very interesting presentation. So next up is Noaman Adhami from Alfanar Energies. Noaman here? Oh, there you are.
Hello, hi. Good morning. My name is Noaman Adhami. I'm the country head for Alfanar, based in the UK, in charge of the local setup and the development activities of Lighthouse Green Fuels, which is a waste to sustainable aviation fuel project. And today I have a few slides explaining the project, the status, also giving a brief introduction about Alfanar. For those of you who don't know about Alfanar. So the agenda will start with Alfanar overview, LGF project, and then a description about the process and the timeline and what are the challenges currently we are facing in the development of the project and reaching financial close or final investment decision. Now, Alfanar is a global developer and investor in renewable projects. Also, the group is a manufacturer of electrical equipments and an EPC contractor, mainly in the power sector. The group was established in 1976. We have direct presence in 24 countries globally and expanding. The group turnover annually is more than $3 billion US, and we have around 20,000 employees globally. This slide will show you examples of projects in which we were involved in developing these projects recently. mainly in the renewable sector and sustainability. So we were involved or still involved in the NEOM project in Saudi Arabia, and we recently closed a contract with a value of around 2.4 billion US, in which Alfanar invested 600 million directly into this development. Another examples of renewable projects is in Spain. We have around 500 megawatts of wind development, which is currently, part of it is in operation, other part is still in development. And another project, solar project in Egypt. But these are examples. We have a portfolio of around 1.7 giga of power globally currently. Now, why we are moving into the fuels and into sustainable aviation fuel. This is because basically we were very successful in the decarbonization of power, developing projects globally, and we believe that the next challenge is the decarbonization of transport, and of course SAF has major attention currently in the market, and this very difficult sector to decarbonize. So we decided to focus first on SAF, but also we are considering other potential green fuels as well in the future. Now, this is a new vertical, which is currently based in the UK. So it's a new vertical for the group. We are around 70 people now based in the UK. First, focusing, of course, on Lighthouse Green Fuels project, but eventually we would like to utilize this platform to develop more projects in UK and elsewhere globally. From our perspective, there are three main routes which we are currently considering. The first one is the easy one, or what we normally call first generation liquids, or in this case you can say SAF, which is the waste, the used cooking oil and fats to HEFA. We are already currently developing a project in Saudi Arabia to produce HEFA from used cooking oil, utilizing local feedstocks, and also importing part of the feedstocks as well. The second route, which is what we are focusing here in the UK with Lighthouse Green Fuels, is the solids to liquids, which basically is the second generation SAF. And for us, this is a very important move, because then it will unlock much more feedstock, which can be utilized by Biogenic feedstock for the production of SAF. And of course, power to liquids is, we strongly believe in this route as well. In the right time, we will either integrate with our current SAF project or develop more projects related to power to liquids. We have already hydrogen projects, green hydrogen projects in Egypt, for example, and green ammonia in Egypt and in Chile. But to produce fuels is the next step, which we are preparing for now. Project overview, Lighthouse Green Fuels. The project will be utilizing around between 1 to 1.5 million tons of waste feedstocks, biomass waste feedstock. The project will generate around 1,500 jobs during construction, and the capex is around 1.5 billion pounds. And in terms of production, we are aiming to produce around 3,400 barrels per day. This is equivalent to 134,000 tons of SAF annually. Why Teesside? Simply because the area is very rich with industrial heritage first, and also availability of high-skilled workforce is very important to have when you develop projects with such type of a scope. Also in Teesside, as you know well, it's one of the first carbon capture clusters in the UK, And for our route, carbon capture is key in order to reduce the carbon intensity of SAF. We acquired the sites, so the sites are existing. We acquired the sites. It was the previous Air Products TV1 and TV2. So we do already have all the connections required to develop the projects like oxygen, grid, wastewater, water, and other essential connections is already existing. Also, a power plant is existing where we will be utilizing it for our parasitic load for the SAF plant. In addition, there are existing infrastructure which we will be utilizing like a railhead to bring the feedstock from different locations within the UK. Also, we are planning to use the existing storage for the storage tanks which are close by. The project is currently considered a nationally significant infrastructure project, so we are going through the DCO route due to the complexity. This was not the plan originally, but now due to the complexity of the project, we are going through a DCO, which is progressing well. And we are aiming to get this finalized by end of next year. Process overview, I think this is it's a typical process which is following the FT-SPK route, starting with the pre-treatment of waste and feedstock. This first step is where we have spent a lot of time and efforts during the last 5 years, making trials. We did, I think, one of the largest, if not the largest, waste campaigns, waste sampling campaigns for 1 year. Every day we take samples and analyze it. So the key for us is to basically understand well the feedstock and try to de-risk the gasification process by basically refining the waste to the extent where it will be suitable for gasification without any potential issues. Then the next step is the gas cleanup, after which we will go to the refining, which basically we are using an FT technology and the hydrocracker. Now, maybe it was also explained by the other projects which follows the same route. This route we will be able to separate the CO2 from the syngas stream. By the process itself, we need to separate the CO2 because we cannot have CO2 fed into the FT technology. So it's already a carbon capture enabled project. We only need the connection to the carbon capture facilities in order to basically reduce the carbon intensity of SAF. And this works well in the UK because the SAF mandate is carbon scaling, as you may know. So it will basically help accelerate the decarbonization of aviation by having a lower carbon intensity SAF. Project timeline, we started FEED in Q2 2022. We are currently progressing well with the FEED, aiming to get the FEED finalized by Q1 2025. After that, we plan to start enabling works and site preparation because the site is brownfield, is existing, so we need to do some work to prepare the site before we build the new SAF plant. And our aim is to reach FID by second half of 2025, in line with the Jet Zero strategy. And our project is one of the 5 projects which is supported, of course, by DFT, and we are an AFF project as well. So the aim is to start construction by 2025, and we are ready for that. And we are aiming to reach commercial operation by 2028. This includes a commissioning period for the project. Now the challenges, and this is maybe not necessarily only linked to us, it's also, the other projects, the other 5 projects will most likely share the same. As you know, the price certainty mechanism has been announced by DFT, the consultation, but the time frame for that is long. And we will be ready, as I explained, by mid next year to close the project and reach FID, and we cannot wait up to the end of 2026. So this is one of the main challenges. The second challenge is access to CCUS. It's very important for us. We need to have certainty about the access to CCUS before we close the project. There will be a delay the first 2 years. We don't have it. It's fine. We can live with that. But then we need to have certainty that the rest of the operation years we have access to CCUS. Since this will make the business model work, without it, it will be difficult. If I have the same carbon intensity of HEFA, then basically I'm much more expensive than HEFA because it's a capital intensive and the capex is much higher than a HEFA plant. So in order for me to compete with HEFA, I need to be much lower in carbon intensity. That's why it's very key for us to have carbon capture. And thank you. That's it.
Thank you very much, Noaman. Thank you. Okay. Right. Thank you very much to all the projects. I think what that highlights is there's some really interesting developments in the UK and some real game changers within that mix. So we are now going to go into the break, so it gives you an opportunity now to go and talk to those projects because they're all got exhibition stands out there, so feel free to go and talk to our speakers in a bit more detail, and then we'll come back at 11:20 and we'll continue on with the project showcase, and then next door in the Whittle room will be scaling power to liquids with nuclear energy if you're interested in that, and that's sponsored kindly by Carbon Neutral Fuel. So we'll let you head off and then we'll be back in here at 11:20. Thank you.
Airlines and aircraft makers are desperately searching to reduce their climate impacts. CO2 emissions amount to about 2% of the global total and 7% in the UK, and are increasing. But there are other impacts, such as the damaging contrails. Back in 2011, I was granted a patent for a novel way to generate power and hydrogen from hydrocarbons. Highly efficient fuel cells and electrolyzers make this possible. Using this patented process as a front end to a more conventional gas to liquids process, we can turn all sorts of worthless waste into high-value fuel, help clean up the environment, and solve the problems of disposal in one fell swoop.
Making sustainable aviation fuel in sufficient quantities is a massive chemical engineering challenge. We've already started building our bench scale system, which will just prove the concept. So we'll take some waste, which is our feedstock, and we'll create some fuel to demonstrate that the process actually works. The key step is then our demonstration system, which will be a 5,000 tonne per year plant, and that will be a very faithful reproduction of the larger scale plant that we're going to scale up to. Then we're going to scale up to our 30,000 tonne per year commercial plant, where we're making fuel, selling the fuel and making money for the business. Jet fuel is a tightly regulated product. In our case, we have to meet those requirements, but we also have to meet the requirements that it's sustainably produced.
Reducing global temperatures and protecting our planet is a key generational challenge. Our mission at Aviox is to deliver the world's most technologically advanced refinery making sustainable aviation fuel. We believe that the plant will be highly profitable due to the very low cost of the waste materials as input material. We need the resolve and the capital to make a radical shift within our economy to make it modern, circular and sustainable. This is a once-in-a-lifetime opportunity to join a new wave of clean tech companies developing clean, green and sustainable aviation fuel, and it's a privilege to be part of it.
Airlines and aircraft makers are desperately searching to reduce their climate impacts. CO2 emissions amount to about 2% of the global total and 7% in the UK, and are increasing. But there are other impacts, such as the damaging contrails. Back in 2011, I was granted a patent for a novel way to generate power and hydrogen from hydrocarbons. Highly efficient fuel cells and electrolyzers make this possible. Using this patented process as a front end to a more conventional gas to liquids process, we can turn all sorts of worthless waste into high-value fuel, help clean up the environment, and solve the problems of disposal in one fell swoop.
Making sustainable aviation fuel in sufficient quantities is a massive chemical engineering challenge. We've already started building our bench scale system, which will just prove the concept. So we'll take some waste, which is our feedstock, and we'll create some fuel to demonstrate that the process actually works. The key step is then our demonstration system, which will be a 5,000 tonne per year plant, and that will be a very faithful reproduction of the larger scale plant that we're going to scale up to. Then we're going to scale up to our 30,000 tonne per year commercial plant, where we're making fuel, selling the fuel and making money for the business. Jet fuel is a tightly regulated product. In our case, we have to meet those requirements, but we also have to meet the requirements that it's sustainably produced.
Reducing global temperatures and protecting our planet is a key generational challenge. Our mission at Aviox is to deliver the world's most technologically advanced refinery making sustainable aviation fuel. We believe that the plant will be highly profitable due to the very low cost of the waste materials as input material. We need the resolve and the capital to make a radical shift within our economy to make it modern, circular, and sustainable. This is a once-in-a-lifetime opportunity to join a new wave of clean tech companies developing clean, green, and sustainable aviation fuel, and it's a privilege to be part of it.
and robust in its operation. We achieved the first in 2022. We have produced SAF in our first-of-a-kind facility in Sierra Nevada in the States. We have produced the second objective in 2023. We have an extended run where we produce SAF, thousands of gallons of fuel that were then sold, certified and sold. Those two steps have led us to numerous lessons learned that we are currently trying to implement in our Sierra Nevada facility in the States to improve our third target, which was the robustness of the design and the robustness of the operation. We were actually hoping to have a video for you to show you today. We were hoping to restart our facility during April. Unfortunately, this wasn't possible. It will happen imminently in May, so I don't have a video, but I have very, very positive outcome and messages coming out of our facility in the US. So we have proven the concept. We have a facility that is one gasifier train in the US, processing effectively municipal household waste at 500 tons a day capacity is what we call 1X. Project NorthPoint, which is a UK development for Fulcrum bioenergy in the UK, we are trying to bring this platform over here and develop a project that has 3 very similar gasifier trains. We call that a 3X facility. We're effectively maintaining the same technology licensors across our process, and it's effectively a 1,500 a day ton facility. At this stage, I would like to acknowledge the funding from the Advanced Fuel Fund. It helped us bridge our funding gap all the way to FID. So thank you very much. We utilized the funds from the AFF to develop the FEL2, primarily and FEL3 phases of the project. That means the feasibility phase and the feed phase. We are currently into feed design. We're almost 50% complete. We have awarded the feed design to Kent Energies Limited. We have an owner's engineer on board supporting us with the execution of the project. We have awarded the owner's engineer contract to Technip Energies. Obviously, we utilized the funds as well in numerous other activities trying to develop further the UK SAF industry. Let's talk a bit about Project NorthPoint. You can see a slide with the location of the NorthPoint site. The location is within the Stanlow oil refinery in Ellesmere Port. I'm not sure if you can see the site very well. You can see the boundaries in red color on the slide. The site effectively forms part of the wider Ellesmere Port industrial area. It has been selected by us because of its industrial nature, because of the availability of local skilled workforce, the availability of utilities. We have access, through Stanlow, obviously, to be able to blend our product there, our SPK product to, produce SAF and then utilize the existing pipeline to be able to feed local airports in the region. The project area covers 55 acres and is bordered on the north and the west by the River Gowie and on the east by the Thornton Brook. There are many synergies in the location of our site. There are other projects that are happening in the area. We have a green hydrogen project that is almost achieving FID. There are obviously lots of utility providers that we have established already cordial relationships, and we are in discussions with them to be able to supply the site with power, gas, water, etc. The Fulcrum process. Obviously, we are converting residual household waste, household waste, municipal solid waste into synthetic paraffinic kerosene using one of the approved routes by the UK government, which is through the gasification and FT, Fischer-Tropsch synthesis. Our facility is designed to be carbon capture ready. Our design ensures that we isolate our carbon dioxide stream. We clean that stream, we remove the sulfur, we remove the water, we compress it, and we are ready to send it, to store it, and sequester it somewhere close to the site. We are hopeful that we should be able to do that through our Track 1 application, our HyNet application, to be able to send our CO2 to the Liverpool Bay, but we also have a plan B in case this infrastructure in the northwest is not ready by the time we complete our project. In terms of our timeline, as I said, we are in feed development. We are 50% through to feed. Kent Energies is our feed engineer and principal designer for the project under CDM. They will produce an AAC Class 2 estimate for us, and they are helping us at the moment carving out our contracting strategy for the execute phase of this project, which is the phase after the financial investment decision is taking place, detail engineering design, construction, pre-commissioning, commissioning, and startup. We hope that we should complete FEED this autumn and achieve our FID in 2025. We are hopeful that we should be able to break ground, and break ground in 2025 and complete our construction in the first quarter of 2028, and then shortly after commission and ramp up to full capacity the NorthPoint facility towards the end of 2028. Many thanks for your attention. We have a stand here if you want to talk to us. We have showed up in force. We have lots of Fulcrum employees today to respond, to any of the questions you may have, and we can give you an update about our US facility and also further update of what we're trying to do with NorthPoint up in the northwest. Thank you very much.
Thank you very much, Thanos. That's great. Thank you very much. And now we've Neville Hargreaves from Velocys. If you could, your presentation. Thank you.
Thanks, Michelle, and good morning, everybody. I do feel I'm among friends here. After many years of labouring in the world of creating SAF projects, it's wonderful to see the diversity and range of new initiatives that are coming along. Let me tell you a bit about our journey, and I will talk about not just one, but two projects funded under AFF. So first of all, a bit about Velocys. We're a sustainable fuels technology company. We arose out of two innovations, one in catalysis at the University of Oxford, one in reactor design at the Pacific Northwest National Laboratory in the US. And we have a Fischer-Tropsch technology, which we have demonstrated at full scale. I'll show you a little more about that in a minute. And on the top right of the picture, you see one of our full-scale reactors. That enables the Fischer-Tropsch pathway, which, as most of you know, is one of the ASTM-approved pathways to drop in SAF, and it also enables us to couple it with carbon sequestration, as both Alfanar and Fulcrum mentioned, to create negative carbon fuel. And I think this is a key element. For those who were here yesterday, there was a discussion about carbon removals and SAF, and I think the conclusion of that conversation was we need both. This project allows both in one place. So Velocis used to be a public company. We're now glad to say we're private. We're owned by a set of investors all focused on impact on climate. They've put $40 million and some more into the company earlier this year, and we're very excited to be part of those families. We're headquartered here in the UK, in Oxford. Our manufacturing centre is in Columbus, Ohio. That's the bottom picture on the slide, and that's where we'll be making the cores of our reactors, previously outsourced but now brought in-house, and that gives us a lot of extra control. And then we have an engineering centre in Houston as well. So our long-term business model is that we want to license our technology. So we are not fundamentally a project developer, but we've had to become one in order to prove the end-to-end chain from feedstock to SAF. So we are developing 3 reference projects, one in the US, which is using forestry residue, woody biomass, as the feedstock, which will have a deeply negative carbon intensity. And then 2 in the UK, Altalto and eAlto, and I'll say more about those in just a moment. I suppose what distinguishes us is the fact that we are a technology company. We've got many, many years of experience of operating Fischer-Tropsch plants and with some extraordinarily difficult and dirty feedstocks. And so that's carried forward into the way we go about our business. But small companies can't do big projects on their own. We need partners, and one of our most important partnerships is that with Bechtel. We have a master service agreement in place with them. They're the feed contractor for the Altalto project, and our intention is that they'll be building each of our reference projects. And fundamentally, the construction expertise that they bring is really important. James Fivens from Bechtel's in the audience, and he'll be at our stand later if you want to talk to him. So I mentioned that we've got a lot of experience. Our technology has operated in many settings. Some of them are shown here. The one on the left is important because that was at full commercial scale. So our technology is a modular one. That's one of its key advantages, that it can be applied at many different scales. That plant was a landfill gas and natural gas to fuels and waxes project in Oklahoma City in partnership with Waste Management, and that gave us our runtime at full scale. But we've also done a number of other demonstrations with gasification, including with the TRI gasifier shown in the middle picture. And on the right, our most recent one was with in partnership with Toyo Engineering in Japan, and that produced SAF that was used in a commercial flight. So now on to our own projects here in the UK. So Altalto is a waste-to-fuels project based in Immingham on the south bank of the Humber. Fantastic location. It's actually a greenfield site, but it's very much within an industrial context. It's very close to the largest cargo port in the UK. It has road and rail links, and importantly, it's got access to carbon sequestration. So we're close to both the Viking and the East Coast CO2 clusters. So that you can see an aerial view of the site on the left. You can just see the South Humber refineries in the background, South Humber Bank Power Station on the right. This facility will take in about 600,000 tonnes of waste, residual non-recyclable waste that would otherwise go to landfill or sequestration. And that then goes through a gasification, syngas cleanup, Fischer-Tropsch and upgrading process. I took a gamble that someone else was going to show the process scheme earlier, and actually two others have done so, so I won't take your time with it. But it is very much the same principle as the others using, but we are using different technologies in a number of cases, and of course our own Fischer-Tropsch process, which we think gives a particular advantage. We'll be making at least something in the range of 40,000 tonnes of carbon negative SAF per year, with a carbon intensity of around minus 50 grams per megajoule. So that's 150% saving versus fossil fuel. And that really is the most important bit here. It's not how many tonnes of fuel we make, that does matter, of course, but how many tonnes of CO2 we save is vitally important. And thanks to the SAF mandate and the business model that's been published, that does translate into value. We couldn't do it without our current partners, so we're working with Foresight, the investment house who own our land, our site, and of course British Airways, who've been partners with us right from the beginning. We're presently in the FEED stage. We've got planning consent, and we've done an enormous amount of de-risking of this, partly through our selection of partners, both technology side and Bechtel, as I mentioned, but also through many stages of engineering and commercial work. We've invested, altogether, we and our partners have invested over £12 million before we started the FEED. We've been able to do that with to start the FEED with the aid of the Advanced Fuels Fund grant of £27 million. Thank you to the DFT for that. We're presently in the process of raising the remainder of the development capital. So if anybody is interested, we'd be happy to talk to you about that. This is a project that has had an enormous amount of effort and knowledge put into it. When will we reach final investment decision? I think there are a few things that I don't know yet. One of them is to what extent the SAF mandate will affect our ability to reach commercial deals before the revenue certainty mechanism in place. As Noaman pointed out, there is a timing mismatch between the government's ambition and the implementation of that revenue certainty mechanism. Subject to that, we'll be ready to go and to have production in place well before the end of this decade. So that's Altalto. I seem to have lost a page. There was another page which seems to have gone missing, which is EALTO. So our other project is an e-fuels project, which is taking hydrogen and carbon dioxide as the feedstocks to make SAF. We got a grant under the AFF for that as well. And that enabled us to partner up with Technip Energies with their reverse water gas shift technology and help to develop that technology so that we've actually got a solid block of something that's commercially ready for the reverse water gas shift, because that was not at the same stage as the technologies in our lineup for Altalto. So we've already achieved that through the Advanced Fuels Fund. We've also done conventional project development. We have an option on the site. We have CO2 supplies in place. We're still working on the hydrogen supply, and herein lies the challenge with PTL projects, and I think many of you know this. Although the SAF mandate has done a tremendous thing for waste-based projects, I don't believe at the moment that PTL projects are economic in the UK. We have a challenge in terms of the price of power. We have challenges in terms of availability of continuous power, so some of the requirements for additionality and temporal correlation. If you don't know what those mean, ask me afterwards, but it's not straightforward to produce continuous supplies of hydrogen based on the UK model at the moment. This may be where nuclear comes in. I know none of you are interested in nuclear, because otherwise you'd be in the other session, but nevertheless, that is actually a really interesting route to making renewable hydrogen, making low carbon hydrogen. So we have done a lot with EALTO, and we think we've learned a lot. We think we can help inform others and hopefully get such a project to conclusion, but it does depend on having a business model. So thank you very much, everybody, and I'll hand on to the next speaker.
Thank you very much, Neville. Okay, so next up is Patrick Smith from Nova Pangea Technologies. Thank you.
Thank you very much. Patrick Smith, I'm Strategic Development Director here at Nova Pangea Technologies, and here to talk to you today about Project Speedbird. So what is Project Speedbird? It is a joint partnership between Nova Pangea Technologies, British Airways and LanzaJet to deliver cost-effective second-generation sustainable fuels into the UK. It was launched in 2021, where we conducted an initial feasibility study, which was funded by the DFT's Green Fuels, Green Skies campaign. Since then, we have completed a number of joint development agreements and recently been the recipient of the DFT's Advanced Fuels Fund That is being used essentially to progress and accelerate the development of Nova Pangaea's first RefNova facility, but also LanzaJet's ATJ hub as well. So if we go into our technology, so essentially, what is it that Project Speedbird does? We take waste residue from wood and agriculture, and we turn it into 2G sustainable aviation fuel. The RefNova side of the process, which is the MPT patented technology, essentially consists of three main stages. We take the lignocellulosic material, we use NovaPre to reduce the particle size, to remove contaminants, and then we put it through our steam-assisted rapid pyrolysis process. That essentially delivers C5C6 sugars, which we then ferment and distillate into lignocellulosic ethanol. That is then put into the LanzaJet process, and this is where I wish scientists would come up with easier names, to go through dehydration, oligomerization, hydrogenation, and fractionation, which delivers two main products, the 2G sustainable aviation fuel and renewable diesel. Now, LanzaJet's technology really has a high selectivity to SAF, so it has the ability to produce 90% of hydrocarbons within the jet fuel range and at a higher energy density than Jet A1 as well. So why are we unique? I think we've spoken a lot about this over the past couple of days, but really at the front end of the process, we are feedstock agnostic. If it is lignocellulose, we can process it. And we have run a number of different lignocellulosic material through our SARP unit, ranging from whiskey draff, bagasse, wheat straw, and also hardwood and softwood as well. We are a thermal process on the RefNova side, so we do not use enzymes, which reduces cost, but it also allows for adoption of a continuous process. And thirdly, really, and a key one when we're talking about carbon emissions, is the production of biocarbon. So if I flick into this to talk a little bit around this, the heating rate of the SARP unit that we use avoids lignin decomposition, which essentially provides us with high surface area biocarbon. So for every ton of carbon in the Novachar, it's 3.6 tons of CO2. So essentially, if we can use that as a carbon sequestration, then we will be a net negative SAF producer. So essentially the way that we use this is either in soil enhancement, where it is sequestrated, allowing for nutrient uptake and higher agricultural yields. We can also use it as a filler in cement and asphalt and plastics. Alternatively, it can be used as a combustant, as a replacement for coke in metals refining as well. If I flick through, and I do have to show this because it is just quite a nice slide, essentially the circularity of the process of Project Speedbird. So we essentially, whether we are working with agricultural or wood waste, we will always be sustainable. So in terms of the wood waste, we take the brash from the trees that are felled. So essentially the crown and the foliage and the branch wood that isn't used in the timber industry, that is largely left on the ground, or we use the cuts from the sawmills that is either used in MDF or for animal bedding. So we use that as our wood process. For agricultural, for things like wheat straw, it is the waste residue from the processing of the agricultural crop. That then goes through the RefNova process, then through the LanzaJet process, of which part of the output is the renewable diesel, which we are hoping to be able to use for our fleet management operations within Speedbird as well. And then finally, that is then given to British Airways to use in the UK. And if we look at our overall UK impact, so at full operations, we'll be delivering around 90,000 tonnes of SAF and renewable diesel a year, which is equivalent to around 230,000 tonnes of CO2 emissions reduction. And based on 2019 data from the LCA that we did, is the equivalent to around 26,000 British Airways domestic flights a year. I will finish, I believe that is my last slide, so I will finish just by saying a huge thank you to the DFT for their continued support, both through the Green Fuels, Green Skies, and also through the Advanced Fuels Fund, and a big thank you to everyone here in the industry who have helped raise the profile of SAF over the last couple of years. Long may it continue. Thank you very much.
Thank you very much, Patrick. That was short and sweet. So that brings us on to Greg Archer from Lanztech. Thank you.
Thank you very much. Well, everybody said everything, so thanks. Does feel a bit like that, I must be honest. Project Dragon is Lanztech's project to develop SAF in South Wales, Port Talbot. Lanztech is a carbon capture and transformation company. We capture the waste gases from our industrial processes, also from gasification of solid wastes, and we feed them to bacteria who then transform them into ethanol. And then we transform that ethanol into a whole range of different products, including sustainable aviation fuel, but we also produce the soles of running trainers, we produce sportswear with Adidas, dresses with Zara, and a whole range of plastic bottles, detergents. We even make fragrances with Gucci. Project Dragon is our project that will produce around 1% of the UK's jet fuel needs, and it's one of the sites which are targeted to be under construction in 2025. It's a major development. It would be an investment of over £1 billion, and like a number of the other projects that have been described today, it's supported by a £25 million Advanced Fuel Fund project, which is designed to take us through the front-end engineering design, the planning, the permitting, to reach FID. And the big challenges that we face are the ones that you've heard. They're regulatory and their financing of the project. The image there is the location of the site. You can see the Port Talbot Steelworks just behind it, and located conveniently in a harbour area where we can build a jetty to bring our product in, the feedstock in, ethanol, and take the SAF away, which we can then connect up by ship to either Avonmouth or Milford Haven and to the SAF pipelines, aviation fuel pipelines in the UK. This is the overall design of the scheme. There's essentially 2 projects, or now 3 projects, within the overall production cycle. The part on the right-hand side there is exactly the same as we've just heard described by Nova Pangaea. Lanztech separated out the LanzaJet business a few years ago to focus on the production of the alcohol-to-jet and the development of the alcohol-to-jet technology. We still own a portion of that company, but it is independent and separate from us. And we can use the technology on integrated projects, and they are clearly developing their own projects, such as Project Speedbird. So the 3 steps in the production of the process are the ones that Nova Pangaea have described in terms of dehydrating the ethanol to ethylene, producing long-chain molecules, and then a hydrogenation step in order to produce around 90% SAF, 10% renewable diesel. Now, we're located in Port Talbot because our original intention was to make the ethanol locally using the gases from the Tata Steel blast furnaces. Those blast furnace gases are ideal for our process because they're very rich in carbon monoxide, and our bugs, our bacteria that make the ethanol, feed on that CO gas. Clearly, the Port Talbot blast furnaces are closing. That presents a challenge to us. And I'll describe how we're going to overcome that in a moment. Our process for producing the ethanol, if we were using a blast furnace gas, would simply involve a bit of compression, up to about 10 bar, a moderate amount of cleanup, mainly to remove some of the carbon dioxide, and then we literally just bubble those gases through a large bioreactor containing our bacteria. The bacteria is entirely natural. It was originally found in the guts of rabbits. No rabbits are harmed in the making of our bacteria. And then we fractionally distill off the ethanol product, and the bacteria goes through the fractional distillation process, comes out the other side, and continues to produce ethanol. At the end of its life, we actually take that bacteria away. In China, where we have 4 sites, we feed it to animals, we sell it as an animal feed. In Europe, we anaerobically digest it and turn it into biogas, which we can use on the site. Now, in the absence of the blast furnace gas, we can use a CO2-rich source, so we can take gases from the planned electric arc furnaces at Tata, and we can, with the addition of hydrogen and a water-gas shift reaction, we can then feed that to our bacteria, and our bacteria will happily produce ethanol in the same way. But clearly, this is a major development to the project. We require 50,000 tonnes of hydrogen a year. That's a 300 megawatt electrolyser. That's adding cost, a significant amount of cost to the project. But this is the basic idea of going from industrial off-gases to producing sustainable aviation fuel. This is what the site will look like. You can see we're just alongside cement works on the bottom right left-hand side of the slide. You can see the various tanks there which are holding either sustainable aviation fuel or the feedstock ethanol. In the bottom side, you can see a enclosed ground flare, which we plan to build. When we first started to talk to local residents about the site, what we discovered was there were 3 things they were worried about. They said to us, is it safe? How are you going to move the stuff in and out? Is it going to cause any traffic? What's the air pollution like? And then the 4th thing they kept mentioning is we don't like flares. They worry us. We see the flare going off. It makes noise. We get worried there's something wrong at the site. By building an enclosed ground flare, we're able to earn a lot of credit from the local community, address a lot of local concerns. By listening to people, you can modify the scheme of even large industrial processes to earn a lot of goodwill from the consumers and local people. So where are we? Well, we have completed the feed engineering work on the alcohol-to-jet part of the project. That work has been done by Technip. It is finished. The work on the feed for the gas fermentation to produce the ethanol has been delayed because of the uncertainties around the steelworks, but Fluor are moving that forward urgently with us now. We have planning permission for the alcohol-to-jet site. We secured that at the beginning of April. You say that very quickly, and then it was over 2,000 pages of documentation just for the planning permission. That's a major undertaking in its own right, and I have to congratulate our planning consultants, Turley, who did a fabulous job working with us to do that. The 3rd thing is the environmental and safety permits. Those are well advanced, they're moving forward, they've been made, and we will be finishing them shortly. We've also got initial offtake agreements with BA and with Virgin to be able to sell the SAF that we make. But we can't finalise those offtake agreements because we don't have finalised legislation in the UK. And this brings me to the first of the real challenges that we face. Simply concluding the consultation is not putting the SAF mandate in law. That requires a statutory instrument to be laid in Parliament, which will take at least 8 weeks to pass, and there are 12 weeks left before Parliament rises for the summer and for the recess, and it's quite likely or possible that Parliament will not return after the summer recess for the election. So the clock is not ticking, the alarm bells are ringing really loud on this. We have to have the statutory instrument laid in Parliament and passed to move forward with this project. The second issue is the one that Neville's just mentioned. that there's many excellent things in the design of the SAF mandate, but one of the things that is not excellent is the buyout price on PTL, power to liquids. And if we make our SAF from CO2, we are making a power to liquid. And the buyout price is simply not high enough to cover the very high costs of the hydrogen. So if we're going to make PTL in the UK, we have to have a support mechanism for the price of the hydrogen. The hydrogen production business model is there to do that, but at the moment the government is not minded to allow the two systems to work together. If it wants PTL made in the UK, it will need both support schemes together. And the last is also what Neville has just said, that we face challenges with investment, because when we talk to potential investors to actually build these projects, they tell us, could you come back at the end of 2026 when the revenue certainty mechanism is in place? It's like, well, you know, we were hoping to actually reach a final investment decision this year. And so we're being really held up by the fact that there is no interim solution to help build 5 plants next year. There will not be 5 plants under construction next year without an interim solution. We've proposed a workable solution to the Department for Transport, extending the existing AFF grants to enable us to continue to work on the projects till revenue certainty is a bit further forward and agreed. But without that, this project will not move forward because investors will not invest without the RCM. So are we ready for takeoff? Well, we have made substantial progress. Can we get to the departure gate? I don't know. It's not entirely within our hands. In fact, a lot of this is outside of our hands. But I very much hope that we can do, and I very much hope that we can reach the FID at the end of this year and start building this project, because 3,000 people are about to be made redundant in Port Talbot, and they need jobs and they need a future. Thank you for listening.
Great, thank you. I think some very clear messages coming through there. You know, it's great stuff that we're all doing and working on, but there's still a lot of challenges out there that need to be sorted. So thank you very much for all our speakers this morning. And again, all our projects are out there exhibiting, so please go and talk to them if you've got any questions at all about their projects and what they're developing. We're going to return back in here at 1:30, where we've got a keynote presentation from Brian Moran from Boeing. So please do join us back then. Now's an opportunity for you to go away and network. And thank you very much to all our exhibitors as well. So there they all are. Please go and make the most of the networking session. So thank you very much, everybody. If you could thank our speakers.
Damaging. Airlines and aircraft makers are desperately searching to reduce their climate impacts. CO2 emissions amount to about 2% of the global total and 7% in the UK, and are increasing. But there are other impacts, such as the damaging contrails. Back in 2011, I was granted a patent for a novel way to generate power and hydrogen from hydrocarbons. Highly efficient fuel cells and electrolyzers make this possible. Using this patented process as a front end to a more conventional gas to liquids process, we can turn all sorts of worthless waste into high-value fuel, help clean up the environment, and solve the problems of disposal in one fell swoop.
Making sustainable aviation fuel in sufficient quantities is a massive chemical engineering challenge. We've already started building our bench scale system, which will just prove the concept. So we'll take some waste, which is our feedstock, and we'll create some fuel to demonstrate that the process actually works. The key step is then our demonstration system, which will be a 5,000 tonne per year plant, and that will be a very faithful reproduction of the larger scale plant that we're going to scale up to. Then we're going to scale up to our 30,000 tonne per year commercial plant, where we're making fuel, selling the fuel and making money for the business. Jet fuel is a tightly regulated product. In our case, we have to meet those requirements, but we also have to meet the requirements that it's sustainably produced.
Reducing global temperatures and protecting our planet is a key generational challenge. Our mission at Aviox is to deliver the world's most technologically advanced refinery making sustainable aviation fuel. We believe that the plant will be highly profitable due to the very low cost of the waste materials as input material. We need the resolve and the capital to make a radical shift within our economy to make it modern, circular and sustainable. This is a once-in-a-lifetime opportunity to join a new wave of clean tech companies developing clean, green and sustainable aviation fuel, and it's a privilege to be part of it.
Airlines and aircraft makers are desperately searching to reduce their climate impacts. CO2 emissions amount to about 2% of the global total and 7% in the UK, and are increasing. But there are other impacts, such as the damaging contrails. Back in 2011, I was granted a patent for a novel way to generate power and hydrogen from hydrocarbons. Highly efficient fuel cells and electrolyzers make this possible. Using this patented process as a front end to a more conventional gas to liquids process, we can turn all sorts of worthless waste into high-value fuel, help clean up the environment, and solve the problems of disposal in one fell swoop.
Making sustainable aviation fuel in sufficient quantities is a massive chemical engineering challenge. We've already started building our bench scale system, which will just prove the concept. So we'll take some waste, which is our feedstock, and we'll create some fuel to demonstrate that the process actually works. The key step is then our demonstration system, which will be a 5,000 tonne per year plant, and that will be a very faithful reproduction of the larger scale plant that we're going to scale up to. Then we're going to scale up to our 30,000 tonne per year commercial plant, where we're making fuel, selling the fuel and making money for the business. Jet fuel is a tightly regulated product. In our case, we have to meet those requirements, but we also have to meet the requirements that it's sustainably produced.
Reducing global temperatures and protecting our planet is a key generational challenge. Our mission at Aviox is to deliver the world's most technologically advanced refinery making sustainable aviation fuel. We believe that the plant will be highly profitable due to the very low cost of the waste materials as input material. We need the resolve and the capital to make a radical shift within our economy to make it modern, circular and sustainable. This is a once-in-a-lifetime opportunity to join a new wave of clean tech companies developing clean, green and sustainable aviation fuel, and it's a privilege to be part of it.
Airlines and aircraft makers are desperately searching to reduce their climate impacts. CO2 emissions amount to about 2% of the global total and 7% in the UK, and are increasing. But there are other impacts, such as the damaging contrails. Back in 2011, I was granted a patent for a novel way to generate power and hydrogen from hydrocarbons. Highly efficient fuel cells and electrolyzers make this possible. Using this patented process as a front end to a more conventional gas to liquids process, we can turn all sorts of worthless waste into high-value fuel, help clean up the environment, and solve the problems of disposal in one fell swoop.
Making sustainable aviation fuel in sufficient quantities is a massive chemical engineering challenge. We've already started building our bench scale system, which will just prove the concept. So we'll take some waste, which is our feedstock, and we'll create some fuel to demonstrate that the process actually works. The key step is then our demonstration system, which will be a 5,000 tonne per year plant, and that will be a very faithful reproduction of the larger scale plant that we're going to scale up to. Then we're going to scale up to our 30,000 tonne per year commercial plant, where we're making fuel, selling the fuel and making money for the business. Jet fuel is a tightly regulated product. In our case, we have to meet those requirements, but we also have to meet the requirements that it's sustainably produced.
Reducing global temperatures and protecting our planet is a key generational challenge. Our mission at Aviox is to deliver the world's most technologically advanced refinery making sustainable aviation fuel. We believe that the plant will be highly profitable due to the very low cost of the waste materials as input material. We need the resolve and the capital to make a radical shift within our economy to make it modern, circular and sustainable. This is a once-in-a-lifetime opportunity to join a new wave of clean tech companies developing clean, green and sustainable aviation fuel, and it's a privilege to be part of it.
Airlines and aircraft makers are desperately searching to reduce their climate impacts. CO2 emissions amount to about 2% of the global total and 7% in the UK, and are increasing. But there are other impacts, such as the damaging contrails. Back in 2011, I was granted a patent for a novel way to generate power and hydrogen from hydrocarbons. Highly efficient fuel cells and electrolyzers make this possible. Using this patented process as a front end to a more conventional gas to liquids process, we can turn all sorts of worthless waste into high-value fuel, help clean up the environment, and solve the problems of disposal in one fell swoop.
Making sustainable aviation fuel in sufficient quantities is a massive chemical engineering challenge. We've already started building our bench scale system, which will just prove the concept. So we'll take some waste, which is our feedstock, and we'll create some fuel to demonstrate that the process actually works. The key step is then our demonstration system, which will be a 5,000 tonne per year plant, and that will be a very faithful reproduction of the larger scale plant that we're going to scale up to. Then we're going to scale up to our 30,000 tonne per year commercial plant, where we're making fuel, selling the fuel and making money for the business. Jet fuel is a tightly regulated product. In our case, we have to meet those requirements, but we also have to meet the requirements that it's sustainably produced.
Reducing global temperatures and protecting our planet is a key generational challenge. Our mission at Aviox is to deliver the world's most technologically advanced refinery making sustainable aviation fuel. We believe that the plant will be highly profitable due to the very low cost of the waste materials as input material. We need the resolve and the capital to make a radical shift within our economy to make it modern, circular and sustainable. This is a once-in-a-lifetime opportunity to join a new wave of clean tech companies developing clean, green and sustainable aviation fuel, and it's a privilege to be part of it.
Airlines and aircraft makers are desperately searching to reduce their climate impacts. CO2 emissions amount to about 2% of the global total and 7% in the UK, and are increasing. But there are other impacts, such as the damaging contrails. Back in 2011, I was granted a patent for a novel way to generate power and hydrogen from hydrocarbons. Highly efficient fuel cells and electrolyzers make this possible. Using this patented process as a front end to a more conventional gas to liquids process, we can turn all sorts of worthless waste into high-value fuel, help clean up the environment, and solve the problems of disposal in one fell swoop.
Making sustainable aviation fuel in sufficient quantities is a massive chemical engineering challenge. We've already started building our bench scale system, which will just prove the concept. So we'll take some waste, which is our feedstock, and we'll create some fuel to demonstrate that the process actually works. The key step is then our demonstration system, which will be a 5,000 ton per year plant, and that will be a very faithful reproduction of the larger scale plant that we're going to scale up to. Then we're going to scale up to our 30,000 ton per year commercial plant, where we're making fuel, selling the fuel and making money for the business. Jet fuel is a tightly regulated product. In our case, we have to meet those requirements, but we also have to meet the requirements that it's sustainably produced.
Reducing global temperatures and protecting our planet is a key generational challenge. Our mission at Aviox is to deliver the world's most technologically advanced refinery making sustainable aviation fuel. We believe that the plant will be highly profitable due to the very low cost of the waste materials as input material. We need the resolve and the capital to make a radical shift within our economy to make it modern, circular and sustainable. This is a once-in-a-lifetime opportunity to join a new wave of clean tech companies developing clean, green and sustainable aviation fuel, and it's a privilege to be part of it.
Airlines and aircraft makers are desperately searching to reduce their climate impacts. CO2 emissions amount to about 2% of the global total and 7% in the UK, and are increasing. But there are other impacts, such as the damaging contrails. Back in 2011, I was granted a patent for a novel way to generate power and hydrogen from hydrocarbons. Highly efficient fuel cells and electrolyzers make this possible. Using this patented process as a front end to a more conventional gas to liquids process, we can turn all sorts of worthless waste into high-value fuel, help clean up the environment, and solve the problems of disposal in one fell swoop.
Making sustainable aviation fuel in sufficient quantities is a massive chemical engineering challenge. We've already started building our bench scale system, which will just prove the concept. So we'll take some waste, which is our feedstock, and we'll create some fuel to demonstrate that the process actually works. The key step is then our demonstration system, which will be a 5,000 tonne per year plant, and that will be a very faithful reproduction of the larger scale plant that we're going to scale up to. Then we're going to scale up to our 30,000 tonne per year commercial plant, where we're making fuel, selling the fuel and making money for the business. Jet fuel is a tightly regulated product. In our case, we have to meet those requirements, but we also have to meet the requirements that it's sustainably produced.
Reducing global temperatures and protecting our planet is a key generational challenge. Our mission at Aviox is to deliver the world's most technologically advanced refinery making sustainable aviation fuel. We believe that the plant will be highly profitable due to the very low cost of the waste materials as input material. We need the resolve and the capital to make a radical shift within our economy to make it modern, circular and sustainable. This is a once-in-a-lifetime opportunity to join a new wave of clean tech companies developing clean, green and sustainable aviation fuel, and it's a privilege to be part of it.
Airlines and aircraft makers are desperately searching to reduce their climate impacts. CO2 emissions amount to about 2% of the global total and 7% in the UK, and are increasing. But there are other impacts, such as the damaging contrails. Back in 2011, I was granted a patent for a novel way to generate power and hydrogen from hydrocarbons. Highly efficient fuel cells and electrolyzers make this possible. Using this patented process as a front end to a more conventional gas to liquids process, we can turn all sorts of worthless waste into high-value fuel, help clean up the environment, and solve the problems of disposal in one fell swoop.
Making sustainable aviation fuel in sufficient quantities is a massive chemical engineering challenge. We've already started building our bench scale system, which will just prove the concept. So we'll take some waste, which is our feedstock, and we'll create some fuel to demonstrate that the process actually works. The key step is then our demonstration system, which will be a 5,000 tonne per year plant, and that will be a very faithful reproduction of the larger scale plant that we're going to scale up to. Then we're going to scale up to our 30,000 tonne per year commercial plant, where we're making fuel, selling the fuel and making money for the business. Jet fuel is a tightly regulated product. In our case, we have to meet those requirements, but we also have to meet the requirements that it's sustainably produced.
Reducing global temperatures and protecting our planet is a key generational challenge. Our mission at Aviox is to deliver the world's most technologically advanced refinery making sustainable aviation fuel. We believe that the plant will be highly profitable due to the very low cost of the waste materials as input material. We need the resolve and the capital to make a radical shift within our economy to make it modern, circular and sustainable. This is a once-in-a-lifetime opportunity to join a new wave of clean tech companies developing clean, green and sustainable aviation fuel, and it's a privilege to be part of it.
Airlines and aircraft makers are desperately searching to reduce their climate impacts. CO2 emissions amount to about 2% of the global total and 7% in the UK, and are increasing. But there are other impacts, such as the damaging contrails. Back in 2011, I was granted a patent for a novel way to generate power and hydrogen from hydrocarbons. Highly efficient fuel cells and electrolyzers make this possible. Using this patented process as a front end to a more conventional gas to liquids process, we can turn all sorts of worthless waste into high-value fuel, help clean up the environment, and solve the problems of disposal in one fell swoop.
Making sustainable aviation fuel in sufficient quantities is a massive chemical engineering challenge. We've already started building our bench scale system, which will just prove the concept. So we'll take some waste, which is our feedstock, and we'll create some fuel to demonstrate that the process actually works. The key step is then our demonstration system, which will be a 5,000 tonne per year plant, and that will be a very faithful reproduction of the larger scale plant that we're going to scale up to. Then we're going to scale up to our 30,000 tonne per year commercial plant, where we're making fuel, selling the fuel and making money for the business. Jet fuel is a tightly regulated product. In our case, we have to meet those requirements, but we also have to meet the requirements that it's sustainably produced.
Reducing global temperatures and protecting our planet is a key generational challenge. Our mission at Aviox is to deliver the world's most technologically advanced refinery making sustainable aviation fuel. We believe that the plant will be highly profitable due to the very low cost of the waste materials as input material. We need the resolve and the capital to make a radical shift within our economy to make it modern, circular and sustainable. This is a once-in-a-lifetime opportunity to join a new wave of clean tech companies developing clean, green and sustainable aviation fuel, and it's a privilege to be part of it.
Airlines and aircraft makers are desperately searching to reduce their climate impacts. CO2 emissions amount to about 2% of the global total and 7% in the UK, and are increasing. But there are other impacts, such as the damaging contrails. Back in 2011, I was granted a patent for a novel way to generate power and hydrogen from hydrocarbons. Highly efficient fuel cells and electrolyzers make this possible. Using this patented process as a front end to a more conventional gas to liquids process, we can turn all sorts of worthless waste into high-value fuel, help clean up the environment, and solve the problems of disposal in one fell swoop.
Making sustainable aviation fuel in sufficient quantities is a massive chemical engineering challenge. We've already started building our bench scale system, which will just prove the concept. So we'll take some waste, which is our feedstock, and we'll create some fuel to demonstrate that the process actually works. The key step is then our demonstration system, which will be a 5,000 tonne per year plant, and that will be a very faithful reproduction of the larger scale plant that we're going to scale up to. Then we're going to scale up to our 30,000 tonne per year commercial plant, where we're making fuel, selling the fuel and making money for the business. Jet fuel is a tightly regulated product. In our case, we have to meet those requirements, but we also have to meet the requirements that it's sustainably produced.
Reducing global temperatures and protecting our planet is a key generational challenge. Our mission at Aviox is to deliver the world's most technologically advanced refinery making sustainable aviation fuel. We believe that the plant will be highly profitable due to the very low cost of the waste materials as input material. We need the resolve and the capital to make a radical shift within our economy to make it modern, circular and sustainable. This is a once-in-a-lifetime opportunity to join a new wave of clean tech companies developing clean, green and sustainable aviation fuel, and it's a privilege to be part of it.
Airlines and aircraft makers are desperately searching to reduce their climate impacts. CO2 emissions amount to about 2% of the global total and 7% in the UK, and are increasing. But there are other impacts, such as the damaging contrails. Back in 2011, I was granted a patent for a novel way to generate power and hydrogen from hydrocarbons. Highly efficient fuel cells and electrolyzers make this possible. Using this patented process as a front end to a more conventional gas to liquids process, we can turn all sorts of worthless waste into high-value fuel, help clean up the environment, and solve the problems of disposal in one fell swoop.
Making sustainable aviation fuel in sufficient quantities is a massive chemical engineering challenge. We've already started building our bench scale system, which will just prove the concept. So we'll take some waste, which is our feedstock, and we'll create some fuel to demonstrate that the process actually works. The key step is then our demonstration system, which will be a 5,000 tonne per year plant, and that will be a very faithful reproduction of the larger scale plant that we're going to scale up to. Then we're going to scale up to our 30,000 tonne per year commercial plant, where we're making fuel, selling the fuel and making money for the business. Jet fuel is a tightly regulated product. In our case, we have to meet those requirements, but we also have to meet the requirements that it's sustainably produced.
Reducing global temperatures and protecting our planet is a key generational challenge. Our mission at Aviox is to deliver the world's most technologically advanced refinery making sustainable aviation fuel. We believe that the plant will be highly profitable due to the very low cost of the waste materials as input material. We need the resolve and the capital to make a radical shift within our economy to make it modern, circular and sustainable. This is a once-in-a-lifetime opportunity to join a new wave of clean tech companies developing clean, green and sustainable aviation fuel, and it's a privilege to be part of it.
Airlines and aircraft makers are desperately searching to reduce their climate impacts. CO2 emissions amount to about 2% of the global total and 7% in the UK, and are increasing. But there are other impacts, such as the damaging contrails. Back in 2011, I was granted a patent for a novel way to generate power and hydrogen from hydrocarbons. Highly efficient fuel cells and electrolyzers make this possible. Using this patented process as a front end to a more conventional gas to liquids process, we can turn all sorts of worthless waste into high-value fuel, help clean up the environment, and solve the problems of disposal in one fell swoop.
Making sustainable aviation fuel in sufficient quantities is a massive chemical engineering challenge. We've already started building our bench scale system, which will just prove the concept. So we'll take some waste, which is our feedstock, and we'll create some fuel to demonstrate that the process actually works. The key step is then our demonstration system, which will be a 5,000 tonne per year plant, and that will be a very faithful reproduction of the larger scale plant that we're going to scale up to. Then we're going to scale up to our 30,000 tonne per year commercial plant, where we're making fuel, selling the fuel and making money for the business. Jet fuel is a tightly regulated product. In our case, we have to meet those requirements, but we also have to meet the requirements that it's sustainably produced.
Reducing global temperatures and protecting our planet is a key generational challenge. Our mission at Aviox is to deliver the world's most technologically advanced refinery making sustainable aviation fuel. We believe that the plant will be highly profitable due to the very low cost of the waste materials as input material. We need the resolve and the capital to make a radical shift within our economy to make it modern, circular and sustainable. This is a once-in-a-lifetime opportunity to join a new wave of clean tech companies developing clean, green and sustainable aviation fuel, and it's a privilege to be part of it.
Airlines and aircraft makers are desperately searching to reduce their climate impacts. CO2 emissions amount to about 2% of the global total and 7% in the UK, and are increasing. But there are other impacts, such as the damaging contrails. Back in 2011, I was granted a patent for a novel way to generate power and hydrogen from hydrocarbons. Highly efficient fuel cells and electrolyzers make this possible. Using this patented process as a front end to a more conventional gas to liquids process, we can turn all sorts of worthless waste into high-value fuel, help clean up the environment, and solve the problems of disposal in one fell swoop.
Making sustainable aviation fuel in sufficient quantities is a massive chemical engineering challenge. We've already started building our bench scale system, which will just prove the concept. So we'll take some waste, which is our feedstock, and we'll create some fuel to demonstrate that the process actually works. The key step is then our demonstration system, which will be a 5,000 ton per year plant, and that will be a very faithful reproduction of the larger scale plant that we're going to scale up to. Then we're going to scale up to our 30,000 ton per year commercial plant, where we're making fuel, selling the fuel and making money for the business. Jet fuel is a tightly regulated product. In our case, we have to meet those requirements, but we also have to meet the requirements that it's sustainably produced.
Reducing global temperatures and protecting our planet is a key generational challenge. Our mission at Aviox is to deliver the world's most technologically advanced refinery making sustainable aviation fuel. We believe that the plant will be highly profitable due to the very low cost of the waste materials as input material. We need the resolve and the capital to make a radical shift within our economy to make it modern, circular and sustainable. This is a once-in-a-lifetime opportunity to join a new wave of clean tech companies developing clean, green and sustainable aviation fuel, and it's a privilege to be part of it.
Airlines and aircraft makers are desperately searching to reduce their climate impacts. CO2 emissions amount to about 2% of the global total and 7% in the UK, and are increasing. But there are other impacts, such as the damaging contrails. Back in 2011, I was granted a patent for a novel way to generate power and hydrogen from hydrocarbons. Highly efficient fuel cells and electrolyzers make this possible. Using this patented process as a front end to a more conventional gas to liquids process, we can turn all sorts of worthless waste into high-value fuel, help clean up the environment, and solve the problems of disposal in one fell swoop.
Making sustainable aviation fuel in sufficient quantities is a massive chemical engineering challenge. We've already started building our bench scale system, which will just prove the concept. So we'll take some waste, which is our feedstock, and we'll create some fuel to demonstrate that the process actually works. The key step is then our demonstration system, which will be a 5,000 tonne per year plant, and that will be a very faithful reproduction of the larger scale plant that we're going to scale up to. Then we're going to scale up to our 30,000 tonne per year commercial plant, where we're making fuel, selling the fuel and making money for the business. Jet fuel is a tightly regulated product. In our case, we have to meet those requirements, but we also have to meet the requirements that it's sustainably produced.
Reducing global temperatures and protecting our planet is a key generational challenge. Our mission at Aviox is to deliver the world's most technologically advanced refinery making sustainable aviation fuel. We believe that the plant will be highly profitable due to the very low cost of the waste materials as input material. We need the resolve and the capital to make a radical shift within our economy to make it modern, circular and sustainable. This is a once-in-a-lifetime opportunity to join a new wave of clean tech companies developing clean, green and sustainable aviation fuel, and it's a privilege to be part of it.
Airlines and aircraft makers are desperately searching to reduce their climate impacts. CO2 emissions amount to about 2% of the global total and 7% in the UK, and are increasing. But there are other impacts, such as the damaging contrails. Back in 2011, I was granted a patent for a novel way to generate power and hydrogen from hydrocarbons. Highly efficient fuel cells and electrolyzers make this possible. Using this patented process as a front end to a more conventional gas to liquids process, we can turn all sorts of worthless waste into high-value fuel, help clean up the environment, and solve the problems of disposal in one fell swoop.
Making sustainable aviation fuel in sufficient quantities is a massive chemical engineering challenge. We've already started building our bench scale system, which will just prove the concept. So we'll take some waste, which is our feedstock, and we'll create some fuel to demonstrate that the process actually works. The key step is then our demonstration system, which will be a 5,000 tonne per year plant, and that will be a very faithful reproduction of the larger scale plant that we're going to scale up to. Then we're going to scale up to our 30,000 tonne per year commercial plant, where we're making fuel, selling the fuel and making money for the business. Jet fuel is a tightly regulated product. In our case, we have to meet those requirements, but we also have to meet the requirements that it's sustainably produced.
Reducing global temperatures and protecting our planet is a key generational challenge. Our mission at Aviox is to deliver the world's most technologically advanced refinery making sustainable aviation fuel. We believe that the plant will be highly profitable due to the very low cost of the waste materials as input material. We need the resolve and the capital to make a radical shift within our economy to make it modern, circular and sustainable. This is a once-in-a-lifetime opportunity to join a new wave of clean tech companies developing clean, green, and sustainable aviation fuel, and it's a privilege to be part of it.
Right, welcome back, everybody. If we could take a seat, and we'll make a start for the afternoon session. Hopefully you all enjoyed the lunch, and just get the people in for a bit. All right. Okay, well, let's make a start for the afternoon session. So we're going to start with a keynote presentation from Boeing, and then we've got the final session for the showcase of the DFT-funded projects in this room. And then in Whittle Room next door, there'll be, at 2 o'clock, is the Fuel Pathways and Modelling Fuel Properties session, if you're interested in that, which looks at also the elements of, we've got a presentation on the US Clearinghouse, and pre-screening activity that's going on there, if you're interested in that. So, without further ado, I'm going to hand over to Brian Moran, who's Chief Sustainability Officer at Boeing.
Thank you. Hey, everybody. First of all, congratulations to Innovate UK Business Connect. What a heck of a meeting. I was just reflecting, we probably could have been around one of these tables not that many years ago, and now to take over an entire floor at the QE2, that's impressive. Hey, when Business Connect wrote, said, send me your charts, I did. So I didn't have a keynote with prepared remarks, so hopefully you're going to be entertained by a couple of visuals that I'm going to talk to, and then I really look forward to taking some questions afterwards. We always start with this slide, and this is a reminder first and foremost for ourselves on why we're here, why we're excited about decarbonizing aerospace by the middle of the century. It's the 4.5 billion people that took to the skies in just before the pandemic, and that number is going to nearly double over the next 20 years, as is the global fleet. We estimate there's about 43,000 airplanes needed between us and our competitors over the next 20 years. Economically, though, aviation is responsible for about 4.3%, 4.1% of global GDP. You've got the 87 million jobs up there. And then when you look at the UK and you zoom in a little bit, you can see 150 million passengers, 1.6 million supported jobs. And that's why in the UK, aerospace is so vital, and that's why, again, we're here today. So 2050, we talk a lot about this magic moment in 2050 that we all are going to hit. And so we put this collage together a couple years ago just to inspire ourselves, because if you look on the right there, we're going to have really cool new airplanes out there, radical new designs, but we're also going to have about 45,000+ conventional airplanes in the skies. And those will have to be powered by SAF. So that's one point and one data point to remember when we all talk about switching energy carriers. There are going to be a lot of conventional airplanes, which in 2050 are going to be around for another 20, 30 years. So we're well into the next half of the century before new energy carriers would take over at scale. We're also going to see a lot of eVTOLs or a lot of urban air mobility. We're excited, and we're actively working that space, as are many of our competitors. But those things on the left are not going to decarbonize aviation. And then in the middle, we're going to see, we're working on prototypes, we're working on future flight concepts. We're going to see some new energy carriers enter gradually by that point. But as you'll see, and I'll talk a little bit about this total climate impact model we developed called Cascade, they're only going to contribute a fraction of the total carbon intensity of our sector. And here it is for now, right? It's 2%, 2.5%, really well-known number. The problem with that number is it's going to go up as other sectors decarbonize and as aviation continues to grow at 2.5 times GDP, which it has historically grown. The other data point I use every time I get to speak to an audience like you is 4 out of 5 people on planet Earth have never even been on an airplane. And so when we all sit here, and many of us have flown here, we get to sort of opine about what 2050 will look like and which levers we get to pull. 80% of the world has never even had the privilege of being on an airplane. So it's really our job, and that's why this conference is exciting, to make it sustainable for them. So they have the opportunity of connecting commerce, of having the social connection that we deliver through aviation. So how do we do that? How do we decarbonize? And this is our view, and I think I'm very happy that really as an industry, I think we've rallied around these five levers that we get to pull. So the first one is fleet renewal. Unsurprisingly, as an OEM, job number one for us is to deliver safe and efficient airplanes, ramp up in production, and every generation of airplanes that we deliver, it's about 20 to 30% more efficient than the airplanes you replace. You heard Mark yesterday from Airbus. That's sort of generally accepted. That's what we deliver. We're very proud of that. We invest heavily in that. And that's job one. You see a little P-8 Poseidon, an anti-submarine warfare airplane there, which the Royal Air Force has also purchased. And while the military will never put sustainability ahead of combat effectiveness, there is a role to play. And even in fleet renewal, you take a KC-46 767 base tanker and you replace an old 707, you get an improvement. Second category is about operational efficiency, using the digital brains in the cockpit to make flying more efficient. You know, the work that Nats is doing here, the work we're doing on delivering new capabilities around weather updates, wind updates, continuous to send arrivals. We did a fantastic demonstration the other day across multiple regions, what we call multi-region trajectory-based operations. Eurocontrol estimates there's about 8 to 10% locked up in the skies, just in that pillar alone. And it's not just in the air, but it's also on the ground. Single engine taxi, maintenance procedures, retrofits of winglets, things like that. Third category is what we're all about here today, and that's renewable energy, particular SAF. And we'll talk a lot about SAF and the work Boeing has done there, but also how new energy carriers, electrification and hydrogen, will over time earn their way onto the airplanes safely. And then on the right, advanced technology, right? We're a technology company. This is what we do. We spend $4.5 billion a year on R&D and CapEx, more than we ever have spent, by the way, despite all the headwinds that we're currently facing. Because we're a technology company, we got to bring tomorrow's technology forward into the next airplanes. And then I normally almost skip over it because we take it for granted that we happen to be a sector that has a carbon offset and reduction scheme for international aviation. But since I really enjoyed the carbon removals panel yesterday, it was really well done. But there's an undertone of, well, you know what, CORSIA, wouldn't trust it. Or, you know, there's some bad actors in CORSIA, and there were a couple projects that are being heavily scrutinized. That's true. There were some bad actors. But the system is legally binding. The airlines are spending $1 billion a year on offsetting. And by the way, we're working very hard on making sure that removals are getting credit in CORSIA. We invested in one permanent removal company called Aquatic, which is an ocean-based technology. And we're working with them to get CORSIA credit because we believe, as was outlined yesterday, removals and offsets, by the way, removals are a form of offset. So when we use these terms as if they're different, I sort of lose a little bit. But removals and offsetting will be part of our bridge. It will be part of our solution. So it's in our interest to make it as robust and as verified as possible, but not to start picking winners and losers as long as they're certified by the bodies that do that for a living. I mentioned Cascade. So one of the things we found over the last couple of years that when we talk about zero emissions or no emissions in aviation, we often talk about the tailpipe. We don't take the total climate impact of the energy carrier into account. And so one of the things we did is we set out with MIT, with the Whittle Lab at Cambridge, with NASA, and with IATA, the Airline Association. And we mapped every flight in 2019 and the gigaton of emissions, the infamous 2% that I showed earlier, globally. Every flight, international and domestic, and you can map it. And it's at cascadeboeing.com. You can just play with it. It's an open source model. There isn't a single proprietary data point in there. It is not a marketing tool. It's a tool to service that we wanted to provide to allow folks to visualize, and especially regulators, to visualize and make assumptions around how will aviation grow, how will the availability of green hydrogen or the lack thereof impact the total life cycle emissions of a new technology that might come in. Not all SAF is created equal. What assumptions around life cycle intensity do you have? And so it basically, as you see on the left there, it allows you to basically do a snapshot and make your own assumptions. And it has a forecast mode, a little bit like ATAC's Waypoint 2050 or Destination 2050 here in Europe. Allows you to model, okay, what's my assumption? Again, we're not picking winners. We're not saying, well, this is the Boeing answer. It's you get to pick your own answer. And last week we had a fantastic event at the Royal Aeronautical Society up the street where we let an audience of industry, of government, academia, military play with forecast mode and make their own assumptions. And we had a really robust debate, also with some of our competitors in the room. Who will get the first and the last drop of hydrogen? If you're at a conference like this for the cement industry or the steel industry, their answer is hydrogen, by the way. So it's really healthy to have these debates, and we found this a bit as a public service to have the tool out there, and we continue to refine it. We welcome your feedback. If you can break it, let us know. But it's out there, and I hope you get to play with it a little bit. So what have we done on SAF? We're very proud of the history on SAF. We recognized very early on that SAF will be the biggest part of the contribution of our, if you look at the wedges, it's the biggest part. And it goes all the way back to the very first flight on SAF in 2008, before SAF was sexy. And oh, by the way, before SAF was sustainable. But we did this flight with Virgin, and which is fortuitous, and we're very proud of that just last fall, and celebrated this week, and you heard about it from Luke yesterday, some 15 years later, we did the first transatlantic 100% SAF flight with passengers on board. But in between, we've done a lot, and when we look at our SAF journey, there are really three things. One is, first and foremost, to de-risk the airplane and everything that touches the fuel. So the technology first. Second is about using SAF, right? We're a participant in this market, and so it's our obligation to send a demand signal into the market. And then third, it's about striking new partnerships globally, as you see some examples on the board here, to stimulate this market and come up with new creative ways of financing it, of creating offtake. So let me just click through some of these. JP is in the audience, and he'll be on a 100% SAF panel later. But this sort of hidden bullet here, we let the research approval for HEFA. He wrote that paper. So in 2011, he did the work, not just at 50% blend, but up to 100%. We did the technical work needed to validate, and then later through our board seat at ASTM, that 100% and that HEFA is safe to fly. And so again, with a little bit of pain, when we were debating HEFA caps, which is sustainable and robust, it pains me a little bit, but I also appreciate where the UK government is coming from in enabling markets for future technologies and some of the other pathways. But then you look at, we did the first 100% SAF flight with FedEx in 2018. And then we had a series of firsts with the first passenger flight, was on the 737 MAX with United, the run with our friends at Rolls-Royce here in the audience, all the way then to the 100% flight across the Atlantic. So that's the technical side. But we also, and I'll talk about this in a minute, we're hard at work on the 100% SAF compatibility, both from a fuel perspective, but also, most importantly, in our case, from the airplane perspective. In terms of usage, we've been using SAF on our deliveries for many, many years. Just a couple of months ago, we purchased 35 million liters of SAF. That equates to about 20% of our fuel use. Again, when you look at the global use of about a couple percent, it's us taking our own money in our hands and buying this stuff and sending a demand signal into the marketplace. And then I talked about some of these partnerships. We're very proud of the partnership we have with Sky Energy. We're helping them in the Pacific Northwest, where they're benefiting from the policy conditions and the blender's tax credit to set up a manufacturing facility. Us backing them and doing an offtake has recently, in part, inspired Macquarie to invest and double down on Sky. And then there are many other examples in the Middle East and Australia where we have just recently invested, in the latter case, in Wagner Corporation to set up capability down there. So what does it take to accelerate SAF? And by no means, reflecting on this chart, it's not circular by any means, because these lines sort of connect, and it's really just a matrix. But it starts with the R&D, right? And the hard work many of you guys are doing in this room, the work we're doing together at Sheffield. But then it's access to capital. And we had a fantastic event last year in Seattle, and we're going to repeat that this year in Montreal, where we convened aviation, the finance community, the regulator, and energy. Those are the four quadrants, right? And when you ask them, well, what does it take? The airlines are ready to buy, but not at any price. But they're paying a premium, especially corporates. The manufacturers need financing to build these facilities. And what do they need? And what does the financing community need? Well, they need policy. They need certainty. Again, which is why here I think the demand signals and the mandate that's been set here is an important first step. But just as important, if not more important, the revenue certainty mechanism that's being debated right now is the other side of that coin, right? De-risking that production and the green premium for some time to come. And we're seeing this play out differently all around the globe. I had a privilege of meeting the Singaporean transport minister not that long ago. And Singapore is piloting the minister got a question yesterday, the airplane passenger duty. Why don't we just use that money? It's what Singapore is doing. They're going to tax the tickets between $3 and $16. They're going to create a green fund, and they're going to take that exact money to buy down the green premium to reach 1% SAF by 2026, and they're keeping the door open to go to 3 to 5% by 2030. A lot of details to iron out, but it feels really pragmatic to take the money and then buy down the green premium, keep it in loop, if you will. So we talked about incentives, we talked about feedstock diversity. I mentioned it already in the context of CORSIA, but absolutely, we need an S in SAF. And that's not our job. That's the job of the likes of the Roundtable for Sustainable Biomaterials, who we've been supporting from day one, who have sort of their 12-point check plan. What's the indirect land use change? What's the water usage, et cetera? So when we talk about it, and when we're very quick to criticize production methodologies or regional differences, we need to rely on third parties, and they need to do a good job. I'm painfully aware that there are a few out there that haven't recently, but that doesn't mean the whole system is broken. We just need to wash out the bad actors and preserve the system. And then policies, we talked about it at length. So on 100% SAF compatibility, we announced this several years ago, hard at work, and doing a couple things. We developed a set of jet reference fluids so that we have sort of a stable patient to operate on and to reference against. We're testing the materials because, as many of you in this room know better than I do, but the challenge with this commitment that we've made is you have to be compatible at 100% and at 0% and everything in between, because these airplanes, we're not going to have 100% dedicated SAF airplanes. These airplanes will take off somewhere with 50% blend, land somewhere where there's no SAF available, and then go somewhere where there's more than 50. So the airplane will see everything between 0 and 100, and there might be a little left in the tank. And then everything that touches the fuel, right? The wings are the fuel tanks, for starters. The fuel system, the sensors, the fuel gauges. Fuel has a cooling property. It has a certain weight. So there's a lot to really study to make sure that these airplanes by 2030, which is tomorrow in our cycle, are going to be ready. And we're hard at work, and we're not just hard at work as Boeing, but we're very proud that we're leading a working group at the International Aerospace Environmental Group, IAEG, together with Airbus and many other partners, because this is a team sport. This is working with GE, Rolls-Royce, the whole ecosystem, because everything, as I said, that touches the fuel has to be able to handle it. And that's what we did last year there. We convened about 40 suppliers in Seattle to have a debate a bit like this, like what's on your mind? What do you worry about when you think about compatibility? And then we have the SAF dashboard. I was very intrigued yesterday to see some of the capabilities you guys are building. And it sits on BNEF data, who we found did a really nice job sort of sifting through announcements and doing the due diligence on what's real, what's not. And again, go to cascade.boeing.com. You can play with it. You can sort of see announced capacity. And then when you click in for the UK, there's that 0.5 metric tons that are forecasted to be available by 2030. With the 12 million tons we need in total, the 10% mandate by 2030 is 1.2. So you can see we're approaching halfway there. And that, again, gives me some hope. When we always talk about we're only 1% there, we're getting to some serious numbers. You got the 5 facilities here, but we talked about the policies needed for the capital to flow and for this number to increase dramatically. So little anecdote. This says SAF and. The folks behind the screen here thought it was a typo and removed the and I put it back in because we've been talking about it takes SAF, as I just described. SAF is foundational for us to decarbonize. Without it, we're not going to get there. And it'll take electrification and hydrogen to earn their way safely onto an airplane. So this little graphic here illuminates how we think about new product development. It starts with the green dot. Is it technically feasible? Can you do it? Right? How many Nobel Prizes in terms of battery density are we away of moving 20 people more than 200 nautical miles, which is sort of where we sit today? How are we going to move the hydrogen? How are we going to cool it? How do we prevent leaks? The flammability. I mean, all these questions on hydrogen and on electrification that we're asking ourselves. Then you ask yourself, if you've solved the technical part, which is hard in and of itself, you ask yourself, can you get it certified? And will it be as safe or safer than what it replaces? Because if the answer to that is no, you stop. You stop. That's it. Game over. But if you can safely certify it, then a whole other set of questions opens up. So you prove that you can do it, then you got to ask yourself, should you do it? Just because you can doesn't mean you should. And there are two really important questions. What's the value proposition? Not just to us as an OEM. Of course, we have to make money. But it's to our customers. Can they introduce an airplane where the turn time, instead of 25 minutes on a MAX, is an hour or longer? The whole business model changes. What about the airports? So can you make money? Does it make any sense, or do we disrupt the entire system? The house of cards falls apart. And then the final question, which might be the most important question, and hence why we did Cascade, is what's the total climate impact of the solution you just dropped into the system? What's your assumption around around electrification? How clean is your grid? Where is the green hydrogen coming from, and are we going to get it? 98% of hydrogen today is not green. But let's assume it is. Are we going to get it? And those are the decisions you have to, and the assumptions you have to make to close this circle. So it sounds a bit philosophical, but I just want to give you a bit like a sneak peek under the hood. This is what we think through day in, day out. And that's sort of the result, right? And we often show little cartoons and PowerPoints. Well, these are real. These are real products. Start with the top left. So the Demonstrator is a franchise that celebrated its 10th anniversary last year. We've had over 11 airplanes that we've taken, either from our customer in partnership or some of our own. This happens to be a 777-200 of our own, that we're stuffing with tomorrow's technology, and we're flying it today. Over the franchise history, we've flown 280 different technologies. Some of those include the little winglets that that are ubiquitous on airplanes. That was a 2012 demonstrator on a 737NG with American Airlines. It demonstrated that we can generate about a 1.52% improvement in aerodynamics and therefore in fuel burn. So now it's everywhere. So we onboarded that into the production system. But in that same year, we flew a fuel cell in the cargo bay with IHI. That fuel cell, 4 times the size of that desk, powered a coffee pot. You could do it. We proved that you can. Guess what? That didn't earn its way onto an airplane. Right now in this airplane, we're flying a gray water recycling system that Diehl in Germany makes, where the water you wash your hands with gets recycled and put into the toilet. Save about 200 kilos per flight. That's a couple people with luggage. But so aerodynamics, on the inside, we have recyclable sidewalls from a biodegradable plastic. We have 3D printed monuments and sort of cup holders, if you will, where we're taking recycling back and are working on our circularity. Very advanced aerodynamics with active laminar flow, you name it. So really exciting franchise. And then what we recently announced is we're going to have sort of the sister brand to EcoD, and that's the Demonstrator Explorer. So rather than committing a full airplane for a year in a flight test program, we're taking either one of our airplanes, or we just did this with United, where we took a 737 MAX 10, 100% SAF in one fuel tank, Jet A in the other, had a DC-8 from NASA flying behind it, measuring the contrails and actually doing the testing needed to figure out, okay, what are some of the emissions of SAF and how much better is it? So you can see we're demonstrating what we're talking about. Down there, Whisk, again, we're not going to decarbonize aerospace with an eVTOL, but it's our 6th generation vehicle. This one is going for flight test. We're the only company that's leading with autonomy first, because we believe to close the safety case and the business case, you need AI to handle hundreds of thousands of these or tens of thousands of these eventually in the airspace. And to close the business case, you can't put a pilot in the cockpit when you have 3 passengers. But the learning from this up into the Boeing company on a more autonomous operation, and the electrification. We're building the motors, we're building the thermal management system, we're building the battery stack, all in-house. So we're learning a lot about more electric architecture. By the way, that 787 has more than 1.5 megawatt of onboard generated electricity. So when we talk about electrification, we've been working on electrification for ages. But we need to be mindful that dropping a small airplane into the marketplace is not going to move the needle. So we have to really think about the value proposition I talked about earlier. Top right, probably one of the most exciting things. Here's the rendering of the X66, the Sustainable Flight Demonstrator, also referred to as the Transonic Truss Braced Wing. because of the shape of the wing that we're putting on top, what used to be two MD-90s that we've purchased. That's the actual picture. We're cutting it up now. We're putting that new architecture on board. You can see all that real estate under the wing for new engines. Whether they're conventional or open fan, we'll see. That hasn't been decided. But again, we're shooting for yet another 30% above what we know to be true today through aerodynamics, through propulsion, and the materials. And then our history on hydrogen. We often get painted as, well, you're not into hydrogen. And we are. And we've done a lot of demonstrations and de-risking of the various different components. This number here is a 16,000-gallon linerless composite cryogenic tank we built for a space application. We tested it beyond its design limits, and what you see here, the little white stuff, that's ice, because as you know, we keep hydrogen as minus 253 degrees Celsius. That's it, by the way, going through a tunnel. That also happens to be the size of a tank you'd need to power a regional jet, and we got some great questions on that yesterday. I'll let you decide where the passengers go when that's the tank in the regional jet. But again, we're doing the work, we're following that circle very carefully. Technically feasible, certifiable, is there value to it? And what's the total climate impact of a solution like that? We have a partnership in Japan, a hydrogen technology integration project that we're doing with METI. I was just in Japan checking on that. And again, we're doing a lot of the work to de-risk it, but we definitely think hydrogen is probably something for the second half of the century. And we've been saying this from day one. But that doesn't mean we're going to not work on it. Just to wrap up, before I take a question or two, super proud. I got to be based in the UK here, and my first managerial assignment in 2007. Got to sit on the board of the AMRC in Sheffield. When I see now how far we've come and how far Sheffield has come to also launch the Energy Innovation Center, where we're a proud first founding member. We got Zero Petroleum in the room. They're going to be on a panel later. Another great partnership with Patty and the team, helping them in Sheffield, thinking through the certification of their fuels. I talked about the P8 already. We're working with the MOD to help them think through decarbonizing, digital tools in their cockpits to fly more efficiently. That second pillar I showed. Promoting SAF initiatives, Luke did a fantastic job talking about Flight 100 yesterday. A proud moment in Parliament 2 nights ago to unveil the results. You saw the numbers. You know, we talk about this all day long. Oh, it's this much more, this much less. 64% fuel burn saving, 1% better energy, 40% lower particles and non-CO2 emissions, as validated by RMI, ICF, and many other partners. So, Jet Zero Council, I said this to the minister 2 nights ago, probably one of the most impressive forum that I've come across where government and industry come together to debate what's necessary, both on SAF and on advanced technology. Collaborate at industry events like this. And then supporting the MOD, where we proudly get to share different setups, because the MOD has an important role to play. And frankly, as I get to travel the world, probably no other military more advanced and more forward-leaning and progressive than what we've seen here in sending demand signals and demonstrating flights, et cetera. I'll end with this quote, and again, it seems a bit corny perhaps, but especially given the times we're going through right now, this gives me a lot of energy and gives me a lot of hope. When Bill Boeing, just 12 years after he founded the company, he made this statement basically as a rally cry to all of us. And that last sentence, that let no improvement to flying and flying ever pass us by, is what gives me hope. And when we think about that circle, I often think about that quote, because he admonished us, like, if there's going to be a sea change, if there's going to be a breakthrough, Boeing better be part of it. That's what happened when the 707 ushered in the jet age. That's what happened when we shrunk the world by 40% with the 747. That's what happened when we issued or produced the 787 as a first all-composite airplane. That's what happened when we went to the moon on the Apollo program. So again, with all the humility necessary, especially now, this gives me a lot of hope and a lot of confidence that we're going to be part of this future for a long time. Thanks.
Brian. Chris has got one. Just at the front. Thanks, Alan.
Yes, good afternoon. Chris Surgener from Green Air News.
Hi, Chris.
You mentioned about the 100% SAF capability of your aircraft by 2030.
Yeah.
How are you getting around the aromatics issue? You and presumably the engine manufacturers as well. Will aircraft be capable of flying without aromatics, as it were?
We don't know yet is the answer. I mean, there's these two parallel work streams going on, right? On the fuel side and then on the airplane. And we have to de-risk the airplane and all the gaskets and all the seals that get in touch with the fuel to think through are we going to change the airplane, the fuel, or both? And so that's where ASTM in particular, and that working group I just talked about, there'll be a release on this here any moment or in the coming days on how we as an ecosystem are coming together to figure that out. And again, I think it's the best example of this industry collaborating versus competing.
Thanks. If you could
There's one
just
back there.
hang on for the microphone, that would be great. Thank you. And while Alan puts on his running shoes and thanks a bit.
Take some more water
Sorry,
here.
yeah.
Hi, Henry Lawson from Eco-Pragma Capital, investor in this space. And I would respectfully point out that the jet age was actually kicked off by the de Havilland Comet.
Yeah, fair enough.
About 10 years before the 707, but never mind. The question for you is, the answer from all the airlines to the premium, the net premium that they will pay for SAF is always zero, of course. But realistically, that can't be the case. Right. Yes, you can close the gap with subsidies, but you as Boeing have the best catbird seat to be able to actually see what premium SAF, what's the realistic premium that SAF can actually go out at that will get it through the tipping point, will get it through that S-curve that we all know about. What do you think that premium is, given the modelling that you're doing?
I don't know why Boeing would have the best catbird seat to know how airlines purchase fuel and what they're willing to pay. So I can't give you an exact answer. By the way, I think you made that comment yesterday about the doors coming off the airplane. 170,000 of us at this company are working day in, day out to regain trust and confidence in Boeing. And I just want you to know, and frankly everybody to know, that we're not taking that lightly for a second, and that we know that we must, we can, and that we will do better. So I wanted to take that head on. So look, on the green premium, the way I think about it is it comes from both sides, right? The cost of carbon is rising, and whether that's the emissions trading schemes or just taxation. And then we're all trying to bring the cost of fuel down so that there's pressure from both sides. And that's really what the airlines have to model. And, you know, in the end, that premium will get passed on to the passengers. Willie Walsh at IATA was very, very forward about that. So, but I don't have a good answer on the sensitivity analysis what that amount is. So I'm sorry to disappoint.
That's great, thank you. I think in the interest of time, we'll leave the questions there. Are you around for a bit longer?
I'm around for a bit longer.
Well, so hopefully
Thank you.
can catch up with Brian
Awesome.
Later. So
Thank
let's
you.
join me in thanking Brian. Right, okay. Well, let's move on to the next session, which is part of the Department for Transport funded project showcase session. And in this session, we've got Arcadia eFuels, Willis Lease Finance Corporation, and Zero. So if I can invite Andy McNeil from Arcadia eFuels to the stage, please. Has he disappeared? Sorry? Yeah. I think. Just the green button.
The green button. Need my sunglasses here. So good afternoon, everyone. For those of you who haven't met me yet, I'm Andy McNeil. I'm UK Venture Manager with Arcadia eFuels. I'd like to take the next few minutes to introduce you to Arcadia eFuels, to those of you who don't know us as a company, and to share our take on the serious challenge the UK aviation sector is facing and the solution that we're offering. So start a little bit about us. So we're a pure play e-fuels developer. We plan to produce net zero e-SAF, e-kerosene, e-diesel and e-naphtha for the difficult to decarbonise sectors of aviation, maritime, international shipping, heavy plant and ultimately manufacturing. From a blank canvas in 2022, we now have 3 e-fuels projects underway. One on Teesside here in the UK, one in Vordingborg in southeast Denmark, and one at Corpus Christi in Texas in the US. Our founder and CEO, Amy Hebert, who's is hopefully joining us later this afternoon, has put together, actually myself aside, has put together a world-class team, kind of with extensive relationships and experience across the SAF value chain and the major capital project lifecycle. And that's in support of delivery of a strategy which is pretty simple. We're looking to design, build and operate an international portfolio of commercial scale e-fuels facilities. We're looking to innovatively use proven technology building blocks to produce ASTM compliant drop-in fuels, and I'll say a little bit more about our approach to that later. What do we mean by commercial scale? It's kind of a bit of a subjective term. For us at the moment, it means 80,000 tonnes per annum of e-fuels. It's not all e-SAF, but the majority of it's e-SAF. So these are, this is a serious and distinctive proposition. But we're already looking to the future, and we've got ambitious scale-up plans. We're targeting up to 800,000 tonnes per annum per plant by 2035. We may not always be able to do that in an individual location, but that's the ambition to bring economies of scale. So coming kind of back to the challenge, and there's a little bit of kind of reiteration here, but I think it's important, and this is how we look at the challenge. We have got a well-informed audience, but we're here because companies like Arcadia and our colleagues are needed. In the past few years, kind of UK transportation sector has overtaken power generation as the largest source of greenhouse gas emissions in the UK. We've heard a little bit about that yesterday, and it's coming increasingly into focus. The provisional data indicates that transport last year was about 35% of emissions in the UK. That's a lot. And aviation is about 8% of that, within that 35%. And as we've all seen the plots, most other sectors are trending down. Aviation's kind of underlying trend is going back up after we kind of get over the hiccup or the blip of the pandemic. And with continued potential for continued passenger growth, limited, I have to say, decarbonisation efforts and success so far in aviation. I think UK aviation sector, as a sector, is set to see its profile as a leading greenhouse gas emitter is going to increase, kind of year by year. Minister Brown yesterday mentioned that emissions from UK aviation are anticipated to overtake those from road transportation by 2030. So the light that's shining brightly on me at the moment is going to shine increasingly brightly on the aviation sector over the coming years. So we need to step up. We need to step up, and we need to be seen to be stepping up as a sector. We need to embrace in the UK the SAF mandate that's in the process of being legislated for, and we need to kind of show government and the public at large that as an industry we're capable of we're capable of delivering, and that ambition, we have ambitions to ensure that we're not the barrier to aviation decarbonisation. If we don't do this, this is the sort of the negative part of the conversation. I think your license to operate, social license to operate, is at risk for aviation, and as that spotlight shines brighter and brighter, that's going to come under more and more scrutiny. So, and if we don't get after this, the alternative is demand interventions, which none of us are looking for. We want to support growth in the sector. To kind of to that, and then kind of getting towards the role of staff, there's thoughtful long-term decarbonisation forecasts out there. We've all seen them. We've spoken about some of them, and they show that net zero for UK aviation is possible, but it's not going to be easy, and it's not going to be a competition between efficiency improvements, hydrogen, electrification, SAF. It's going to be all of it, and it's then going to be and then some, if we're going to get there. So, we spoke a bit about carbon removals. I heard about them yesterday, and I think they have got a part to play, but from, kind of from our perspective, we have to think carefully about what carbon removals mean as a tool to deliver net zero. They mean we continue to extract fossil hydrocarbons, combust the product, release the carbon, and then recapture it. So, SAF's part in that, IATA did an interesting study of studies recently. Many have seen it, and kind of it's a good way of averaging, kind of what the demand picture looks like for SAF. 50% of UK aviation decarbonisation in 2050 is probably going to come from SAF. Within that 50% is probably going to be eSAF. That could mean up to 4 million tonnes per annum of eSAF being required in the UK by 2050. That's enormous. So, kind of turning to kind of Arcadia and our approach, on the screen here you see our version of the building block. You've heard from some of our colleagues in other companies about what eSAF, how power to liquid SAF is produced. So I'm not going to labour, kind of labour that point. The recipe for us is simple, and I'll maybe just talk to the, briefly to the scale issue here, which is a little bit different to some of the numbers we were looking at earlier. So we're looking to take 360 megawatts of renewable electrons, add water to create zero carbon hydrogen, and then add 250,000 tonnes per annum of CO2. We then use the catalysts and the chemistry and the old-fashioned engineering to produce 80,000 tonnes per annum of e-fuels. That e-fuel has an ultra-low carbon intensity, less than 1 gram of CO2 per megajoule. And that's largely because we're entirely driven by electricity. We've no fired process and processes. So it's simple, but it's also serious. Assuming that our electrons come from renewable, from new offshore wind, the total capital investment along this value chain to deliver 80,000 tonnes per annum could be as much as £2 billion. So these are serious propositions, big capital projects. The sort of point of interest, if you like, on the flow chart there is probably the bit in the middle, which is everything on the left, everything on the right is proven, and in fact, in terms of the right-hand side, it's proven at a scale much beyond what we're planning to do in the early stages. That magic in the middle around reverse water gas shift, electrically heated, as I've said, the chemistry that's well understood, the engineering is now well advanced, so there is still, there's still work to be done there, but the residual technology risk is manageable. This is based on a Fischer-Tropsch pathway. We heard about that a little bit earlier. One of the advantages of the technology we're using here is high selectivity towards kerosene and or gas oil, so SAF and diesel, which means that we can target our product at the markets that we're looking towards. We're not tied to any one technology pathway. That's why there's no, there are no brand names on this slide. We're agnostic, as a lot of companies are. That means we can be flexible and adapt as the supply chain moves forward and bring energy and capital efficiencies to the market, which we can then embed. Our most mature project in Denmark, although we have actually already put together that supply chain consortium, and we're working with companies like Technip Energies, Topsoe Sasol, Hitachi, Plug Power, and Veolia. So, it's great to be able to lean on their experience. A little bit on Teesside. So there's a great team here from Tees Valley Combined Authority. I hope you've had a chance to talk to them. They're doing a great job of marketing and advocating for the area. Why did we choose Teesside? So in a large part, it's to do with the excitement in energy and support from local stakeholders. It's very much an area that's open for business.
and it's looking to the future and looking to restore some of its proud history in that area around manufacturing and economic activity. This kind of manifests itself in a kind of can-do approach to problem solving. There's a lot of activity in the Teesside area which is to be, which we can leverage and build on across carbon capture and storage, green hydrogen, low carbon hydrogen, and sustainable fuel projects. There's an exciting portfolio of land available. You can kind of see from that plot in the top right, this kind of browny grey areas. This was a very heavily industrialised area. That area has been clear-felled almost, and has been made available for redevelopment for developers such as ourselves. And last but not least, obviously, we as a producer, we need feedstocks. So the potential synergies in the area from e-fuels, carbon capture, utilisation and storage, and green hydrogen projects make this a very interesting place to try and put together a feedstock strategy for an e-fuels project. Yeah, just let me just jump then to the to just briefly, Michelle, just to kind of wrap. So we're providing a serious solution to a serious challenge. It's clear, the sector needs to step up, make sure that we're not seen as a barrier to decarbonisation. The task is a substantial one. We spoke about potentially 4 million tonnes per annum of e-fuels. That would be nearly 60 of our plants, the plant I've just described. But the economic potential that comes with that is enormous as well. By 2050, that could underpin 20 gigawatts of new electrical generation, 10 gigawatts of green hydrogen, and 14 million tonnes of carbon capture and utilisation. And to multiply the numbers, I talked about 2 billion per plant. That could be over $100 billion of investment into the UK, creating economic activity, creating jobs, and reducing dependency on imports of fossil kerosene currently, which comes from most of the UK. So I'll wrap there. Thank you for listening. Thanks to the DFT and the Advanced Fuels Fund for supporting us, and thank you to Michelle and the team at Innovate UK for bringing this event together and giving us the opportunity to speak. Thank you.
No problem. Thank you, Andy. Thank you. So, next up is Austin Willis from Willis Lease Finance Corporation. Thank you.
Thanks, Michelle. Good afternoon. My name is Austin Willis. I'm the CEO of Willis Lease Finance Corp. And I'm proud to say we've got some really smart, capable people working on this SAF project on behalf of the company. Unfortunately, they're not here with us today, so you've got me. I'm actually really pleased to have the opportunity to speak to you guys. I recall when we started this journey about 2 years ago looking into our SAF project, I was met with people that really wanted to collaborate around a project like this and other similar projects to try to improve the world and to try to improve aviation in general as a sector. And it's refreshing to see that, especially in my space in the aircraft and engine leasing business, which is very, very competitive and certainly not so collaborative. My day job is running a leasing company, so I'll save the more policy and technology-focused questions or points to my colleagues who are better equipped to answer those than I am. So there's really three segments to our core business. There's jet engine leasing, aircraft leasing, and financing, which is our balance sheet side of the business. Then we've got our services businesses, which support our leasing company, essentially vertical integrations that help us make ourselves better at leasing jet engines and aircraft to customers. And then the third segment is innovation. And while we're a public company, we're probably less beholden to quarterly results than I suspect a lot of our colleagues at other public companies are. So, we're looking 5, 10, 20 years into the future and asking ourselves, how do we participate and how do we profit from decarbonizing aviation, and how do we accelerate that process? So a few quick facts about us. We're not a big company, but we're not a small company either. We've got over 400 million in revenue, about 2.5 billion in assets owned and managed. We're all over the world. We have great relationships to over 95 aviation customers, airlines, MROs, OEMs. It's actually over 100. But you know, we're well placed to be able to support a project like this because of our connection to the different airlines and because of our ability to finance these sorts of things on our balance sheet. Brief history about the company. We were started in 1985 by the chairman and my dad, Charlie Willis. He mortgaged the house to buy a jet engine, put it on lease, and then that snowballed. In 1996, we had our IPO and we trade on the NASDAQ. 2013, we purchased a jet engine parts business that I started a few years earlier. 2016, we purchased a company called Total Engine Support in the UK that mainly does engine shop visit management and power plant consulting. We started 2 145 repair stations for jet engines, Work US and Work UK, that help us transition our engines more quickly from customer to customer. And in 2020, we started an airframe maintenance facility in Teesside in the UK. And that's sort of the reason why I'm walking you through this timeline, is that gets us to the interesting bit, which is why we're here today. Going back to what Andy said about the folks in Teesside and Tees Valley Combined Authority, they're really a forward-looking bunch of politicians, if I can call them that, or public servants. They made a real effort to come out and work with us to try to develop jobs in the region. And in fact, Ben Houchin's team came out to visit us in Florida and pitched us on the idea of co-sponsoring a sustainable aviation fuel project. My initial reaction was, Ben, I love you, but that's crazy. You know, what do we know about renewable fuels? But he essentially sold us on the concept that for the same reasons we've been successful at diversifying into different parts of aviation, we could add value here, and that's essentially through distribution. So our contacts and our knowledge within the aviation space and the relevant players. So touching quickly on our project. So the goal for the first project was really to create the smallest plant that we could that would still be commercially viable. And this is really for 2 reasons. One, we didn't want to spend millions of dollars on something that ultimately would produce 0 revenue. And 2, in order to prove the technology from a lender's perspective, it had to be done at scale. So a small pilot plant really wouldn't have achieved this. And this goes back to a point that you heard earlier about the one sort of less proven element of the technology, the reverse water gas shift. That has been proven out, but it's been proven out at a very small scale. So in order to prove out the whole project and the whole plant, it's got to be at a certain scale threshold. So Teesside isn't cheap with respect to electricity or renewable electricity or labor for that matter. So why Teesside? Why the UK? Frankly, a lot of it was opportunism. It was being presented with this opportunity by TVCA. But, you know, before we really considered this seriously, what got us over the line was what we viewed as the commitment from the British government on a bipartisan basis to really see this through and to support projects like this over the next few years. Oh, I got ahead of myself. So one thing I did want to touch on is the 50,000 liter per day commercial demonstration refinery is intended to be the first of a number of different refineries. The follow-ons are going to be 10x scale up of 500,000 liters per day. But as you know, as was mentioned earlier, really the pacing item for these is going to be renewable electricity, getting sufficient renewable electricity that qualifies for the additionality requirements. So our project, I know it says on here 2023, our project was actually started in 2022. when, as I mentioned, a small delegation came from London to pitch us on the concept. We initially were looking at the concept as natural gas as the key ingredient, but as we soon learned after doing a red flag analysis that wasn't suitable, we switched to green hydrogen, conducted a feasibility study with the help of a couple of really fantastic guys, Ed Craddock and Francesco from MUFG, who helped point out a lot of the commercial elements that we would need to address in order to make the project stronger and potentially more bankable. After securing LOIs that equaled over 100% of our nameplate offtake volume, we began the front-end engineering design, which we completed about a month ago. At the same time, we hired an engineering firm that conducted a technology readiness level assessment, a TRL assessment. And there's many, many, many other steps that I'm omitting between where we started and where we ultimately are today, but we've got limited time, so I won't go into them. Suffice to say, we were fortunate enough to be awarded a grant from the Advanced Fuel Fund last year, which was an incredible validation of our project. And we received planning permission to construct the plant a few months ago. So we're hoping to complete FID by early next year and commissioning late 2026, early 2027. We know it's ambitious, but we're trying to hold ourselves to account to get this project moving. In terms of the technology process, as I'm sure you're aware, there's a number of different PTL projects currently under development. I would say that we differ in technology in that our technology allows us to produce 100% SAF rather than an array of different co-products. And we've also got a very strong GHG score as part of it. I mentioned the TRL earlier, and this was touched on by Arcadia. There's nothing really new about the technology that's being presented or that we're putting together here. Reverse water gas shift, FT, upgrading, it's been around for a pretty long time. The only element that's different is the novel approach with which it's arranged. So because of that, the TRL that we received was in the high sevens, which essentially is the best you can get with it still being a first of its kind plant. Let's see. So in summary, that's a pretty brief synopsis of our project. I appreciate you guys giving me an audience here and letting me chat with you about this, especially as an energy outsider. This has been an incredible learning process for me. And in fact, I had one of our bankers very recently come to me and he asked me a question. I think he came from a consulting background, so they always have really good questions. He asked me, why do you at Willis, why do you deserve to win? And I had to think about that. You know, not being a fueling company, not being a Shell or a BP or you know, some of my colleagues here that have a lot of experience with renewable fuels. And ultimately, I think it's a few things. First, we're not looking to take over the world. We don't have to be the biggest. We just want to contribute to this process. So we're doing it in a measured, thoughtful way. We've got access to capital. That can't be underestimated how important that is, particularly in the pre-FID development phase. We're partnering with engineers and engineering companies that are frankly a lot smarter than we are, that we can rely upon to help us. And we're approaching this from the perspective and the view of the airlines, which I think is a little bit different than some others. So thanks a lot for your time. I really appreciate it. And
thank you very much.
That's it. Thank you.
Thank you. Right. Paddy Lowe from Zero is up next. So if you'd like to come to the stage, that'd be great. There's your slides. And you'll notice the whole team is branded out.
Thank you, Michelle. Great to be here. Yeah, correct about the lights. Yeah. It's very bright. So thank you for your interest so far. And thank you, Brian, actually, for the good mention earlier from Boeing. We've had terrific support from Boeing along the way, actually, and that's great acknowledgement of what we've done so far. I'm going to talk about the company, the basic information about the company, and what we've done within this Advanced Fuel Funds project. A bit about the team then. We were founded in 2020 by myself. I have a long background in Formula One, worked there 32 years in senior technical roles. And then Professor Nilay Shah, who's a chemical engineer from Imperial College, was my co-founder, and now running 4.5 years. So we are dedicated to synthetic fuels. We see that as the future for scale in the SAF market, but also in all the other liquid fuel markets that are out there that need to be addressed. And we're also looking at petrochemicals because, of course, it's all about making hydrocarbons in the end to replace fossil hydrocarbons, which is currently ubiquitous, actually, across almost every industry. We own and develop our own technology, and that's giving us some unique ability, and I'll move on to that a bit later. And we're presently about 55 full-time employees. You can see some of the team there in our facility, Plant 0.1, which is in Bicester, just near Oxford. So our process, we've seen a few diagrams so far, but essentially we're also taking carbon from the air, ultimately by direct air capture. I think as common with many players in this space, in the e-fuel space, we will use biogenic carbon to be pragmatic in the early days of scale. But ultimately, direct air capture is the pathway to truly growing this industry to the scale it needs to be to completely replace fossil fuels. And then obviously using green hydrogen as the other molecule. We often call the hydrogen the energy molecule and the carbon the utility molecule because we make hydrogen, which is great for energy, but has very low utility, very impractical to store and carry in mobility. We make it into a practical substance. I find it interesting that actually in biology there's no green hydrogen at play, or biology has to bring the carbon into play to make it practical. And there you see in orange is what we call direct FT. That's our proprietary process. And that encapsulates all of the carbon reduction, as well as the FT component, which combines the carbon and hydrogen to make your hydrocarbon. And we make fuels, which I'll come on to. What we call 100% drop-in, or increasingly replica. That's to say fuels that are exactly equivalent in chemistry to the existing fuels. Interesting, later there's another session on non-drop-in. We obviously see that as a future pathway as well. Effectively, our platform gives us the chemical authority, flexibility to make any of these three fuels, not at once, but as the primary target fuel at incredibly high yields. So some of these fuels we're making at a 95% yield from the imported feedstocks. And also making them to the recognized standards. So, for instance, we can make a replica of Jet A1, and that does involve, for instance, we had a question about aromatics. We make aromatics. We can make as many aromatics as we want, in fact. So we can tailor these fuels to exactly reproduce a Jet A1, and indeed in future superior fuels with lower density, etc. Or higher density, sorry, get it right. So that's the product, but then in terms of the process, as I said, very configurable, very selective, so very high yield, and also very simple, and that's giving a pathway to incredibly low capex and opex footprint. So as we've seen some numbers earlier, this is an industry that is incredibly capital intensive, needs to be very, very large ultimately. So the economic parameters around the process are very, very important to get right and develop. And that's where we are today. And with our team of 55 who are mostly chemists and engineers, obviously we are actually improving these attributes on a daily basis and will do forever. That's the nature of the business. So I'll bring my Formula One bit in at that point. Formula One is all about sprinting to more and more performance. That's measured in lap time. In our company, we position that as cost down is primarily the objective. We need to get the cost out of this product, and that will come through sprinting around technology development. So that may sound all like a lot of talk, but we have actually done it. You see on the left, that aircraft flew in late 2021, and we got the Guinness World Record for the first flight powered by synthetic fuel. Little side story on that. Guinness didn't want to put the word in that I suggested of entirely or 100%, because they said that they only do 100%. So clearly we've had lots of flights, I'm sure you've read about them, with part loads of synthetic fuel, but this was the first at 100%. And of course that's been done by others since then. But that's a real flight, properly regulated, as you need to do for any flight of an aircraft. So very proud of that part of our history. But we run lots of other vehicles and engines, as you see on the right, and many more besides. So, we like to see our products in action and show that they really work. And then our partnerships, I mentioned Boeing, so thanks to Brian and Anna, who are here for their support. We also work with Rolls-Royce in a joint project with the Royal Air Force on the right. Royal Air Force have been incredibly supportive of what we're doing. In fact, that flight was flown by the RAF, their chief test pilot. We're working with ADNOC in Abu Dhabi, Babcock on another flight project, and supported all the time by Intertek. Those of you in the industry will know they're one of the primary test houses for fuels around the world, so very important partner. And of course, Department for Transport, that's, thanks to Michelle and her team for all the support we've had so far, and going forward with that. And we're working on the ASTM side with the Turk at Sheffield, and with the new clearinghouse to bring forward these fuels, particularly the replica Jet A1, which I mentioned earlier. So as we know, this will be potentially one of the critical paths to getting any of these SAFs into the air. But particularly what's exciting with our fuel is that it will, in the pure form, be compatible with all aircraft as they are today and all legacy systems. So because of primarily the presence of the aromatics. Just a view here of our scale-up pathway. So even before these 4 pictures, we started in the laboratory, obviously, at very, very small scale. This small trailer was where we made fuel for the first flight. That made fuel at a site in Orkney. So that was an exciting stage in our history back in 2021. And then here in the second picture, this is our working plant in Bicester, which I'll come on to in a minute. Here we call this engineering scale, and then we move to the third, which will be the first of a kind plant, and then ultimately to the nth of a kind plant. So these are our stages of development. I mentioned earlier about sprints, so you see our pathway to first of a kind plant is very, very aggressive to be getting a plant that's of a viable size to capitalize, but can work and prove the model of function of this technology in a commercial context. So some more detail on the plant in Bicester. We launched it pretty much a year ago, which is an exciting day. It's operating the catalysis itself already at commercial scale. So those who are familiar with the chemistry, you have units of catalysis. FT itself particularly is very exothermic, so there's a limit to your catalysis unit, and from here you simply number up. So we have 1-tube rigs, we have multi-tube rigs. When we go to commercial scale, we will just simply have millions of units. So already working in this facility at the full commercial scale catalysis. Continuous R&D, as I mentioned, on the specifications of the product, and all of the specifications that we need for our commercial scale plants. And we have 3 trains in Vista are a single tube system, basically, which is about 1/10 of a litre. A 3 litre, which is for small-scale application of fuels to run engines and trials. And then our 45 litre system, which will make the fuel at scale for ASTM prove-out. As I said, 40 plus of our 55 staff are on the technical side, chemists and engineers, and we're running here 24/7 making fuel as we speak. We have a lot of our own analysis because the whole point of moving things really fast is to test things virtually real time. So we have our own analysis within the facility. So the next in prospect, I don't know if that graph is, the diagram is a bit faint, but you can see, get the idea. Very much a modular concept to build a plant at scale. So we take our catalysis into multi-tube systems, and we containerize that or use container footprint, and we have multiple containers. So this is a pathway to get these things out and running in the shortest possible time. We plan to operate this plant in 2026, and our scale point is finding that balance between economics and ability to move quickly. So, there are a number of fixed overheads in building these plants, particularly labor, and we find this point around 15 megawatts is our target scale. And so on to the fuel fund. What this fund is supporting is the development of the first of those modules. So this is the first extraction of our technology that's in plant 0.1 into the in-field module that will operate within the commercial scale. So you see the diagram there of the production module, and our commercial plant is likely to need about 15 or 20 of these units. So the grant is funding the work towards the certification of the fuels through ASTM and the design of this module, and then moving forward to the production of the first example and positioning it within the UK. And you see the candidate location there is actually in the Orkney Islands in the photo above. And just a little bit of a few words about the industry and the sector in general. A lot of discussion about scale and cost. I believe that synthetic fuels will come through quicker than any of us expect, as we've seen in many other industries in history. Even more, quite close to home, the development of solar power and wind power has, I believe, taken everybody by surprise in terms of the cost down and the rate of deployment that we now see. So I don't see that it will be any different in the synthetic fuels sector or the eSAF sector. I talk, by the way, about synthetic fuels in general. We see the sector as being much wider than simply aviation, and we need to address all of those different fuels and different sectors, and they will indeed complement each other. But cost is a really important point, and you see a graph there where fossil fuel will gradually get more expensive over the next 2 to 3 decades as extraction becomes more and more difficult. We see biofuels currently about four times fossil. We don't see a cost down avenue for biofuels or also fuels from waste, simply because of the limitations in feedstocks. Whereas we see in the world of synthetic fuels, there are all the opportunities for cost down because it's an entirely industrially based production. There are no feedstocks to buy, especially as we move into a world of direct air capture. And this graph where we show cost parity actually with fossil fuels within about a decade will of course be a game changer, and we like to bring the excitement of that to the group. And that's not wishful thinking. We've done a lot of work to substantiate that data point there. And scale, as you see, I don't believe the liquid fuels sector is going to get any smaller. It's going to get bigger, most particularly through aviation. And there we are. So thank you, Michelle. We like to say fuel reinvented because we think it's a whole new game.
Thank you very much. That was really interesting. Okay. So we've run over slightly, and we are going to start at 3 because we've got a really good final sessions with Sean Harris and a really good session on 100% SAF, worth sticking around for. If you could go and get yourself some refreshments and come back ready to start at 3, I'd very much appreciate it. And then we can let you go. So thank you, everybody.
Airlines and aircraft makers are desperately searching to reduce their climate impacts. CO2 emissions amount to about 2% of the global total and 7% in the UK, and are increasing. But there are other impacts, such as the damaging contrails. Back in 2011, I was granted a patent for a novel way to generate power and hydrogen from hydrocarbons. Highly efficient fuel cells and electrolyzers make this possible. Using this patented process as a front end to a more conventional gas to liquids process, we can turn all sorts of worthless waste into high value fuel, help clean up the environment and solve the problems of disposal in one fell swoop.
Making sustainable aviation fuel in sufficient quantities is a massive chemical engineering challenge. We've already started building our bench scale system, which will just prove the concept. So we'll take some waste, which is our feedstock, and we'll create some fuel to demonstrate that the process actually works. The key step is then our demonstration system, which will be a 5,000 ton per year plant, and that will be a very faithful reproduction of the larger scale plant that we're going to scale up to. Then we're going to scale up to our 30,000 ton per year commercial plant, where we're making fuel, selling the fuel and making money for the business. Jet fuel is a tightly regulated product. In our case, we have to meet those requirements, but we also have to meet the requirements that it's sustainably produced.
Reducing global temperatures and protecting our planet is a key generational challenge. Our mission at Aviox is to deliver the world's most technologically advanced refinery making sustainable aviation fuel. We believe that the plant will be highly profitable due to the very low cost of the waste materials as input material. We need the resolve and the capital to make a radical shift within our economy to make it modern, circular and sustainable. This is a once-in-a-lifetime opportunity to join a new wave of clean tech companies developing clean, green and sustainable aviation fuel, and it's a privilege to be part of it. This is a once-in-a-lifetime opportunity to join a new wave of clean tech companies developing clean, green and sustainable aviation fuel, and it's a privilege to be part of it.
Airlines and aircraft makers are desperately searching to reduce their climate impacts. CO2 emissions amount to about 2% of the global total and 7% in the UK, and are increasing. But there are other impacts, such as the damaging contrails. Back in 2011, I was granted a patent for a novel way to generate power and hydrogen from hydrocarbons. Highly efficient fuel cells and electrolyzers make this possible. Using this patented process as a front end to a more conventional gas to liquids process, we can turn all sorts of worthless waste into high value fuel, help clean up the environment and solve the problems of disposal in one fell swoop.
Making sustainable aviation fuel in sufficient quantities is a massive chemical engineering challenge. We've already started building our bench scale system, which will just prove the concept. So we'll take some waste, which is our feedstock, and we'll create some fuel to demonstrate that the process actually works. The key step is then our demonstration system, which will be a 5,000 tonne per year plant, and that will be a very faithful reproduction of the larger scale plant that we're going to scale up to. Then we're going to scale up to our 30,000 tonne per year commercial plant, where we're making fuel, selling the fuel and making money for the business. Jet fuel is a tightly regulated product. In our case, we have to meet those requirements, but we also have to meet the requirements that it's sustainably produced.
Reducing global temperatures and protecting our planet is a key generational challenge. Our mission at Aviox is to deliver the world's most technologically advanced refinery making sustainable aviation fuel. We believe that the plant will be highly profitable due to the very low cost of the waste materials as input material. We need the resolve and the capital to make a radical shift within our economy to make it modern, circular and sustainable. This is a once-in-a-lifetime opportunity to join a new wave of clean tech companies developing clean, green and sustainable aviation fuel, and it's a privilege to be part of it. Waste materials as input material. We need the resolve and the capital to make a radical shift within our economy to make it modern, circular and sustainable.
Airlines and aircraft makers are desperately searching to reduce their climate impacts. CO2 emissions amount to about 2% of the global total and 7% in the UK, and are increasing. But there are other impacts, such as the damaging contrails. Back in 2011, I was granted a patent for a novel way to generate power and hydrogen from hydrocarbons. Highly efficient fuel cells and electrolyzers make this possible. Using this patented process as a front end to a more conventional gas to liquids process, we can turn all sorts of worthless waste into high-value fuel, help clean up the environment and solve the problems of disposal in one fell swoop.
Making sustainable aviation fuel in sufficient quantities is a massive chemical engineering challenge. We've already started building our bench scale system, which will just prove the concept. So we'll take some waste, which is our feedstock, and we'll create some fuel to demonstrate that the process actually works. The key step is then our demonstration system, which will be a 5,000 tonne per year plant, and that will be a very faithful reproduction of the larger scale plant that we're going to scale up to. Then we're going to scale up to our 30,000 tonne per year commercial plant, where we're making fuel, selling the fuel and making money for the business. Jet fuel is a tightly regulated product. In our case, we have to meet those requirements, but we also have to meet the requirements that it's sustainably produced.
Reducing global temperatures and protecting our planet is a key generational challenge. Our mission at Aviox is to deliver the world's most technologically advanced refinery making sustainable aviation fuel. We believe that the plant will be highly profitable due to the very low cost of the waste materials as input material. We need the resolve and the capital to make a radical shift within our economy to make it modern, circular and sustainable. This is a once-in-a-lifetime opportunity to join a new wave of clean tech companies developing clean, green and sustainable aviation fuel, and it's a privilege to be part of it. Our mission at Aviox is to deliver the world's most technologically advanced refinery making sustainable aviation fuel. We believe that the plant will be highly profitable due to the very...
Airlines and aircraft makers are desperately searching to reduce their climate impacts. CO2 emissions amount to about 2% of the global total and 7% in the UK, and are increasing. But there are other impacts, such as the damaging contrails. Back in 2011, I was granted a patent for a novel way to generate power and hydrogen from hydrocarbons. Highly efficient fuel cells and electrolyzers make this possible. Using this patented process as a front end to a more conventional gas to liquids process, we can turn all sorts of worthless waste into high-value fuel, help clean up the environment, and solve the problems of disposal in one fell swoop.
Making sustainable aviation fuel in sufficient quantities is a massive chemical engineering challenge. We've already started building our bench scale system, which will just prove the concept. So we'll take some waste, which is our feedstock, and we'll create some fuel to demonstrate that the process actually works. The key step is then our demonstration system, which will be a 5,000 ton per year plant, and that will be a very faithful reproduction of the larger scale plant that we're going to scale up to. Then we're going to scale up to our 30,000 ton per year commercial plant, where we're making fuel, selling the fuel and making money for the business. Jet fuel is a tightly regulated product. In our case, we have to meet those requirements, but we also have to meet the requirements that it's sustainably produced.
Reducing global temperatures and protecting our planet is a key generational challenge. Our mission at Aviox is to deliver the world's most technologically advanced refinery making sustainable aviation fuel. We believe that the plant will be highly profitable due to the very low cost of the waste materials as input material. We need the resolve and the capital to make a radical shift within our economy to make it modern, circular, and sustainable. This is a once-in-a-lifetime opportunity to join a new wave of clean tech companies developing clean, green, and sustainable aviation fuel, and it's a privilege to be part of it.
Okay. Right. Welcome back, everybody. If we can take a seat, and we'll get started. Great. Okay. Yeah, we'll make a start because we've got people online as well, so they were watching this as well. So, right, well, so the final session, so thank you for bearing with us, and we've got a keynote presentation right now from the RAF, and then we're going to head straight into a really interesting 100% SAF session as well. So let's get started with the session, and then we can, we'll just wait for people to sit down. Okay. Right, well, it gives me great pleasure to welcome Sean Harris, CBE, who's Director of Support and Chief Engineer at the Royal Air Force. Thank you very much, Sean.
So, well, thanks everybody for thanks for the introduction. I heard earlier I was miking up behind, and I heard this session being bigged up, which is always a bit of a challenge, isn't it? Where you set the expectations very high, but hopefully I'll deliver for you. My picture was up there earlier. I've come in camouflage today to fit in with my environment. So hopefully you'll excuse that, but I really actually am a military officer. Absolute pleasure to be here, to be able to talk to you, and without bigging you up the other way, to such an important and to some people quite highly esteemed audience out there that are at the cutting edge of the cutting edge of this in sustainable aviation, and I see all of you, and hopefully by the end of this presentation you will see us as teammates on this journey, I think, in sustainable aviation, because this is a massive team sport. What I want to be able to try and put across to you is why this really matters to the UK Ministry of Defence. You know, why does it matter to militaries in particular? Why we want to and need to be a part of this team. And perhaps if I can leave you with why you might want us on your team as well, that would be a pretty good outcome for me. So, why does Defence care? I think it's very easy to take a somewhat cynical view to say that we've got to care because of policies. If we look back, obviously 2019, as a government organisation, we are part of, and the legislative requirements to reach net zero by 2050, and as a government organisation we've obviously got targets on us to deliver that. But to us it's about far more than that. It's not just because we've been told to, it's not just because there's a government target to do it. For Defence, at the strategic level, climate change is a serious national security consideration. All of our predictions going forwards in global trends see that the impacts of climate change are likely to cause more conflict in the world, sadly, and certainly more friction points, and certainly where there's competition for natural resources in areas where climate change impacts might reduce the availability of them. So for us, in our role at trying to protect the nation and protect us from appear to have lost a microphone. Oh, I've got it back. There you go. Somebody didn't like that. They shut me off. So for us, as the people who are trying to prevent conflict, trying to reduce the impacts of climate change strategically makes our job easier to reduce those conflict points. And why would we want to be part of the contributors to our own problem in the future. There's more to it than that, though, and hopefully as we go later in the presentation, you'll understand a little bit more about why we need to do this. You will see on there, so on the back of sort of higher level government documents and policy, the Ministry of Defence produced its own climate change and sustainability strategic approach in 2021. And it talks about defence being a fast follower. I'll talk about that a little bit in the future. From a Ministry of Defence perspective, what we've done is we've split up the various elements of climate change initiatives in a sectional approach, and it will not surprise you to know that the Royal Air Force has taken the defence aviation element of that, hence I'm here today. Other people in the Ministry of Defence fly aircraft. We fly a few more of them than some of the others, but so this is the Royal Air Force's lead, and hence our connection with sustainable aviation fuel. You'll see on the right there of the slide, we've also signed up to an aspiration to be the first net zero air force by 2040. Now that's a pretty tough gig, to be perfectly honest, but what does it do? What it does is it galvanises our organisation and drives people forward to not take their foot off the gas, if you'll excuse the unfortunate metaphor, to achieve the 2050 targets that we need. We know that's pretty tough to achieve, but it does set us a really good stretch target. Fast follower. So what does that mean? In 2023, we produced the Defence Aviation Net Zero Strategy as the lead in defence on net zero for aviation. What we then did is we worked with industry partners to put together a defence aviation net zero charter. And we've got various signatories to that from people across the defence industries, some of whom I know are in the room and are really valuable partners. So how we're working together as a team across defence on net zero. What does fast follower mean, though? I think in the past, defence industry, and it is in some areas, but definitely not all, defence industry has been seen as the technological leader. So there are lots of elements of things out there in technology that came from our need to pursue those from a defence perspective. In this area, you're the leaders, really, the people who aren't necessarily in the military, and sometimes the people who aren't in the defence sector. So this is why we're extremely keen to be part of this enterprise and to work with you to see what technologies are coming on. That enables us to help to influence in this space, and from a global perspective, we, as the Royal Air Force, signed up to a charter with the global air chiefs in 2022, so the chiefs of most of the other air forces around the globe on climate change. So we have the ability to influence in that space. We're also interested in looking at what technologies are coming on and which ones might be beneficial for us going forwards, and where are the areas that we might seek to invest more time and energy to help the military. So, you may notice, if you go and look at the Defence Aviation Net Zero Strategy, that it's got a lot of similarities with the UK's Department of Transport Jet Zero strategy. There's no accident in that, but actually it wasn't a copy. We started from a separate piece of work and then brought things together and went, do you know what, there's a lot of similarity, but that's because ultimately we're all seeking the same outcomes here. I think that if you were to look at the defence strategy, you will see that the drivers and motivators in there might be slightly different. And I'll come on to that a little bit in a minute. But but ultimately we are seeking the same things. This is one of the reasons why the Royal Air Force sits there as part of the UK Jet Zero Council, and why we're keen to be really active in this space. It is very much, and I can't emphasize it enough, I know I'm overemphasizing it, a team sport in how we do this, even if the reasons why we need to do it might be slightly different. Okay, so I said I'd come back to a bit more about why this matters to us, other than the strategic context. In our net zero strategy, we've identified 6 main reasons why this is important. I'm not going to go down and go through all of these on this slide, because I'll come on to it in a minute, because 5 of those particularly relate to sustainable aviation fuels, or where sustainable aviation fuels are a factor in us getting after them. Talked about drivers and motivators. So civil sector out there may see climate change regulation as an existential threat, or a potential existential threat. And so there's really, obviously very valid drivers to adapt business models to be able to protect your business. For the Ministry of Defence, this is about maintaining our ability to protect the nation. And as you'll see on the slides to come, this is not discretionary for us, just like it isn't discretionary for businesses who want to survive. It is not discretionary. There are elements that we could sit there and we may, from time to time, because of operational reasons, have exemptions or waivers to certain elements of legislation, but we can't ignore it. It's not discretionary. So we want the same outcome. Reasons for business may be protecting business, the survival of the business, and the existential threat there. For us, we don't do this. It impacts on our ability to protect the nation. So 5 of those 6 are where SAF can make a contribution. And I'll just go through these briefly, each in turn. Operational constraints. We operate globally. We have to be able to go wherever we are required in the world to be able to do the nation's business and protect people. And also to be involved in humanitarian aid as well. And I'll come on to that a little bit later. So as the environment changes out there, as we move to civil sector with greater percentages of sustainable aviation fuel, we need to be able to take fuel uplifts from anywhere. I need to be able to take any fuel I can from wherever it comes. So I can't afford to be in a position where my aircraft are not compatible with what's out there in the marketplace. The marketplace is shifting and will shift. We have to move with it, otherwise we will constrain ourselves operationally. Operational resilience. I think we've all seen, particularly from Russia's actions with respect to Ukraine, that the volatility in energy supplies, and particularly in fossil fuels, and what that can do. There's the economic aspects of that, and some could argue economic warfare that can be done through our reliance on fossil fuels from other areas, which is where sustainable aviation fuels and the UK sustainable aviation fuels enterprise and industry is particularly important to us for resilience. And then even down to a local level for us, the fact that we could end up in a position where our fuel supplies are shut off and therefore impede our ability to operate and do our job is a serious consideration for us. So the ability to have that national enterprise that can generate fuel, and perhaps even in the future, our ability to synthetically generate fuel at the point of need, is an important consideration for us. Legitimacy to operate. We've called license to operate. So if you imagine we go into, say, a hurricane hit area in the Caribbean, hurricane that's arguably been caused by the impacts of climate change, or the likelihood of that caused by the impacts of climate change. It'll be pretty difficult, I think, for us operating in the future to go into those areas as a net generator of that problem, as an emitter of carbons, as the people who are going out there to try and actually recover from the problem, to be building tomorrow's problem. So it's definitely a reason why we need to consider this. Workforce. Any of the engineering and technology sectors, we are all out there trying to attract the best people. For us, some of this is about our cognitive edge against our adversaries. We need the smartest people within defence industry to outsmart the others in technology and in rapid advancement. A significant amount of our talented workforce out there, and we'll have some definitely in the room today, they are all over climate change. This is important, as it should be to them. So if we're not able to tap into that workforce because we are not on this journey with you, we won't be able to do our job in the future. We have to be able to engage with them, and we have to get some of the smartest people involved in defence sector working on these problems. This is not just a civil sector thing. This is something for all of us, and we need to be able to attract those individuals. Although we're a smaller part of the aviation fuel market within the United Kingdom, what we are, hopefully, and if there's any of the suppliers out there, don't come and beat me up at the end of it, but what we hopefully are is a reliable customer. We are the government, right? So when we're coming out and buying fuels, and where we turn to buy fuels, it is hopefully a reliable, consistent customer base. And I think that hopefully gives us the ability to work with you to build confidence in the sector as we increase our elements of sustainable aviation fuel that we're buying as a reliable, confident customer. Okay, so what this slide shows is we have a number of strategic themes of ways that we know we need to attack to reach our 2040 aspiration of being a net zero air force, but in reality of making sure that we hit the government target of 2050 for net zero. You will see on the pie chart there on the, he says I'm doing right and left here, so on your right, on the pie chart on your right, the light blue, that is the calculations that we've made of the contribution that we need to get from sustainable aviation fuel at the moment to hit our targets. There are a variety of other factors that we can put in there, which, you know, I can definitely bore some people with later if you're around. I'll hang around for a while, but given this is a sustainable aviation fuel conference, I'll concentrate on SAF. But whatever we do in those other areas, we still need to get a significant proportion of a significant proportion of our achievements of those targets relies on SAF. It is the backbone of our plan. There are other things out there, obviously. You know, there are people looking at electric, there are people looking at hydrogen. But where the technology is, we have some aircraft that are very similar to civil. You know, some of our transport aircraft, it's a similar role. But the top end of what we do is about performance, it's not about efficiency. It's about having the power. If we're talking about fighter aircraft, that we need to be able to be better than the others out there to be able to achieve our task, we're not going to get there in the short term with anything but a replacement for existing aviation fuels. That's why SAF is massively important for us. We've got nowhere else to go on that one. It is the backbone of our plan. So our approach to this, three main things. So what we're out there doing at the moment in the marketplace is exploring the technology. I'll give you some examples of this in a moment. Seeing what's out there. I talked about us being part of the team and kind of looking out there at what you're doing in that fast follower role and seeing what might be relevant to us and dipping our toe in different elements of it to see what's relevant for us in the future, what's going to help us strategically. Then there's something about operationalizing this. And we're trying to get after that. So what does this actually mean to move from existing fuel sources into sustainable aviation fuel sources? And there's various reasons why we might, as others in the sector are, why we might have more interest in fuels that aren't necessarily drop-in at the moment than civil sector might be interested in more drop-in. And certainly we need to be future-proofing for fuels that aren't drop-in at the moment. And we're keen to lead the work on standardisation in that area, or, well, lead the work. We're keen to influence the work on standardisation in that area because we're interested in what that means for clearances and regulation on some of our aircraft, which we won't get from the civil sector. And then the last bit is us adapting to the commercial markets. So I'm sure, and apologies for not having been here for some of the previous presentations, but I'm sure you've heard some things about how the markets are changing with respect to buying up fuels or buying up sources in advance rather than probably where we are in the marketplace today. We've got to work out how does that work in our interaction with the fuel suppliers, fuel producers for defence to make sure we can assure our outputs. So I will just give you a few brief examples of some things that we've been doing. So one of the things is a collaboration that the RAF Rapid Capabilities Office has been doing with Zero. As I think I saw some people from Zero earlier wandering around. So UK-based synthetic fuel producer. This is us dipping our toe in because we're interested in what this technology means. And I talked to you earlier about the ability to, the resilience aspects of being able to generate your own fuel potentially somewhere, which is important to us, to understand what that might mean. And what that led to us doing in this collaboration is the first synthetically fueled flight. We're moving forward where we want to be able to produce fuel in sufficient quantities to be able to, at some point, conduct 100% synthetic flight on a combat aircraft. Other work in this area, we've got an important collaboration, and I know there's many other partners in the room today, with Cambridge University's Aviation Impact Accelerator, and some great, interesting work going on in there that we're sort of picking out from that. What's the bits that are defence specific, actually? Because there's some stuff in there where there's defence things that other areas of research haven't gone into. And there's some fascinating work and collaboration. Before the much publicised Virgin flight, which was brilliant, wasn't it? The transatlantic flight. November 2022, we worked in collaboration with Airbus and Air Tanker and Rolls-Royce Defence Equipment and Support, and also got some fuel from Air BP and conducted the first military wide-body flight on 100% sustainable aviation fuel with one of our Voyager aircraft, an A330 derivative. Great collaboration with industry. Industry got a lot of good stuff out of that. There's a lot of good data came out of that flight, which I think has assisted other things and will assist other things in the industry. From us, we weren't just looking at the aircraft. We looked at the whole supply chain. And this was a type of fuel where we hadn't added in some of the aromatics, etc. So really gave us a good test of what it meant to the aircraft's performance with that fuel, but also what it meant to our whole supply chain, storing, transporting, how easy was that? And we got some great lessons out of that. What we then did was, although we've got aircraft that are certified to a 50% drop-in blend, we hadn't actually tried it out. So we used the residual 100% fuel from that, blended it to about 40, just over 40%. And then because the Voyagers are air-to-air refueling aircraft, we sent it up and they air-to-air refueled some of our Typhoon aircraft and some C-130s at the time. So we got a lot of useful information from that, and a great collaboration. Routine procurement. So this is the bit about understanding the markets and how we work with you. We are working really closely with Department for Transport on the SAF mandate, and we will comply. And actually, there's some real advantages in that mandate for us as well. We generally, our fuel generally comes down some of the distribution pipelines in the UK. We have some areas where we've got our own access to pipelines, which makes it easier for us to introduce sustainable aviation fuel into that, which we bought ourselves through the markets. And we're starting to ramp up our acquisition of sustainable aviation fuel to bring into the MOD's system. But in the longer term, because we've got shared pipelines with Civil, we need to be on the same journey with Civil. As the percentages go up in those pipelines, that's advantageous to us as well, because we can't just buy our own fuel and put it in the pipeline because it mixes with everybody else's. And it won't be at the percentages that we need. So there's some real advantages in this. Because at the moment, like anybody else, if we want to get higher percentages of SAF, we're having to ship it in, and we have done that for some specific flights. And you'll see things that we've done out there in the news for particular VIP flights out there when UK's doing global engagement, where we have brought in sustainable aviation fuel for our aircraft that have transported VIPs around the world. But there's more to be done. And the last point on that, in terms of constraints to the airlines, I mean, the cost point is important for all of us. The cost thing for us is we're dealing with public money, with taxpayers' money, and so we're out there, as you would hope we would be, trying to get the best value for money for all of you who are UK taxpayers as well. So we have a real interest in driving down the price points on this, because we'd like to go further, but we've got to balance that against what we can afford in our value for money use of your taxpayers' money. And I come to sort of last slide. I've covered most of this already. So we're working with Department for Transport to meet the UK's SAF mandate, scaling up that supply for all of us, and you will have heard loads about it, and I'm sure there's been a lot of people in the room over the last couple of days talking about this. So scaling up that supply is a challenge, and we want to do all that we can to help influence in that space as the UK government's customer. Ultimately, we're the biggest government consumer of aviation fuel. We're also interested in where things are going on feedstock availability. We in this room are in the aviation sector, that's why we're here, but of course those feedstocks have the potential to be used for fuel for other sectors. So for us, and you'll see from that percentage that I need to get to on our utilisation of SAF to be able to achieve our targets, we're watching really closely what the availability of the fuel's going to be like. And I've talked a little bit about non-drop-in fuel specifications, which obviously has advantages in terms of the carbon emissions there, but we're interested in working with people on what the specs of those might look like, and what the implications are for our aircraft as well as everybody else's aircraft going forward. And on that note, hopefully we might have a couple of minutes for questions, I don't know.
Any questions at all? Do we have any audience? We've got time for one or two.
Oh, question. Don't be shy, by the way. I'm like...
We've got one that's from Chris at the back there.
Hi, Chris. How you doing?
Can you wait for the microphone? Sorry. Just otherwise
Thanks. I did this the other day with somebody, and it was the same thing. I was just trying to hear, but I guess it's being around aircraft for too long, isn't it?
Hi, it's Chris Hancock here from Aviox.
Hi, Chris.
You may have mentioned it, or you may not be able to disclose it, but can you give an indication of the volume of fuel that you use annually?
So I don't have those figures, and actually, I mean, it's not like cloak and dagger super secret, but probably wouldn't want to give out exactly that. I don't have the figures with me. I'll see what I can get hold of, but I'm not sure what's out there in the public domain on that.
Yeah, it'd just be interesting to understand from a commercial standpoint, because I think at the moment it's 9.6 million tonnes per year for civil.
Yeah, so I mean, you could probably do the maths on it. I think we're about 2%. We're about 2% of the UK kind of market out there, so it's not huge, but I would say this, but I think it's an important element given the fact that, as I say, we are the government's customer, if you like.
Sure. Well, thanks very much. And I think the quality point that you made was very interesting.
Okay, who else we got? Somebody must want to ask me something difficult. Oh, hi.
Yeah, it's Glenn Morgan from Clear Skies.
Hi, Glenn.
You haven't mentioned, you said fast follower. What about sort of things in advanced propulsion and drone/technologies are obviously driving innovation?
Yeah, absolutely. So we do have some work going on in those areas. I think there's quite a bit of the drone work that isn't SAF. So what I could have talked about in there, and I was trying to target in on SAF, but so we are doing work in other forms of propulsion. It doesn't lend itself to the high end of what we do, but there is work going on for training aircraft, for drones, in those sort of areas. So we are engaged in that work.
Okay, that's great, thanks. I think in the interest of time,
Yeah.
we'll keep that there because we need to finish on time. There's a gentleman at the table at the front that has a question for you. Perhaps he can catch
I
you
can pop down and
before you
I can pop down and chat.
disappear. That'd be great. So, thank you very much. If we could give Sean a round of applause, please. Thank you. Great. So I'm just going to invite on my colleague Joanna Baldry, who's going to chair the next session. So you're probably sick of me by now, so we'll swap over. And she'll introduce her colleagues for this next panel discussion.
I'm just going to... good, they work. Okay, so my name's Joanna Baldry. I run my own fuels product quality consultancy, but that's on the back of 25 years doing aviation fuels R&D with Shell, including sort of first GTL flights, work with Virent on the SAK and with other technologies, so I've got some experience. Anyway, So good afternoon. Welcome to this final session where we'll look to the future, one with no more fossil fuel being used in aircraft. And this is a step change from today's SAFs containing at most 50% sustainable synthetic blending components, or SBCs. This is a future probably with fewer in-flight emissions products, such as particulates and persistent contrails, not just reduced CO2 footprints. So quite apart from the challenges of accessing the necessary volumes of SBCs for this future, how do we get to 100% SAFs? What will they need to look like? What will be their key performance requirements? But we do need the horse before the cart, so this session is going to be strictly technical, focusing on defining fuels that are technically suitable and safe for flying. And then getting into sustainability and costs is premature at this stage. So our three speakers, who I'll come to in a moment, are going to explain the current activities underway in defining and producing specifications for the two main classes of SAFs that we anticipate in the future. The first type is called drop-in, and the second non-drop-in, more later. Once these specs have been agreed at ASTM, then the aircraft and engine OEMs and fuel suppliers will be able to design for the future. Now, drop-in fuels won't require new aircraft or fuel supply infrastructures, but non-drop-in fuels will. So the OEM wish lists for such fuels, which will be performance features that the fuels must provide, may need to be tweaked to reflect fuel supply realities and challenges. But there will have to be somewhere to start if the lengthy airframe and engine design processes are going to be able to deliver on time. So now I'll hand over to the three OEMs who's going to talk about developing specifications, the R&D they have already done and are undertaking, and what they hope to achieve with 100% fuels. They'll all talk, and then we'll open the floor for questions, and the floor is also online. So I'll hand over, and I think the order we're going is Alasdair Hobday, who works for Rolls-Royce, then David Parmiter, who works for Airbus, and finally JP, who works for Boeing. So let them give their presentations, and then over to you guys. Thank you.
Okay, hi everybody, thanks for that, Joanna. So yeah, I'll just try and give you a bit of a flavour as to the sort of things us as a technical OEM team working very closely with David and JP and many other engine and airframe manufacturers. As Sean was alluding to just now, this is very much a team sport, and I think the sustainability landscape is one where we operate very effectively as a technical group. Should I press the button? Okay, so just a bit of a heads up really around the sort of SAF landscape and how we see it, just so people are clear, given that this is a sort of technically focused session. At the moment, we're in a world where up to 50% drop-in is permitted, as Joanna described, the synthetic blending components. We've got 8 approved today within the 7566 specification. But there's more to come. It's becoming a complex document. Those of you who are familiar with it, the D7566 document, but there will be more to come. But currently, you're allowed up to 50% of that material with fossil fuel, and then that material is recertified and re-identified as Jet A, Jet A1 fuel, so that can go into the fungible supply chain with conventional fuels. So that's where we are today. That's all good. Yes, there's not enough products out there, but the technical clearance is in place. The next thing to challenge us really is that 100% drop-in, which we've talked a lot about. So that specification change is the start of that is in technical discussion within the OEM team. That'll essentially produce a purely renewable material that is still technically equivalent to Jet A, Jet A1. So there'll be no new specification to define that. It's merely changes to the what's permitted through the 7566 specification. And I say that's in discussion with the OEM team at the moment. And they are the key goalkeepers and gatekeepers of the technical suitability of these fuels. So when people talk about ASTM approving things, that's not actually true. ASTM don't actually approve or certify anything. They're the spec, essentially the spec holder. but the technical qualification is to the ASTM standards, and the OEMs, such as ourselves and the guys on the stage, we certify equipment alongside the regulators to particular fuel specifications. That's how it all works. Then the final part of the journey, really, which is ongoing but will take a bit longer, is this concept of a non-drop-in specification. So the key difference here, you're talking about a fuel that's got essentially zero aromatic hydrocarbons. And you've heard all the information around the potential for reduced particulates and what used to be called smoke in the exhaust, and the contrail influence they can have. Contrail and atmospheric science is still a very young science. There's still a lot to learn on that, but the indications are there are benefits to be had. There's also some key challenges with a non-drop-in specification. It will require a new fuel specification. That's something in the jet fuel world we've not done for many years, pretty much since we changed from operating on gasoline. So when this won't be equivalent to a Jet A, Jet A1, it'll have a new ASTM specification designation when we get to that point. But really, that we're on that journey. We're working as an OEM team to understand what that fuel would need to look like and what it should look like. And you've heard the dates of 2030 for engine and airframes being capable on a range of 100% drop-in and non-drop-in fuels. And the ideal outcome is agnostic equipment that doesn't really care whether it's drop-in or non-drop-in. Just a bit in terms of what we've been doing as an organisation. A couple of years ago, we made some commitments around demonstrating engine capability on 100% SAF, and what that means is the capability word was chosen carefully around compatibility, in that it's really showing that we can operate existing engines on these fuel types that are 100% synthetic in nature. So that's not saying these engines are certified. That's not true at the moment because that specification isn't out there, but that the fundamental operation of the engine in terms of performance, handling, starting, all those kind of things, relight, are all equivalent or better to conventional fuels. And you can see some examples there. Some of these have been talked about. Dave's going to talk about the ECLIF program on the left in a few minutes. Just the middle one there, the Trent 1000 on the 747. Rolls-Royce actually owns a 747 aircraft that we use as a flying test bed. So that particular engine is in what we call the test position, the Trent 1000 engine on the test position, and we flew that aircraft on 100% HEFA a couple of years ago now. Sean mentioned the MRTT Voyager, which we also flew on 100% HEFA. That was a service aircraft that we took out of service operation and flew on an aromatic-free fuel. So quite a landmark thing, and the first dual-engine takeoff on HEFA or on 100% SAF full stop in the UK a couple of years ago. So, and these are all the data generated by these programs is key as we move forward towards a potential certification activity on non-drop-in fuels, because you'll see along the top most of the pathways are HEFA that we've evaluated, and that's, as you're probably all aware now, that's a good reason for that. That's the one that's available in significant quantities, and ultimately that non-drop-in specification will look a lot like a HEFA type fuel. And the final one really was just to put a bit of Rolls-Royce flavour around what you've heard about already, the transatlantic flight. So this was a significant effort. I was fortunate to be involved in this from day one, and along with my colleague Katja, we were both on the flight across the Atlantic, which was fantastic. But just as a bit of extra flavour, the sort of things we need to think about as OEMs. So you generate a blend of two fuels, as you've heard, a paraffinic and an aromatic pathway, and you generate some property data. It looks a lot like a Jet A, Jet A1. But the things we need to be careful of are those things that aren't defined in the specification, those kind of fitness for purpose properties, things like bulk modulus, surface tension, sort of vapor pressure characteristics, specific heat capacity, all these kind of technical nuances that we know and love and understand what fossil fuels look like with those sort of properties, but we're still learning that to make sure that the synthetic fuels still sit within the tram lines that we understand. So we did a lot of work to characterise the fuel we used on the flight to make sure it was fully compliant with what we understand. And you know, essentially the level of rigor we went in to deliver this flight was almost equivalent to an engine level certification to reassure the regulators that what we did was safe and good to go. And I think the other thing to mention on this is the fact that we were able to return the aircraft to service the next day. So we did a lot of work to understand any risks associated with that. You know, we were able to just defuel the aircraft, essentially refuel it with Jet A and fly back. And again, I think that's all a very important part of the journey towards agnostic behaviour of the engine and the airframe. So on that, given that we're a bit short of time, I'll hand over to Dave. Thank you.
Okay, good afternoon, everybody. I'm David Parmenter from Airbus, and I'm going to follow up with the airframe perspective on the route to 100% SAF. There we go. So it's already been mentioned that we're looking at both drop-in and non-drop-in SAF. So what are the differences between the two? Well, essentially with the drop-in SAF, that's an extension of the work that we've been doing over about the past 15 years. So since the introduction of Fischer-Tropsch fuels as blends with Jet A and Jet A1 and HEFA fuels, we've gained significant experience over the last decade and a half over about how these fuels work and what their impact is on airframe and engine operation. And with more and more fuel pathways becoming available, especially those with aromatics, it enables us to look at 100% drop-in fuel. So principally, with Jet A and Jet A1 fuels, there are aromatics present along with iso and normal paraffins, and those sort of give us what fits within our experience of jet fuels. So we know how those function on aircraft. We know what the limitations are, and it enables us to be able to use those fuels. So trying to replicate that with a 100% drop-in is activity that's going on now. There's a cross-industry task force looking at that, and data has been produced, and we're looking at how that functions on our aircraft. But moving forward, we need to look at other aspects, such as those external to the aircraft, such as the non-CO2 emissions impacts and various other aspects like that. So that sort of points us towards zero aromatic fuels and fuels that are predominantly isoparaffinic and normal paraffinic, so that we can have a fuel that hopefully has less non-CO2 emissions. So we need to look more in depth on that and what the particular emissions characteristics of those are, which I'll come on to. Okay, so when we look at non-drop-in fuels, there's a trade. We have to look at what platforms are available today, what fuel producers are producing fuels today, and what the volumes are, and what sort of fuels that they can produce that could potentially fit with a non-drop-in fuel. Alasdair already mentioned that the 100% non-drop-in fuel could essentially look like a HEFA fuel, and that's the ultimate goal, a zero aromatic fuel that is easy to produce, but it forms part of a trade. So we have to look at the compatibility with aircraft and engines. How far outside of our current experience is that, and is it sort of feasible to operate those on aircraft? Would those aircraft require modification? And what other aspects we would need to look at? Because it's not just about the usage of these fuels on aircraft, it's also the supply and production of them. So the feasibility to produce the volumes that would be required in the future, but also how that fits in with current refuel infrastructure. There's a very well-developed fuel supply infrastructure around the world. It's something that's evolved steadily over the past 50, 60, 70 years, and something that's well established. So if we were to introduce a new fuel grade, what sort of impact would that have? Would be able to supply it to airports? At the moment, we have just one single supply, essentially, so Jet A in North America and Jet A1 in Europe and elsewhere. So how would an additional fuel grade impact that? And that all forms part of the trade. But importantly, most of all, it's looking at the environmental impact. So we're doing testing, which I'll come on to on the next slide, where we look at what the composition of those fuels are and what the impact is on emissions, but also how that affects aircraft and its operation. Okay, so over the past few years, we've performed flight testing on A350 and A320 family aircraft, looking predominantly at the emissions characteristics of using zero aromatic fuels. We're working with DLR and others to look at essentially tailpipe emissions from our aircraft. So we have an aircraft following behind measuring emissions from our aircraft. So looking at soot emissions, particulates, and the potential for those to form contrails. And that's formed a part of the environmental work that we're doing, but it goes far deeper than that. Not only are we just looking at the emissions aspects through these flight tests, but a lot of work goes into the aircraft compatibility aspects as well. So we look at aircraft limitations. Are they limited by fuel viscosity, fuel volatility, and also altitude, and various other aspects like that to see how feasible it is to use such a fuel or such fuels on current aircraft. And all of that feeds into the work that we're doing, looking at 100% drop-in fuels and non-drop-in fuels, sorry. So, in the interest of time, I'll stop right there and hand over to my opposite number at Boeing, Jean-Philippe Bellier.
Yeah, so good afternoon, JP Bellier, Boeing. So Brian gave a very good keynote address and highlighted Boeing's strategy. So, and like my colleagues here mentioned it, we are on the technical side, so I'm going to focus on what us engineers do to make sure we meet the 2030 commitments that we made. And since I'm the last one speaking, I always finish by the conclusion slide, just in case. So basically, this is the state of play where we are now. We are doing a lot of gap analysis and testing in terms of material testing and fuel system testing. And for that, we developed some jet reference fuels, specifically two things. One is to standardize the testing, because we want to rely on our suppliers to be able to test materials and fuel systems the same way as we evaluate airplane compatibility. And also, we want to challenge this system and this material. So we develop this, depending on what material or what fuel system we are looking at, we are developing this reference fluid to be the most challenging. And that's because we don't want to constrain ourselves to drop in or non-drop in. We are in an evaluation phase. And the discussion about specification will come a little later. So, but I will highlight that in a slide, a schematic a little later. So like I mentioned, what we are focusing on, it's material compatibility, fuel and everything that is basically fuel system and everything that is touching fuel, basically, gauging system, pumps, anything. And of course, the main engine APU. And for that, we work with our partner, engine OEM and APU OEM. But the reason we are doing it this way is because we want to make sure we can enable the widest range of SAF. And we don't really know what it is. It's going to be now. I mean, we have a pretty good idea what it is now, but we are trying to think about what the future could be. So that's why it's important to test this way, in our opinion. And so to illustrate it, it's just a little schematic to try to understand what we are trying to do. So with this, I mean, if you're familiar with how things were done in this industry over the past 30, 40 years, a lot of testing was done, with a spec fuel like Jet A, Jet A1. There was no really challenges to go outside of the box per se. So the yellow box is what represents basically the intersection between all the industry, all the segment of that we are concerned with, like engine OEM, airframe OEM, and then we also have to think about infrastructure, delivery airports. So what we are trying to do, if you can see for Boeing, the green box, and again, it's a schematic, we are trying to challenge all our system and our material to understand really chemistry and physics of our limitation, basically. And so later on, so we can define the specification that protects this system, and that's a yellow box highlighted. So we work with our partner to ensure what are their limitations. And so you can see now the Jet A, Jet A1 is basically this yellow box. but there's no reason we cannot expand in for some properties. So, and when our legacy airplanes are out of service, you could expand the box without having to recertify necessarily the airplane, because we will have done the work beforehand and certified with more challenging fuel and have the data to prove that. So we hope that this way, if somebody comes with a great idea in a few years, we don't have to redo all this effort to evaluate everything. So I'm going back, so you can see I used some of Brian's slides as well, but you can see that Boeing was involved for the past 15, 16 years, not only on the technical side, but here I'm going to focus on a few aspects. And again, I highlight the first flight with Virgin, and then basically one of the last flights we did with them as well. So it's kind of nice to partner with Virgin on the first and last for now. But the reason I wanted to go back to this slide, Brian said something about we did a lot of work before SAF was sexy, or synthetic fuel was sexy, in his own words. That's true, and actually I would say that I'm actually very proud of Boeing, because part of me accepting the job in 2007 was because they were focusing on sustainability. From day one, focus from Boeing was working on sustainability, and we stayed true to that statement all the way to now. And so when we published the research report in 2011, so we promoted EFA, and we were a very big proponent of the EFA pathway. And so when we published the report to ASTM, actually, like Brian mentioned, I wrote that report and managed most of the testing that was done. And so one thing we did is include the data on 100% as well. So we did all the work. Most of the testing we did it with a 50%, up to 50% blends. But we kind of developed a motto within Boeing, is like, why stop at 50%, when it's only 50% of the solution? And so right away we decided to include the data on 100% to kind of give ourselves some published data per se that we could use along the way. And as soon as a specification, ASTM D7566 Annex 2 was approved, we actually quietly started to work on 100%. We did a lot of work. I saw Simon Blakely around here earlier today. So we contracted Sheffield University to do a lot of work on elastomeric compatibility. We did a lot of switch loading and basically tried to simulate life on an airplane for about 7 or 8 years. And the reason we did that is because you can see in 2018, we had the goal, we wanted to fly 100%. So we flew 100% paraffinic fuel, 100% EFA on a 777 freighter from FedEx. So yes, it was 100% EFA, no aromatics, all engine, all tanks. So we were so confident in our evaluation and systems that we went all in. And we flew that airplane for over 5 months. One of the center tank had the EFA, 100% paraffinic, 100% EFA for the entire duration of the campaign. And we had no issues. And in fact, as expected in terms of, so we had a significant decrease in the specific fuel consumption. So it was a very, very successful effort. And 2018, so already 100% EFA. And so from there, we kind of did a gap analysis, basically, and tried to look at everything we had to do to allow our airplane to be 100% SAF compatible by 2030. Note that we used a 777, and the reason is, so the fuel was actually a FR with a density of 760 kilogram per cubic meter. So the 777 has a gauging system that is ultrasonic based, so we didn't have the limitation of the capacitance-based gauging system that most airplanes have today. And then we went on to make many more demonstrations with customers on 100% SAF, United, so you all saw that, and then most recently Virgin. But note that Brian also mentioned our eco-demonstrator. So since 2012, this eco-demonstrator platform has been flown only on SAF blends or 100% SAF. And we also provide our customer with option to take delivery of the airplane with SAF blends, so we've been doing that for many, many years. What I didn't highlight on this slide is the amount of flight tests we did, whether it was military or commercial customer, just highlighted there. But where we are here, when we are here, so we do a lot of work with our colleagues, OEMs, and also suppliers. So when we say mobilizing partners, last year we had a conference basically where we invited all the suppliers because we actually share the same supplier. So we want to make sure we are all aligned because we don't want to have conflicting work being done and delays because we have very aggressive targets. So we thought it was very important to work with the whole industry basically. And through AIG, with the OEM, we are trying to work on going to a specification basically that could allow to promote the transition to 100% SAF. And with that, I think we're good. Pass it back to Joanna.
Well, thank you for that whistle-stop tour of what's going on with OEMs. We have now a period for questions, and I'm wondering whether we go first to anybody online. I think there should be somebody flagging any online interest. Who should I be looking to for the online stuff? Okay, well, they can chip in later on if they need to. So is there anybody in the room who's got a particular question? Or do I need to start off? I think, lady at the back. There's photographer. Okay, so it looks like you're all shy. You're all desperate to get back and see if you can catch a train. So I'm going to ask a general question to all of you, and you can answer it or pass it on to your neighbour. What do you see as the biggest opportunities with using 100% fuels, both drop-in and non-drop-in?
Yeah, I think there are opportunities around 100% drop-in and non-drop-in, certainly if I talk at an engine level. But we need to bear in mind, obviously, if you're talking about a drop-in 100% fuel, by definition, that is a fuel that's technically equivalent to a Jet A, Jet A1. So opportunities around things like improved thermal stability of sustainable components. You can't really take advantage of that from an engine design perspective because you have to consider one day the aircraft could pick up that 100% drop-in SAF, the next day it could pick up marginal quality fossil-derived jet. So that is a limitation. But in a situation where you went to say 100% non-drop-in and you've got aircraft that were dedicated specifically picking that up in a future scenario in say 20 years time, then there definitely are advantages in terms of how you design the heat management system of engines, taking advantage of those thermal capabilities. You can imagine, we use the fuel extensively as a heat exchange medium to transfer oil system heat. So there's opportunities there around numbers and size of heat exchangers and coolers, and you can imagine what that does as a kind of snowball effect in terms of engine level benefit. So they're the kind of things we can consider really.
Okay, from 100% drop-in perspective, would be pretty much analogous to what we have with conventional fuels today. Obviously, when it comes to emissions, there are potential gains there. It would help us to optimize fuel so the non-CO2 emissions and CO2 emissions are managed. But I think from a technical perspective, from my perspective at least, the focus on 100% non-drop-in is where we could have bigger gains, because when we look at aircraft compatibility today and how we design aircraft, they're designed to work with a range of fuels for which the properties fit within certain ranges. Now, when we look at non-drop-in fuels where, say, aromatics are removed, and that coupled with the different fuel production pathways that we have in different parts of the world, we could sort of leverage that and sort of look at the corners of the envelope, if you will, and design or potentially make changes or minor changes that would enable the aircraft to operate that, so we'd have far more flexibility in fuel supply, both with non-drop-in and with the ongoing use of conventional and 100% drop-in fuels as well. So I think it enables us to get to the corners of the box potentially, and the flexibility that that offers could be a game changer.
Yeah, so where do I start? So many things. The first thing will be emission, for sure. But then I look at, transitioning to more paraffinic fuel, a little less aromatic. I look at the energy content of the fuel. Cleaner fuel as well, so maintenance, on the maintenance side. So I expect to have less maintenance and higher reliability on the fuel systems. So that will be the major, actually, key point of transitioning to this type of fuels.
Anyone yet prepared to ask a question? Go at the back, please.
Chris Sim, Commercial Director at Zero Petroleum. So we talked about from the aircraft point of view, in the end could be compatible with both drop-in and non-drop-in. But then how about, could any of the panel give views in terms of upstream of that, so the fuel supply infrastructure? Particularly, there could be a transitionary period where there could be upstream fuel supply infrastructure, which is drop-in, and then some which is non-drop-in. I can imagine that there might be some challenges there. Could people offer some thoughts?
Yeah, I mean, you're correct, but I think, we are looking into it, and for instance, we have some conversation already with EI, the Energy Institute, because, right now we already have synthetic blending components, right, approved, and most of the time you bring that by truck and, blend at the airport or whatever. But if you want to increase the use of these SAF blends, we're going to have other solutions, or pipeline or so on. So I think we're already looking at the infrastructure for synthetic component, So I think it's good to have. We're trying to be all-inclusive, all the segment of the aviation industry, to make sure that there is no surprise, right? We don't want to come to the finish line and find out that we have a showstopper because we didn't think about that. So we're already trying to work with these segments.
Not much more to add to that, really, other than it does form a key part of our analysis of non-drop-in fuels in general. It's not just aircraft and engine compatibility, is how we get it to the aircraft as well. And as JP said, we're in discussions with wider industry to see how we can address that, and we're keeping them up to speed on what our technical perspective is. And moving forward, we hope to involve the fuel supply industry more in the discussion on how this can be implemented. Obviously, in some scenarios, when you look at, say, smaller airports that are refueled by Bowser only, it could be feasible. But when you get to the larger airports with integrated hydrant systems, that is something that would need a lot of thought, and that's something that we're taking into account now on how we can address that. Maybe in the future there is a switch over where infrastructure changes for hydrant systems isn't significant, but again, it forms part of a wider trade study and analysis that is still currently ongoing.
Yeah, the only thing I'd really concur with what these guys say. We shouldn't underestimate the challenge associated with bringing a non-drop-in solution to reality. There's a lot of effort going in within the OEMs around what a technical specification could and should look like to define a non-drop-in fuel, but the infrastructure challenges are quite significant, and I guess in my mind, it's not a done deal that it will manifest itself into reality. We need to just understand how practical that is.
Jonathan Wood from Neste. So is not the challenge how quickly can we move the non-drop-in to be drop-in? And what would it take to make that happen? Not just from a fuel supplier, producer, infrastructure point of view, but also from the aircraft point of view. I mean, what would it take to, not just from a new aircraft point of view, but from the existing aircraft population we've got out there, which is actually, as I understand it, the challenge rather than the new aircraft. What would it take to enable what currently is seen as a non-drop-in to be a drop-in fuel by, for example, doing a recall on the seals in the existing aircraft out there? A simple, non-technical, layman's type of idea. So in a nutshell, how feasible is it and how quickly can we move a non-drop-in solution to be a drop-in solution?
Well, it's very much dependent on the aircraft in question and also the engine as well. I mean, typically we find with newer aircraft platforms, their ability to deal with a range of different fuels is far better. The use of the types of elastomeric seals and various other materials like that on more modern aircraft are able to handle sort of varying and lower aromatic levels. And also the fuel itself, when we look at sort of synthetic and sustainable fuels in terms of their lubricating properties, for example, they're sort of far lower lubricating properties potentially than traditional fuels. And modern aircraft platforms are able to deal with that better, primarily through the advancement of materials over the years. Now, when it comes to older aircraft programs, it depends, like some fuel properties of non-drop-in fuels may be or overlap with sort of wide-cut fuels that were used many years ago, so it may be quite feasible on an older aircraft. But when we look at the materials compatibility, there may be some required change. So it's very much dependent on the particular platform that we're looking at as to the difficulty or in introducing those fuels onto those platforms.
Yeah, I guess the bit I'd add to that is, yeah, then we've done, as you know, Jonathan, we've done a lot of demos to demonstrate capability of certain engines and airframes, but ultimately if you were, yes, you could go in and do strategic seal changes and component changes, but ultimately you'd need to do a degree of engine and airframe recertification to underpin that, and that's where it gets difficult and expensive, because that, you know, you can't kind of, it's very difficult to put a box around it and say, oh, we're only going to think about that and that. You'd have to go and do, you know, ground testing, flight testing, etc., to prove that capability.
So just to close out, I mean, new airplane, yes, we definitely don't want the airplane to be a bottleneck. So that's why we're going to make sure they are 100% compatible. But to your question, if I look at material compatibility, sometimes I'm saying, yeah, you know, seal, we can change it. You know, we switch a NBR to a fluorosilicon or fluorocarbon. It's done. Now, where the issue is most legacy airplane with capacitance-based gauging system, for example. So that will mean a complete redesign of the gauging system. Software could be a solution, but then you have recertification. And so, as Alasdair mentioned it, that's... so I suppose anything is possible if you are willing to pay the price for it. But that's a conversation we are having now. We are going through an evaluation, and then we're going to do a backward compatibility to really understand what it takes. And maybe some of the solution will be acceptable, some may not. So we need to finish this evaluation first before we can make the call.
So one last chance for anybody online, I'm afraid. Yeah, I've got someone. I want to just check who's had. No, okay, no online. Okay, and do you want to go home today? Because I've got about 2 or 3 questions there potentially. Can somebody decide who stuck their hand up first over there and get a mic over to them?
Hello, I'm Richard Chaxfield from Billfinger. We're a construction company, so what we're talking about here is fairly far away from what we normally do. But I'm just wondering, obviously aeroplanes by their nature are designed to go to different countries. And they'll have a fuel over here and you'll fly over to France, America, Saudi Arabia, Egypt. What's the impact of all the different governments and regulatory regimes on this process? And How's it going to get sorted?
So, a good question. So, and I think we touched about it. You know, our goal is to be fuel agnostic, basically, right? To have aircraft and fuel system completely fuel agnostic. In terms of regulation, it depends of where your aircraft is built, basically, right? We OEM define what's acceptable or not, and we work with different countries to ensure that they follow our basically limitations. So we work closely, all of us, with ASTM and DEF10 which they are the two major specifications in the world. But we worked also with Chinese, and Russians to ensure that their specification match. But again, we define the limitation, so that's the way we control it.
I think just to add to that, in most locations around the world, current jet fuels are sort of broadly similar, and by that I mean that they fit within a box of properties that our aircraft are compatible with, and aviation is global in those terms. And I think you talked about sort of the regulatory aspects, and it's important to recognise that when it comes to fuel specification and the documents and standards that control those, that those are purely technical. Now, there may be other sustainability criteria that feed into how a fuel is produced and what it looks like, and that is to a large degree separate from the actual performance specification for the fuel itself. So I think in terms of 100% non-drop-in fuels in the future, as JP said, we define and work with industry to determine and set what those specifications are, and it would only be approved for use on aircraft if we're comfortable with it as a limitation. So I think it would have some impact, but ultimately we'd have a specification that industry would be able to work with and that would be compatible with our aircraft and engines.
Yeah, nothing to add really. I think the guys have covered it.
I think on that, I'm afraid I'm going to have to stop the questions because otherwise I'll be in big trouble with somebody around the corner there. This has been a useful session to winkle out elements of the 100% story. And I can only suggest that those of you who aren't already members of ASTM, consider joining if you want to be more active in the debate and to really ask all the nasty questions there. It is an ongoing debate, it is a discussion, nothing is fixed yet. We haven't told you about where the various specification changes have got in the process. I have to say 100% drop-in is moderately well advanced in terms of a specification draft. The non-drop-in one is still work in progress. So I'm sorry I have to sort of stop questions, but I think if you could prepare to hang around a few minutes, you might find the speakers are prepared to hang around too. And I think I will pass over to Michelle to finish up. Thank you very much.
Thank you very much, Joanna, and your team of panellists there. Thank you. It was a very insightful session. Well, that's a wrap. I can't believe that's gone by so quickly. 2 days on sustainable aviation fuel. So hopefully, given all those talks and things, you feel fully informed and ready to go, head full of stuff to go away and work on and ideas, and it stimulates ideas for you. So I guess in summary, what we've had over the 2 days, we started off with that scene setting. So what is the government policy within the UK? And we looked at also particularly around the world. So it's always important to benchmark. And then we got into sort of the technical developments as well. So hopefully over the 2 days, it's given you a really good overview of what some of the policy developments are, but also the technical developments that are happening. And I think what's I take away as well, it provides really good benchmark of what's happening at the moment. And it'll be really interesting to see as time goes on how that develops, how the industry develops, not just in the UK, but globally, and in terms of various policies and initiatives that are happening around the world. And because there's some very, very imminent deadlines, and we need to meet them. So I think we've all got a lot of work to do in the next few years. But I think it all sounds, from what I've heard, I don't know, you take away what you want from this conference, but I feel quite inspired and that we're on the right track and we're going to get there. So I'm just going to finish off and say thank you very much for everybody for joining us. Thank you everybody that joined online. Thank you very much to our sponsors, and thank you very much to our exhibitors as well. And I think the breadth and the brilliance, I should say, of the presentations and the panel discussions has been very, very good. So on that, Rachel will send out a feedback form. Please do give us feedback. We want to try and create these meetings that's going to be useful for you. So tell us what you'd like to see in the future, and that will be really, really helpful. The recordings, so this is obviously live stream, so it means you can go onto YouTube anytime you like and go and watch any of the sessions again or any of the ones that you've missed. So please look out for an email from Rachel on the recordings and also the feedback form as well. Have a really good, safe journey home. I hope you all do get home and no issues on trains or travel arrangements in such way. So if you'd like to join me in thanking all the speakers, and hopefully we'll see you again soon. Thank you.